Hello everyone. Today we will be learning Complete Core Java. Before we begin, I would like to tell you guys that we have daily updates on multiple technologies. If you are a tech geek in continuous hunt for latest technological trends, then consider getting subscribed to our YouTube channel and don't forget to hit that bell icon so that you can never miss an update from Simplilearn. So in this tutorial, Mr. Vikesh Pandey, our training expert with more than 12 successful years of real-time experience in software development, and along with that, he has an expertise in artificial intelligence and machine learning industry. So he will be helping you out in learning the fundamentals of Java with a detailed theoretical explanation along with practical examples so that you can have a better learning experience. Now, over to our training expert.
Hello guys, this is Vikesh and let's get started with the first topic of this series, which is about Introduction to Java. So when we talk about Java, it is one of the most popular programming language out there, and it was created way back in 1991, but it was publicly released only in 1995. It was developed by one of the famous developers of our generation, who is James Gosling at Sun Microsystems, and then later Java was acquired by Oracle, and today Oracle owns Java. Java is very simple and easy to use, and we will look at different aspects of how it is easy and simple to use. It's a write once, run anywhere type of programming language. Again, we will look at details into this particular concept as well. And when we talk about the usage of Java, you can use it to build web applications, mobile applications, desktop applications, even command line applications. And at the same time, you can also use it to build complex applications like gaming applications, building microservices, or building distributed computing, etc. Let's talk about the features of Java. So one of the most prominent features of Java is that it's an object-oriented programming language, which means that everything which happens in Java happens around objects. Objects enable the execution of the program. Objects talk to each other to exchange data and messages. We will look at the concept of objects in details in the upcoming lectures. It's a platform-independent language, which means that, again, going back to the previous point of write once, run anywhere, it basically enables the program to be run on any platform once compiled. So once you have prepared your program and you have compiled your program, then your compiled program can be run on any platform. It is a strong type checking language, which means that it will force you to respect the contracts of the variables to the data types. For example, if you have created a collection which should accept strings, then you can only insert strings in that collection, and it will not allow you to add a number or an integer into that collection. So it's a strongly type checking language. So when you run your program, it's a two-step process in Java. You compile the program and then you execute the program, which we also call as interpretation. So you have a Java compiler and you have a Java interpreter. You first compile your program and then you run the program using the help of Java interpreter. Java also provides automatic garbage collection. It's a really important feature. And if you talk about the languages prior to Java, like C or C++, they did not offer this capability. And this capability made Java really popular because it could automatically find the unused objects and variables and remove them from the memory to free up memory space for the program execution. It also provides multi-threading support, which means that you can build multi-threading applications like a gaming application. If you take the example of a racing game, for example, so there can be one thread which is monitoring your leaderboard score. There can be another thread which is displaying the speed of the car. There can be another thread which is displaying the graphic. There can be another thread which is displaying the sound. So you see all of these threads are working parallelly, and Java provides the support to create such applications using the multi-threading capability it has. Java is secure by default because there are no pointers in Java. So there are no possibilities of having any memory leaks or any reference leaks from the application. Again, if you take the example of programming languages like C or C++, you had the concept of pointers, and we witnessed a lot of scenarios and a lot of incidents where there was a memory leakage happening in the production application, which was really a bad experience for the organizations. So Java removed the concept of pointers totally from its programming language. It's also a very robust language because it provides a really great exception handling framework out of the box, which developers can use and implement to build really resilient applications. So now let us understand how a Java program is run. So at first you basically write your Java program and you store your Java program into a .java file. Then you compile your Java file with the help of the Java compiler. Once the program is compiled, the compiler is going to generate another file, which is a .class file. And this .class file is basically the compiled file, or also known as the bytecode file. So this bytecode or the .class file code can be run on any platform, be it a Linux platform or a Windows platform or a macOS platform or any other platform. To give you some more context, the first two steps where you write your Java program and you compile your Java program can be run on any machine. Let's take the example that you ran these two steps on a Windows machine. So you write your program and you compile your program on a Windows machine, which generated a .class file. Then you transported this .class file to a Linux machine and it also worked there. You transported your .class file to a macOS machine and it worked there as well. And that's what brings the platform independence concept of Java, that you can write the program once on any platform, and once you have the bytecode available, then you can run this program on any other platform of your choice. Okay, so that was about how the Java program execution works and how the platform independence is actually achieved. Now let us spend some time to understand the anatomy of Java. So once you download Java and install Java on your local machine, you will hear the term JDK. Actually, we'll see that in the next lecture, that when you try to download the Java, it will say JDK download. JDK stands for Java Development Kit. So the Java Development Kit is the installation of the Java. This is what you're going to install on your machine. Once the JDK or Java Development Kit has been installed, the JDK will provide a lot of other components as well, like Java Runtime Environment or JRE, Java Virtual Machine or JVM, some class libraries, and some other supporting libraries. So let us understand what happens when your program is run and how these components work together to make sure that your program runs as expected. Let's start from here. So you install JDK or the Java Development Kit, you write your program, and then you compile your program with the help of Java compiler, which is provided by JDK. Once the program is compiled, your .class file will be generated, and then you can run that .class file using JRE. In fact, if you just run your program on your local machine, JRE will automatically kick in and run your .class file. So the Java Runtime Environment or JRE runs your .class file with the help of these three components. Let's talk about first component, which is Java Virtual Machine or JVM. So the Java Virtual Machine is actually the virtual environment inside which your program runs. This is the real main environment inside your .class file is running. So when this program is running, how does it achieve this environment? For achieving this virtual machine environment, it would need some runtime libraries, and that is provided by these class libraries. For example, there would be a runtime jar or rt.jar as a shorthand, which will be supplied to the program at the runtime to make sure that the program runs smoothly. Then there are other supporting libraries as well, which your program may be using. For example, if this program, this .class file is, let's say, a calculator program, then it might be using a square root function from java.math package. So how does the java.math package get supplied at runtime? It would be supplied by the other supporting libraries which are present inside JRE. So JRE will make sure that your program runs inside the Java virtual machine. It gets the required runtime libraries, and it also gets the libraries which are referred in your program at runtime. And this all together will make sure that your program is running. So you can see JDK basically provides JRE automatically and JVM automatically, but you can also install JRE separately. If you talk about that use case where you compile your program on a Windows machine using JDK, and then you exported your .class file to another machine, and there you just installed the JRE. You don't install JDK there. You just install the runtime environment and you can run the .class file just using the runtime environment. And that brings us to the end of this lecture. Let's get started with installing Java. We will basically look at how we can install Java on a Windows machine. So the first step to install Java is to download it from the official Oracle website. So for that, let's open a web browser and let's type JDK Java download and hit enter. Then you need to find the link which says oracle.com, because like we discussed in the previous lecture, Java is owned by Oracle. So we need to download it from the official website only. So we can click on this link which says Java SE downloads. It will bring us to the downloads page and we will see different versions of Java. You can see the Java SE 15, you can see Java SE 14, you can also see Java SE 11 and all the previous versions. Another thing which you will notice that it says LTS here, which means long-term support. Basically, long-term support are the releases for which Oracle is going to provide long-term security patches and updates. For the non-LTS releases, Java will not provide long-term support and long-term patch fixes and long-term security fixes. So it's a good idea to analyze and evaluate on which version you want to develop your applications on. For this demo, I think it is fine. We can go with the non-LTS version. And even for your customer-facing applications, you can start with the non-LTS version and then upgrade to the latest LTS version whenever that is available. So for this demo, we can download Java SE 15, and you can also do the same on your machine. It will work exactly the same way as an LTS works. So you can click on the JDK download option here. Let's click on that. It is going to bring up the downloads detail page, and you can see there are multiple options given here in terms of what platform you want to install Java on, whether it is a Linux platform or it is a Mac OS machine or it is a Windows platform. So like I said in the beginning of the demo, that today we are going to see how we can install this on a Windows machine. So I'm going to download the Windows x64 installer here. If you are working on a Linux machine or a Mac OS machine, you can download those respective installers as well. So you can see the exe here. So let's click on this. Once we click on this, we'll get this pop-up, which will ask us to accept the Oracle Technology Network License Agreement. So we can hit this checkbox and click on Download JDK 15. And this shall start the download, and you will see some exe getting downloaded in your download box here. But as the download is going to take some time, and I'm not going to wait for that. And that's the reason I have already downloaded the JDK 15 for this particular demo. And that JDK is sitting here on my desktop, which I've downloaded prior to this demo. So we'll just run this particular exe, which is exactly the same exe as the one which is being downloaded. So let us double click on this. It will ask you for this pop-up in some cases. So you can just hit yes. Basically, it is asking whether you trust this exe or not. But as we downloaded this from official Oracle website, then we can trust this particular exe. So I will hit yes. And now the installer is going to unpack, and you might get a screen like this, which will be an installation wizard for the Java SE Development Kit 15. Another thing which, before I proceed, I just wanted to highlight that as well, that you might have noticed the word JDK here. It's exactly the same term which we covered in the last lecture, that when you install Java, you basically install the JDK, which is the Java Development Kit. And this is also visible here when it says Java SE Development Kit 15. So let's hit next. Then on this particular page, you have the option to change the installation location of Java if you want to. By default, it is going to install in C program files /java/jdk15. But if you want to change the location and you want to install Java to a particular custom location of your choice, that is also possible. You just hit change here, and then you can choose whatever directory or folder or place you want to install this Java on, and you can basically select the appropriate location. For this particular case, I don't want to change that. I'm happy with the default location, which is available here. So I'm just going to proceed with this particular location here. So I will just hit next. and then Java is going to install. And it's very fast installation. It generally takes few seconds, as you will see in this demo. Basically, it is going to unpack all the libraries and all the runtime libraries and all the class path libraries which we discussed in the previous lecture, and put all that into the location which we specified to install Java. It will also set up the rest of the prerequisites which are required to run Java successfully. So looks like the Java has been successfully installed, as is visible in this message. And there's also a next step if you want to access the tutorials or the API documentations, the developer guides, the release notes, etc. I don't want to do that, so I will just hit close here. And now if we want to just verify if Java is installed or not, then we can verify that from the command line prompt. Let me just exit this, and let's go to the command prompt to verify to see if Java has been successfully installed. So to do that, we'll just open the search bar and we'll type cmd. It is going to show us this command prompt here. We'll click on this and it will open the command prompt for you like it has opened for me. And there you just need to type Java-version and you hit enter. If you get a message like this, it means Java has been successfully installed. If you get a message saying that Java is not recognized as a command, it means that Java is still not successfully installed and something has gone wrong in your installation. And in that case, you might want to restart. You might want to go back and reinstall this Java exe again. So in this case, it looks like it has been successfully installed. And we can also get some interesting information from here. We can see which version of Java has been installed. It says Java version 15. We can also see that the JRE is also installed. The Java SE Runtime Environment, or JRE, is also installed. And we can also see that the JVM is also installed, which is Java Hotspot Server VM. VM means the virtual machine. So if I connect this back to the previous lecture, we can see that the Java JDK basically installed the JRE as well as the JVM as well. And the complete Java package has been successfully installed. Now we are ready to use Java, a Java program, and run Java programs on this machine. And at this step, I would like to conclude this lecture. In the next session, we will be discussing how we can install Eclipse, because that would be the natural next step for any Java developer, that they want to install Java and then they want to install Eclipse and start working. Let's get started with installing Eclipse on a Windows machine. So the first thing which we need to do is to download Eclipse. So for that, I'm just going to open my web browser and type Eclipse download, press enter. And then you need to find the link which says eclipse.org/downloads, which is the first link in my search results. You can also see it says Eclipse downloads, the Eclipse Foundation. And Eclipse Foundation is the organization which maintains the Eclipse installers. So we can click on this. Once we click on this, we will be redirected onto the Eclipse downloads page. And there again, you will see a bunch of options. You will see the default option highlighted, which would be the Eclipse installer for JRE, for Mac OS, Windows, and Linux. And then you have some other tool platforms option as well, like Eclipse G or Orion, which you might want to use for advanced cases. But for running Java applications, all you need is an Eclipse installer, which is coming from here. So based on your machine, Eclipse will automatically detect whether you want a 64-bit installer or a 32-bit installer. And you can just click on this particular link, which says download 64-bit here. So I'm just going to hit download 64-bit. It is going to open this particular screen where, based on your current location, Eclipse will suggest the nearest possible distribution mirror. Distribution mirror is basically a server which is present somewhere in this world, which contains this Eclipse installer exe. And Eclipse has created these servers all across the globes. These servers are basically called the mirrors. And based on your current location, which will be taken from your ISP, from the internet IP address from which you are accessing this particular website. So based on your ISP location, it is going to suggest you the nearest possible mirror location so that your download is the fastest. So in my case, the nearest location is Netherlands here, as you can see. And I get a download option. This is the file name, which says Eclipse installer JRE Windows 64.exe. And if you think that this mirror doesn't make sense, just click on this option, select another mirror, and then you can choose another mirror. But generally it works really well. It works based on your IP location, and it's generally the download speed is pretty good based on the suggested mirror. So I'm not going to change the mirror location because I think this works fine for me. So, and I'm just going to click on this particular button, which is going to start the download of the Eclipse installer. So now I have hit the download button, and you can see right now an exe has begun to download. It is going to again take some time, and I have already downloaded this particular exe just to save us some time, and I'm going to use that exe to showcase how we can install it. Another thing just wanted to highlight is that Eclipse is an open source organization. It works on donations. So if you feel generous about it, and if you feel that Eclipse is doing really great work, you can also donate to it, which will show here. So we can move to the next step, which is about installing. So you can see here, I have an installer here, an exe file basically, which I have pre-downloaded to showcase this demo. I'm just going to double click on this, and it is going to unpack the installer. You can see this icon will be presented to you, which says Eclipse installer by Oomph. Oomph is basically the provider for this particular installer who manages the installer. And based on your computer's capacity and speed, it is going to take few seconds. And in the background, what it is doing is basically it is unpacking this installer and creating all the installation files which it needs to successfully install it on your computer. Once that is done, you will be presented with this kind of screen, and you will see that Eclipse provides multiple different kind of IDEs for different set of developer communities. You will see an option which says Eclipse IDE for Java developers. You will also see Eclipse IDE for enterprise Java developers. You will see the IDE for C++ and C developers, web and JavaScript, PHP, Eclipse committers who basically contribute to the Eclipse organization, or RCP, RAP, tester, scientific computing. There are tons of IDEs which Eclipse maintains. For our use case throughout this series, I think we will be focusing on this particular IDE, which says Eclipse IDE for enterprise Java developers. You can also use this particular IDE, but this is a very bare bone IDE with very limited set of integrations. Like it says, it includes a Java IDE, a Git client, an XML editor, a Maven plugin, and a Gradle plugin. But if you look at the enterprise, you will get more integrations. You can use this particular IDE to work on whatever you work here. So these all will work here. But in addition, you can also use this IDE to build a web application, build a web service, build a JPA application, data tools, Java server pages, faces, etc. So this is more advanced, I would say. And we will go with this particular IDE. And you can also choose this IDE if you want to, but for this demo, we are going to choose this one. I will click on this. Then it is going to show me which virtual machine it is going to use. So if you remember in the previous lecture, we installed Java 15. It has automatically detected that location by reading my C program files folder, and it has automatically taken that. If you have multiple JDK installations on your machine, you can click on this icon and change a different Java virtual machine. I'm going to leave it as is. Again, the installation folder is also by default taken to your C users username /eclipse/ the JEE version number. And again, if you want to change this, you can also change a different installation folder. I'm going to leave everything as default. It will automatically create a start menu entry and a desktop shortcut. And now I hit install. It might come ask you for a user agreement. So you can hit accept now. And now it has begun the installation. The installation generally takes a bit of time to complete in some cases. So again, it depends upon your computer's capacity and speed. Basically, if it's a good robust machine with good capacity, the installation might be very fast, as you can see in my computer. And if you have a computer which is not very strong on configurations, you can just be patient and wait for some time, and the installation will be finished. Once the installation is finished, you will see this launch option here. You will also have an option to keep an installer if you want to, show the README file. But I think the main option here, which we are going to use, is the launch option. So if you hit the launch option, now the actual IDE is going to start up. It's again going to set up some configuration files and some bootstrap configuration files, which it needs to. And then it will ask you to choose a workspace. Again, the workspace is up to you. Where do you want to create your workspace? The workspace is basically the location where you will create your projects. It will store those project files and the source code of those projects. So it is up to you where you want to create it. Again, I'm going to leave it as default here, but if you want to change it, just hit browse here and choose whatever location you want to. You can see, you can choose, you can go to PC and you can choose whatever location you want to. I'm going to leave it as is. And you also have a choice that you don't want Eclipse to ask this every time. So you can check this box, and next time Eclipse is not going to ask you to choose a directory as workspace. And every time you start Eclipse, it will automatically go to this particular directory. So you can either check it or uncheck it based on your convenience and hit launch. Once you hit launch, it is going to start the actual IDE as a desktop application, and you will get a nice interface and a welcome screen from Eclipse, which will basically show the basic overview of the screen, something like this. So now you can see that the Eclipse IDE has started. It has a welcome page, which has multiple options. You can check out a project from Git. You can import an existing project. You can go to the marketplace, create a Java web project or whatever, or you can just close this. You have a nice navigation project explorer bar here. So all the projects which you're going to create will be listed here. There are also some quick shortcuts here for creating different kind of projects. And if you don't want to use that, just go to File, New, and choose a kind of project you want to create, whether it is a Maven project or enterprise application project or dynamic web project or just a project. If you just hit just a project, you can choose a basic Java project to start with, click Next, give a project name. Let's call it test demo. You can choose an execution environment here, the JRE, and currently this particular IDE has support up to 14, but I think this is going to work fine. We don't need to worry about it. We can also use a project specific JRE, like in this case, Java 15, which is the current installation. So I can use this option because I want to use Java 15 environment because I have Java 15 installed. So you can basically choose whatever option you want to choose. It gives you a flexibility in terms of choosing the JRE, whether you want to choose an external JRE, whether you want to choose a project specific JRE, or you want to use the default GRE JDK installation. So you can use this option as well if you want to. Project layout is either you want to create separate folders for source and classes, or you want to create the use the project folder. Again, these are just basic configurations which you can play around with if you want to. I'm just going to leave it as is and hit next. And then it is going to just give me a review screen here. If I want to change anything, I can. Otherwise, I can just hit finish. I can create a module name here if I want to, but I don't want to create it. So I just hit on don't create and open the Java perspective. And that's it. You have a Java project here where you can create your Java files under this SRC, and you can start executing those files. We will look out on those details in the upcoming lectures. But for this lecture, I think this is what we wanted to achieve. We wanted to show how we can install Eclipse and how we can create a very sample Java CLI project. So this is it for this session. In the next session, we will look at some of the data types in Java. Let's get started with primitive data types in Java. We are going to learn about the primitive data types in Java, and we'll also see a short demonstration of it. So let's get started. Let's first just learn about those data types. I've just opened the official Oracle documentation. And don't worry, if you see how this link appears here, you can just open a browser window and just type Java primitive data types. And if you hit enter, the first link which you will be given is this particular link. And this is the same link which I have opened. So let's learn about the data types now. So Java has these primitive data types, which you can see here. Some of them store numbers, some of them store Boolean values, and some of them store characters. So the data types which store numbers are byte, short, int, long, float, and double. These 6 data types basically are used to store any kind of numeric value. Let's understand these a bit more. Byte is the shortest possible data type value which you can use in Java to store numbers. You can only store numbers within the range of -128 to +127. So you can see the range is very small, and Java has created this variable for use cases where you want to store numbers which have very small value in this range. Why do we provide these kind of options? Just to save memory, because the smaller data type will require less memory to be used in the Java program. Similarly, the next bigger data type is short, which is a bit bigger than byte. And the range of this particular data type variables will range from -32678 to 32767. So that is the range for this particular variable. And you can see that it has a very big range as compared to the byte data type. So if you want to store values which lie in this range, you can use short. The next one is int data type. You can use this one to store even larger values, which range from minus 2 raised to power 31 to plus 2 raised to power 31 minus 1. The next one is long, which is even bigger than int, and it can be used to store the values within the range of minus 2 raised to power 63 to plus 2 raised to power 63 minus 1. So as you can see, as we go from top to bottom, from byte to long, the size of the value which can be stored using this data type increases. And that's how you will basically take a decision of whether you want to use byte or you want to use short or int or long, based on what size of the value that variable is going to contain. Then the next ones are float and double. These two have been created for the use cases where you want to store the values, numeric values, which have decimals, which are precision values. I should also mention that byte, short, int, and long are only used for storing absolute numbers which do not have any decimal representation. Even if you try to store a decimal value in these variables, they will automatically be trimmed. The decimal values will automatically be removed, and you will only be shown the absolute values. And in case of float and double, they can maintain those precision and decimal values. So we use float for the use cases where you want to store decimal representations of the values. And you can see that the float value can store a smaller precision value, but double can store even a bigger precision value. So if you have really big precision values to be maintained, very big decimal values to be maintained, you should use double. And the float is used for storing a bit smaller size of the precision values. I mean, its range of values basically beyond the scope of this discussion. If you want to read more about this, you can go to these particular links, which will explain this in detail. But the basic idea is that float is good for storing two precision values. And if you want to go beyond that, you want to use double. In some cases, some people also use float to store even beyond two values as well. So it completely depends. The decision factor is how long the value you are going to store in the decimal. And that will decide whether you want to use float or double. The next one is Boolean, which is used for storing the Boolean values. Boolean values can be either true or false. So there are only two possible values. And then we have char, which is used for storing characters. It is using 16-bit to store the value. And this is a very popular Java question for beginner level programmers, that why does it need 16-bit to store the character? It's because it stores a Unicode representation. Unicode representation is the representation which can be accepted across platforms across the world in different character encodings. So let's move on to Eclipse now, where I have prepared a very short and simple demo. I'm just creating a variable for each data type and I'm printing them. You also see some things here like these keywords, and don't worry about these keywords. I will cover these keywords in detail in the upcoming lectures. You also see this, and you can just, for now, you can remember that system.out.println is used for printing anything in Java. Anything you want to print on the console, you would be using system.out.println. What is system, what is out, and what is println? Again, we will cover these in the upcoming lectures. For now, I'm just creating a bunch of data types here, variables here basically. I'm creating a char type variable, a byte type variable, a short type variable, an int type variable, a float type variable, a double, and a Boolean. The way you create variables is basically you put the data type name, you put the variable name, which can be anything, you put an equal sign, and you put the value, actual value which this variable is going to store. And I've done the similar thing for all of these variables. Java wants semicolons to be there when you write your statements. So please remember that your statements always end with semicolons. So I've declared all of these variables here, a byte, a short, an int, float, double, and Boolean. And then I'm printing all of them basically. Here I'm printing the char variable. Here I'm printing the byte variable. Here I'm printing the short, and so on and so forth. So how do we actually run this application or this program? You just double click on this or right click on this. You go to this run as option. You see this run as Java application option. So you can hit this option. It will run the application and it will present all the output here in the console tab. Let me just bring this up. So you can see all the variables have been printed here, and this is coming from these print statements. Like I said, this is used, system.out.println is used to basically print anything. And I've used that to print all the variables here. First, I'm printing the char variable whose value is A. Then I'm using the byte variable, which is denoted by B and whose value is 2. So you can see the value is 2 here. Then I'm printing the third variable, which is C, which is a short type variable, which has a value 22. You can see short, and this is coming here. The next print statement is int. So you can see int here with the value 45, and this value is coming from here. Then we have float. You can see the float value being printed here, and you can see the float value declared here. You also see an F here, and this is the standard naming convention which Java proposes, that whenever you declare float and double, you end them with F or D based on whether it is float or it is double. Then you see the double value, which is having a bigger precision than float. So I've printed the double value using this particular print statement, which is printed here. And then we have the Boolean value, which is stored as G, and the value of G is true, and the same value is printed here. So whatever I write here basically is printed here. This is just a placeholder, and this is the actual value. So you can see that we are able to use all the variables here, all the primitive variables basically, which range from byte, character, byte, short, int, float, double, and Boolean. And that's it for this session. In the next session, we will be discussing about the non-primitive data types in Java. Let's get started with non-primitive data types in Java. In the previous lecture, we talked about the primitive data types, and now we'll discuss about some of the data types which are not primitive. First of all, let's understand what is the difference between primitive and non-primitive. So the primitive data types are the ones which are by default supported by Java, and non-primitives are the ones which are a bit custom in nature, where you as developer have the liberty to define the nature of that data type. We'll look at some examples of that as well. But when we talk about which all are the non-primitive data types, we broadly talk about arrays, we talk about classes, we talk about strings as well. And we will cover some of them in today's lecture. And we have a detailed lecture upcoming about the classes as well. In fact, after a few lectures, we'll cover how we'll create classes as well. But for today's lecture, we are going to focus on string data type and array data type. And like I said, for classes, we have a dedicated lecture upcoming. So don't worry about that. And again, for this particular case as well, I have already prepared a demo for this, and we'll basically do some look at some hands-on examples to see how do we create these variables, what does these variables mean. And the first non-primitive data type we are going to talk about is string. And before I go on further, I should also mention that it's very debatable in the Java community to call string as a non-primitive data type. And actually, technically speaking, string is a special data type. It neither fully lies in the primitive category, nor it fully lies in the non-primitive categories. I'm covering this as a non-primitive data type because it's a bit inclined towards the non-primitive category. Why do we do this? Is because Java does provide native support for string handling in the JDK. And that's the reason some of the developers feel that string is a primitive data type, which is primitively supported by Java. But at the same time, string is so customizable and it's so special in nature. It's the way it stores the value, the way it provides the operations and handlings. It's so different than primitive data types that it cannot fully be put in the same bucket as the primitive data types. So that's why I said it's a special data type, a bit inclined towards the non-primitive category. So what is string basically? We covered about the char data type in the previous lecture. And in char data type, you can only store a single character, right? But if you want to store a complete name of somebody, then it's a list of characters. It's basically a lot of characters together. Then in that case, you would need a data type to store that continuous sequence of characters. And that's what string does. String can store a continuous sequence of characters. Technically, string is basically a character array. You can call string as a character array. And don't worry if you don't understand about the word array. I will explain that in the same lecture. So basically it stores the continuous sequence of characters. That's how we define string. And you see this string, this is basically the keyword, the data type basically in Java. So whenever you want to create a string, you need to write string with S capital. You need to give a name to the string. This can be anything. And then you can provide the value, which this particular string is going to contain. So you can see this is a continuous sequence of characters. TEST are the 4 characters which this string is going to contain. And after that, again, I'm printing this particular value. And like I said, don't worry about this. We'll cover this when we'll write our first program in Java. So this is just to print the string value. I'm just putting a string placeholder here, and then I'm actually printing the values of the string variable. Now, string can be created in multiple ways in Java. This is one way of creating it. There's another way of creating a string variable, which is this one, which says, again, the string, data type, some variable name, a keyword called new. Again, don't worry about what is this new keyword. We'll cover this when we'll talk about running our first program in Java and writing the first program from scratch. Then we again say string, and then we provide the value. So if I compare this line number 4 to line number 7, you can see the difference is that I'm still storing the same value, test, but the difference is that here there is no new string keyword, but here we have this new string keyword. So what is the difference? The difference is this, that in this case, in this particular case, string is going to reuse the same object multiple times. But in this case, every time you call this, it is going to create a new object. Again, what is object? It's just, you can think of it as, for now, you can think of it as a memory block. We'll again cover objects in details. But these are 2 different ways in which you can create string. This is generally the most popular way of doing it because this is memory efficient, because you can reuse the same variable again and again. So I'm creating the string variable here and creating another string variable str1 here and printing both of them. Then I've created this strange looking thing here, which is basically an array. Array, like I said, is also a non-primitive data type in Java, and array can store a continuous sequence of anything. That anything can be a number, that anything can be characters, that anything can be a floating number as well. So basic idea is that if you want to store a collection or a sequence of multiple values, how do you do that? You do that with the help of arrays. Array is a data structure, a non-primitive data structure in Java, which can store lot of values of similar type. We also call it as homogeneous data structure, because it can only store same data type values or homogeneous data type values. So the biggest way to identify array is this square bracket. Whenever you see this square bracket in Java, it means it's an array variable. So here I am creating an integer array variable with the name ARR. This is the name of this particular array. It is only going to store integer values because I've specified int. And the moment I provide the square brackets, it means that it is an array. So you can declare an array like this, and then you need to assign a size to the array. Size is basically denoting how many values this data structure is going to store. So I'm saying new, again, it's a keyword, and I'm saying that, okay, create a memory block for storing 2 integers. So this particular array ARR can store at max 2 values at continuous locations. The next thing about array is that it stores the value in a 0 index based location. So like I said, it can store 2 values. So the first location will always be array of 0. And this is how you specify the location or index of the element which is going to be stored. So at the 0th location of this array, I'm storing 0. The first location of the array, I'm storing 1. And this is just to show an error scenario, but I will just comment this for now. You can just put double slashes and comment any line. So I'm just storing, filling up this array for 2 values, and the 2 values location would be 0 index and first index. These are just continuous memory locations, and we denote those memory locations as 0 and 1. Array indexes always start with 0, and I'm just putting some values here. You can put any values. And then I'm printing the whole array, and I'm also printing the first value of the array. And we'll see how this pans out, and we'll also see how we can change this. So now we are going to run this application. So I'll just go to Run As and click on Run As Java application. And once I hit that, I get this output here. So let's understand this output. The first one is I'm just printing the string, which has the value test. And you can see it has printed here. It is coming from this line. Then the next line which is printed is line number 8, where I'm saying another string str1. And str1 also had the same value. So you can see another string has the same value. And then I have printed the array here, the complete array. And you see this strange value here. It also tells us that if you want to print the array, then you cannot just put the variable name and print it. The reason is because this is a non-primitive data type. And once you do this, it is basically printing the memory footprint of this array, the whole memory location where this array is stored. That's why you see this strange looking number, which is the memory hash code. And if you want to print any particular value or any particular element inside this array, then you can do that by providing the index location of that element. So here I've said that print the 0th location element of the array. The 0th location array element of the array was 0. So you can see the value 0 here. Let me put some other value just for fun and show you how this works. So I've just changed the values. And now let's see what do we get for array 0. You can see now I get value 3 because now at the 0th location, the 3 value is being stored, and that is what is being printed here. We can also print the first value. I'll just go Run As Java application. You can see now the array of first index is being stored, which is basically technically the second element of the array. But because array always works on a 0 index based value format, that's why when we say array 1, the second element is printed. When I say array 0, the first element is printed. So always remember that array is a 0 index based collection or data structure basically. What happens if I do this? Now there is no third element in this array because the array has the size only of 2 elements. And when I say ARR of 2, which means I'm trying to print the third element in this array, which does not exist. So let's see what happens in that case. I get an exception. Exception is basically an error. I get an error saying that index 2 is out of bounds for length 2. It means that the array length was actually 2 and index 2 does not exist. Remember, it's saying index 2, not the element 2. Index 2 doesn't exist because only index 0 and index 1 exist. This makes 2 elements and the actual size is also 2. It does not have capacity to store third element. It does not have third element location anywhere. That's why it complains that you are trying to print a non-existing value. So this is where I would like to conclude my lecture about the non-primitive data types. So we covered about string, we covered arrays, and like I said, we'll cover classes in the upcoming lecture as well. In the next session, we are going to talk about tokens in Java.
Let's get started with tokens in Java. When we talk about tokens in Java, these tokens are basically some reserved expressions or words or symbols which have a predefined meaning in Java. And you cannot override this meaning because this meaning is already defined by Java, and you can use those expressions, those symbols, and those words in only the way Java wants you to. There is no way you can change the meaning of those terms or those symbols. So we will be covering those tokens in today's lecture. These tokens are broadly divided into 5 different categories. These categories are keywords, identifiers, constants, special symbols, and operators. So let's talk about each of them one by one. So when we talk about keywords, these are the words which are reserved by Java and they have a predefined meaning. You might have already seen some of these reserved keywords. For example, we have used int when we were working on the primitive data type lecture. We have seen this as well, though we haven't actually found out the meaning of this, but we will find out the meaning of this in the coming lectures. So don't worry about that. We have seen Boolean as a data type again. We have seen byte. So these Boolean, byte, int, class, char, catch, super, switch, synchronized, all the keywords which you see here, these keywords have a predefined meaning in Java. And you use these keywords so that you want to take an action, an expected action by Java. For example, if you call something as int, then you want Java to treat it as int. int will only have a single meaning in Java, and there is no other meaning of int in a Java program. So that's the intent with the keywords. These are reserved words which have a predefined meaning, and we will cover these keywords at length during this whole course. The next token is identifier, and identifier is nothing but just a variable name technically, and we have already covered this kind of identifier when we were showing the demonstrations for primitive data types and non-primitive data types, etc. It's basically anything which you declare as a variable is an identifier. And when you declare the variable name, again Java puts some sort of restrictions as to what you can or cannot do when you work with Java and you declare the variable names. For example, these variable names cannot start with numbers. So you cannot have a variable name which starts with any number. You cannot have a variable name which contains spaces in between them. You either have to fill those if there's a variable name which you think has two parts, for example student name, then you need to write it as student underscore name so that you can create the variable name with the same impact and still does not contain space. So spaces will not be allowed when you create the variable names. Similarly, you cannot have plus, hyphen and ampersand in the variable names as well. These are the restrictions which Java puts on the identifier tokens whenever you create identifiers. The next one is constants, and we will cover these constants in detail in the coming lectures as well. But to give you an idea of what constants are, so constants are basically exactly what they sound like. They are the identifiers which you have declared in your program whose value cannot be changed once defined. So if you write something as final int I equal to 5, then this value is fixed. You cannot change the value of I again in the program. Java will not allow you to change the value of I again because I has now become a constant because you have put a final keyword in front of it. And again, final is a keyword, you see, final is a keyword basically. So these constants are treated specially by Java, that Java will make sure that their values will never change during the course of the execution of the program. These can come really handy when you have situations where you do not want the certain variables values to be modified. For example, if you have an application where you are counting the number of applicants, and if you have declared the number of applicants as final, then every time you call the application, you can do a +1 to the previous value. The value will not be reinitiated. So it is very useful concept, and it can be very handy in programs where you don't want to change the values. The next is special symbols. These special symbols are the symbols which again have a predefined meaning in Java. We have already seen this square bracket symbol in our previous lecture when we were creating arrays. So whenever you use these square brackets, then Java would understand that you are trying to either access or create an array, or you are trying to access or create a list, etc. So this is predefined. You cannot use this anywhere else or with any other meaning. Similarly, when we talk about these braces, these standard brackets or standard braces, these again have a predefined meaning in Java. Generally, whenever you will write functions and methods in Java, you will use these brackets to define the parameters of the function. Now you cannot use these brackets in any other meaning in Java. Java will not allow you to use this anywhere else apart from using it in method parameters. Similarly, the next one is the curly braces, and the curly braces are used to define a code block in Java. You might have already noticed that when we were looking at the previous demos, you could see some curly braces, then some code, and then the curly braces would end. For example, if I show you here, it's just a sample example, and let me open the example which we covered in the last lecture. So you can see this curly brace here, and this curly brace ends here, right? So this defines a code block in Java. Any code block which you want Java to understand will always be starting with the curly braces and ending with a curly brace. Remember I talked about the standard braces. You can see these are the standard braces opening and ending, and this is where we are defining this particular method's arguments. Now what is method, what is argument? Don't worry about that. We will cover in detail, but just an introductory concept. Whenever you are trying to define a method and you want to pass any argument to the method, you use these brackets to do that. Okay. Similarly, this is semicolon is used to close any Java statement. So you will see this semicolon here. Every Java statement has to have a semicolon as ending, otherwise Java will complain that it is a syntactical error. So it is part of the syntax. You need to put the semicolon, and semicolon has only one meaning in Java, which is that your statement is actually ending. Then we have star, and star is used for multiplication, and then we have equality, which is used for assigning any values. And again, assigning any values is everywhere. You are seeing this equality sign everywhere. So these are all tokens basically. The last type of token we have is operators, and we will cover these operators in the upcoming lectures in detail with the examples. But these operators are basically some special symbols, like for arithmetic it would be plus, minus, multiplication, divide. For comparison it will be greater than, less than. For logical it would be ampersand and pipe operators. Bitwise again will have some bitwise operators. So these are basically different categories of operators. And under each category of operators, there are certain symbols. Like for arithmetic, we have plus, minus, we have for comparison, we have greater than, less than, etc. So these again symbols are also reserved by Java under the operators tokens category. You cannot use these in any other meaning or in any other way. And like I said, we will look at a detailed example of this as well in the coming lectures. So this was a quick overview of what are different types of tokens in Java. So we have keywords, we have identifiers, constants, special symbols, and operators. So this is it. This is all what I wanted to cover in today's lecture. And in the next session, we will be looking at data type conversions. Let's get started with data type conversions. So when we talk about data type conversion, the whole idea is to basically answer the question that whether I can convert a int data type variable into a long data type variable, or a long data type variable to a float data type variable, and also vice versa. Can I go back? Can I convert a float variable into a long variable or an int variable, and vice versa? So this lecture is about answering all of those questions. And we will basically look at some examples to understand how the conversion works. But let me just explain the basic principle. The basic principle is that smaller box can fit into larger box, but if we have to fit a larger box into a smaller box, you need to do something else. So what do we mean by smaller box and larger box here? The smaller box is a variable or a data type which has a smaller range. If you remember, we talked about the range of short, byte, int, etc. And we could see that as we go from short to byte to int to long to float to double, the ranges were increasing, right? So we will follow the same kind of analogy, that if we have to store a smaller range variable into a larger range variable, Java will automatically do that. But if I have to store a larger range variable into a smaller range variable, then I have to sacrifice some quality of the value. And we will look at the examples of that as well. So let's first look at the example where we can store a smaller range variable into a larger range variable. We call this as implicit data type conversion. So here you can see I have declared an int variable with the value 100, and I'm printing the int variable. Then I have declared a long variable, and what I'm doing that I'm assigning the value of int a to the long variable b. So I'm not assigning a new value to this long variable, but rather I'm just passing on the existing integer value into a variable of type long. Similarly, after that, I am taking the value of this variable of long type and storing this value into a float type. So you can see int is basically smaller than long, and long has a smaller range than float. So I'm just storing a smaller range variable into a larger range, and then a larger range variable into the largest range. And then I'm printing all the variables values to see if this actually is working. Can long automatically store the value of a, and can float automatically store the value of b? Here I'm just printing the variables, and again using the concept of the previous lecture, this is just to print the values, and I will cover this in detail in the next lectures of how this works. But here you can understand that we can use system.out.println to basically print the values. And here I'm just printing a string, and then the value. Then again the string and the value, and here also the string and the value. So this is what is happening in this program. And again, don't worry about these details. I will cover about what these concepts are in the upcoming lectures. So let's run this and see if the data type conversion actually works. So I will just right click and do run as and go to Java application. And if I click on this, I get this output. So the first output is pretty straightforward. I'm just printing the int variable as is. So this works. Then I am storing the int into a long and printing the long representation of a, which is b basically. And this also works without any errors or any warnings by Java. Similarly, when I talk about storing the long variable into a float variable c, this also works. But here you see an additional decimal precision here, because as we remember from the previous sessions, float is used to store values which have decimals or which have precisions. So it will automatically convert your absolute number into a number which has decimals whenever you try to cast this into float. Casting is also a word which is used. Some people call it as implicit data type conversion. Some people call it as implicit data type casting. So if you hear the word data type casting or implicit data type casting, you can think that it is exactly the same concept as data type conversion. So this is about implicit data type conversion. Now let's look at an example of explicit data type conversion. How does that work? So using the same analogy of the boxes, now I will try to store a larger ranging value variable into a smaller range variable and see how that looks like. So I will start with the largest, which is double variable. So I have created a double variable, and as we know that double is a variable which is used to store decimal values. So I'm storing this value here, and then I'm just printing the double representation as is without any changes. Then I'm trying to store this variable's value into a float variable. So I'm trying to go to a smaller box now. I'm trying to grow from double to float. And if you remember, I told you that if you have to do that, it will not work out of the box, but you have to do something special as well. And this is the special part. This is called type casting. Type casting is basically a way to tell Java to explicitly cast this variable's value into this data type's variable's value. And you always need to do this whenever there is no implicit casting happening. If you are trying to store a larger value variable into a smaller value variable, you have to do this. Otherwise, Java will complain. You will get a compilation error. So that's what I'm doing. I'm telling Java to store the value of a as a float and store the value in f. And this is where I'm telling to store the value as float. So you just put brackets and you define float. And then I'm printing the float representation. Similarly, in the next one, I am trying to store the value of this double variable into a long. So you can see now I'm trying to go even from a precision data type to a non-precision data type, because long does not understand decimal values. So I'm trying to store a variable which has decimal values into a variable data type which does not understand decimal values. And we will see how the output looks like. But here also you need to do the explicit casting. Explicitly you need to tell which data type this a needs to be converted into. That's what I do here, and then I print the long variable here. And then next, I will again go down further and I will try to store a larger long variable type into a smaller int variable type. So again, I'm trying to store the value of b into a smaller data type, which is integer, and I'm naming the variable as c. Here again, I have to do this explicit casting. I'm telling Java to explicitly cast the value of b, which is a long data type variable, into an integer c, which is an int data type variable. And then I'm just printing the value. So this is what is happening in this program, that from double to float to long to int. Now let's run this program and see what happens. So I will right click and go to run as and choose the Java application option. And this is the output I get. First of all, for the double representation, the value gets printed, 0 is ignored. Then in the float, it works fine as well without any precision loss, because float can also print values up to 1 to 2 decimal points without any problems, even beyond that actually. So it works fine. Then when we talk about the long representation, we are trying to convert a double variable into a long variable, and we see that the decimal values are lost. This is expected because long does not understand decimal values. That's why anything after the decimal, or in fact the whole decimal portion, is gone when you're trying to store double or float into some absolute data type variables like int or long. And then in int representation, since you already have this long can easily be casted to int by just providing this explicit casting, and the int representation also prints 50. So we started from this value and we ended up with these values when we try to store them as long or int. So this is all I wanted to cover in today's lecture. So we covered basically about the data type conversion or data type casting concepts. How does implicit data type casting works and how does explicit data type casting works. And as we know the concept, the basic concept is that the value can easily be casted from a smaller range to a larger range without any changes or without any extra code. But when you have to go from a larger value to a smaller value, you have to provide these casting instructions to Java to successfully cast those variables. In the next session, we will be looking at how we can write the first Hello World program in Java, and there we will actually cover all these things which I have been saying that we will cover. So we will cover all these ways of how we can write the first Hello World program in Java. Let's get started with how to write your first program in Java. So I have been talking about this lecture and the details of this lecture in the previous lectures as well. And today we are going to focus exactly on how do we actually write a Java program. So as we have already covered how you can install Eclipse and how you can create a sample Java project in Eclipse. If you haven't seen that, please go back to my previous videos where you can actually see that. And once you have created your Java project, so your Java project might look like something like this. You will have an src folder here. So, and under the src folder, you see some namespaces sort of things created here, right? We call these as packages. And in Java, you can think of package as something which can group multiple related artifacts together. This is simply a grouping mechanism, I can say. It's a way to put all the related artifacts to a particular business problem into a certain place. For example, if you are working in an e-commerce application, so you might have created multiple Java files for, let's say, for checkout, and then some more Java files for the filters flow, I would say, then some other Java files for designing the advertisements. So you have multiple Java files, and these Java files now belong to these three different domains. So you want to group them together for easy accessibility, for referencing each other files within the code. So if you want to achieve that kind of flexibility, you would group the checkout code files into a single package. You can name it as checkout package. Then you can similarly do the same thing for the advertisement package and for the filters package. So similarly, I have created some packages here which you can see. You see a package here which says IO GitHub Vikesh Pandey Hello World. And how do you create a package? You just right click on this. So you go to the src and you right click, you go to new, and here you will see this option which says package. So you can just click on this and write anything which you want as the package name. Let's call it as test package. It says invalid because the package is a keyword, so it is not allowing me to put package here, but let's call it test package 1, and you can just click finish and you will see a test package popping up here. Then you can right click on this again, go to new, and then you can create a Java class. Now what is a Java class? A class is basically a blueprint for an object. It's basically the specifications of an object. Like I covered in the very first lecture, everything in Java is an object, or most of the things in Java are object, I would say. So object is basically an instance of the class. So let's say you create a class for, if I take the same example of e-commerce, you create a class for writing the business logic of checkout, and then you create instance of this particular class to work for a particular customer order. So class is basically a blueprint. It's the specification, it's the skeleton of the object. So once you click on this, you can create a class. Now Eclipse is a pretty smart IDE. It will provide you with a bunch of options on how you actually can create a class, and it will also provide you with some sensible defaults. For example, it will automatically select a source folder in your project which you have created. it will automatically select a package. In fact, the currently selected package. And if you want to change the package, just hit browse and choose any other package which you want to choose. So your class file will be created in that package. Then you can provide a name to the class. So let's call it as test hello world. And you can see I have followed a sort of a naming convention here. The first character I've kept it as capital, and then any other new word which is coming in my class file name is also capitalized. So Java would expect you and it would encourage you to follow this naming convention, that whenever you are creating a class, always start with a capital letter, then small letters, and every new word you are writing can start with a capital letter again. Java will not throw an error if you don't do this H capital or W capital, but it's a good practice. The next thing is the modifier. We are going to cover the modifiers in details in the upcoming lectures. But for now, you can understand that anything which is marked as public is accessible to every other Java class in this whole project. That's the basic meaning of making a class as public. Public, as the name suggests itself, it means it's visible to everyone. You can select a superclass, and again we'll talk about this superclass later, but this is the Java lang object is the superclass of all the classes which are created in Java. Again, interface is again an advanced concept, and there are some other interesting defaults it provides. For example, if you want to create a main method. Now, what is a main method? We'll just cover it in a while. So I will not do that. I will leave everything as default and I will click on finish. So I have this new file coming up here, and you can see it has automatically picked up the package which I selected, and it has also written public class test hello world with a starting and ending curly braces. In the previous lecture, we covered about these curly braces, that all the code block have to be in the curly braces. Whenever you write a Java class, the very first statement Java would expect to have in the class is package name. So make sure that you have package as a keyword and then the actual package name as the package name for that particular class. You can see the package follows a dot convention and it always ends with a semicolon, like all the Java statements end with semicolon. So that would be the first thing which you will write in your class. Second thing is the access modifier of the class. Like I said, you want this class to be accessible to every other file in this project. Then you can mark this class as public. The next thing is the class keyword. You need to write this particular keyword as is, otherwise your class will not be detected. So you write this as class. Then you write test hello world or whatever name you want to write. But make sure that whatever public class name you provide here, that name should match with the file name. These two things should match, the file name and the class name. If they don't match, you would experience weird behaviors as the class will not be compiled or class might not be able to run, etc. So always make sure that whatever file name you provide, you always have a class with that name in your file. So my class structure is ready, but there's nothing here in this class. In fact, you cannot even execute this class, because for executing the class, for executing any class in Java, any class at all in Java, you would need a main method in Java. Main method is the entry point method of the Java. Whenever you are trying to run any application, be it a very small or very large Java application, you would always need a main method in the class, in the project somewhere. And you need to tell the Java runtime to execute that class, and then the class will have a main method and your program will start executing. So always have a main method, otherwise your program will not execute. And how do you write the main method? So you first write public, then you write static, then you write void, and then you write main, and then you provide a parameter to this method as this. Now let's understand what did I actually write here. First keyword is public, because this method has to be public, because like I said, Java runtime needs to be able to access this method. So the similar concept which applied on the class is applied on this method as well, that the entry point method has to be public. Otherwise, Java will not be able to find this method. So you need to make this method exactly as public. The next keyword is static. You again need to write this keyword as is. And the reason we write static here is because we want to run this particular class without creating an object of the class. Static is again a keyword which we'll cover in the upcoming lectures, but for now you can understand that whenever you want to access something within the class without creating an object, then you need to create it as static. The next is void. Void is basically the return type of this method. The method name is main and it has to be main. It cannot be main1 or main2. Otherwise, if you do that, Java will not be able to run your program because it will expect you to write this particular method exactly as what I have written here. No changes at all should be there. If you make any changes, Java program will not run because it will not be able to find the entry point method, which is the main method. So public, static, void, main. Remember that you need to have this in your program. So void is the return type, which means that this particular program, it will not return anything back to the runtime, because a method can have this capability to either return something or not return something. For example, a method which can add two numbers will return the result of addition, right? So we return the result. Return is the word here. In this case, this method is not expected to return anything because there's nobody consuming it, right? Java runtime will not do anything with the return value of this particular method. That's why Java will force you to write void here, and main is the exact method name which you need to use. Java will expect you to supply a string array argument. If we covered arrays in bit detail in the previous lectures, and we will cover arrays in the next lecture in very detail. But you can, as we discussed, that array is basically a sequence of characters or words or integers or anything, right? So in this case, this is basically the mandatory parameter which you need to write as is. This parameter name can be anything, obviously. It can be arg, args, or whatever you want to write it as. But the basic fundamental is that Java will basically supply all the command line arguments using this particular string array. That's why you need to provide this. Then let's write something in the program, because this is a hello world program. So I will just write system.out.println, and I'll type a string here which says hello world and a semicolon. So again, I have been saying that I will explain this, and now I will explain this. Why do we need this and what does this mean? So as I've told earlier, that whenever you want to print something on the console in a Java program, you need to write system.out.println. Now system here, if you just hover over it, Eclipse will show what it is. So system is basically a class which contains several useful class fields and methods. It cannot be instantiated, means you cannot create an object of it, and it provides many facilities like standard input, standard output, and error output. Exactly what we want to focus here, because we want to use system class to print something on the standard output. The standard output in this case is the console. So if you want to input something, or you want to output something, or you want to output an error, then you need to use system class. And all of these, standard input, standard output, and error, are streams. And that's what comes to the next word. What is this out? Out is a stream to print standard output. Similarly, we have system.err, which is for printing the error output streams. Similarly, we have system.in for taking its standard input streams. So system.in, system.out, system.err, these in, out, and err are streams. And then println is the actual method. Let's hover over that. Let's first see out here. So you can see this is a stream object which is used to print anything, which is ready to accept output data basically. And then we go to the println method, and it says prints a string and then terminate the line. So like I mentioned earlier as well, this whole syntax is used to print, and actually this is the core method. This is the real method which prints something on the console. So system class uses the output stream to print something on the console using the help of println method. There is also a print method. So there are two methods. One is print and one is println. The difference is that in case of print method, the print method will not provide you or terminate on a next line. But in system.out.println, the ln means line here. It will print something and it will bring the cursor to the next line. If you do not use this, and if you again use another print statement, then both of the statements will be printed on the same line. I will show that as well. But and then we provide any random string here which we want to print. So you right click on this particular program, you go to run as, and you run as Java application. and you want to save this, so you can say always save resources before launching, and you see the output here. So this is how you can run your first Java program. Now let's also see the difference between system.out.println and system.out.print. So I will just copy this here and I'll say hello world 1, let's say, and this time I will not use system.out.println, but I will use system.out.print. Just put a space here so that it's visible. So if I use print, how does that look like? I go to run and I go to run as Java application. So now you see both of the outputs are printed on the same line. There is no, this output hasn't gone to the next line. And now if I run the same program with system.out.println methods, now both of these outputs will be divided on 2 lines. The first output, then a line break, the hello world 1 goes to the next line. In the previous run, the hello world 1 was printing right next to it on the same line. So that is the difference. So this is how you can build your very first program, the hello world program in Java. In the next session, we will be discussing about arrays in Java. Let's get started with arrays in Java. We discussed about arrays in a bit detail when we talked about the non-primitive data types, but this is a concept and a topic which needs to be understood well. So that's why we'll do a deep dive on arrays in this particular lecture. So as I described earlier, that array is basically a container which can store values or a sequence of values or sequence of numbers or sequence of characters into itself. You can think of it as a box which can store all the values in a continuous fashion. As you can see here, this is just a pictorial representation, and this is coming from the official Java docs. And you can see that if we create an array of size 10, then we have these 10 blocks created here. You can see 1 to 10th. So the whole length of boxes, the number of boxes here are 10. But the way arrays are designed is that the index is basically used to access the element in this particular box. The index of the boxes start from 0. So it goes from 0 to 9. So remember, the array length is 10. The array can contain 10 elements, but the index of the array starts with 0 and will always end at length minus 1, which is 10 minus 1 in this case, which comes as 9. So it will always be length minus 1. It will always the index will always start from 0 and go till length minus 1. Length can be anything. In this case, the length is 10, so the index ends at 9. If the length was 20, the last index will be 19. But in total, you have these 10 memory locations. We also call them as continuous memory locations because they are continuously placed. An array basically blocks 10 memory locations and creates a container over it. So this is how an array basically looks like inside the memory. And whenever you want to access the elements of the array, you will say array of 0 or array of 1 or array of 2. You basically need to specify the index to access the element at index. For example, if you want to access the element which is sitting in this box, you need to say array of index 8. And we'll see how we can do that. But this is the basic understanding and idea of the concept of arrays. So let's try to understand this with the help of an example. I will switch back to Eclipse IDE, and I've created a very simple program here to demonstrate the functionality of arrays here. So we already covered in the previous lecture of what is package and what is public and what is class. How do we give the class name and what is the meaning of this particular method. So I'm not going to cover that again. We'll start directly from here. So here the first thing which I'm doing is I'm declaring an array of integer. This is a variable name, the identifier basically. It can be anything. And this is the data type. It's an integer array, and as we covered this as well, that whenever you put square bracket in front of a data type, it becomes an array data type. So this is an integer array representation. Now we just declared an array, but we still haven't allocated a size to it. So you can do that with this particular syntax. So you can put the variable name of the array and say new int and put the right size here. This size can be anything. And once you do this, now array will actually allocate those memory boxes which we covered here. The moment you do new int 10, these boxes, continuous boxes, will be placed in the memory, and the memory is allocated to this array. We call this memory allocation. This is how you allocate memory to the array. So we allocated memory to this array for storing 10 integers. The next thing is now we can start storing elements in those boxes. So like I said that the array index always starts with 0. So if you have to store the first element, you actually have to store it at index 0 location. So you give the array name, you provide these square brackets, and you put the index value within the square brackets. That is how you basically point to a particular element inside the array. So we say an array of 0 and we put the value 100. Then we initialize the second element, which will be index 1. Then will be the third element, which will be index 2. Fourth element, index 3. Fifth element, index 4. Sixth element, index 5, and so on. Until we store till the last element. So this is the 10th element, which is accessible as index 9. And the value is 1000 basically. So from 100 to 1000, we stored 10 values in this array and we stored them by accessing the index, and this is actually the only way you can store values in the array, by pointing to the indexes. So we go from 0 to 9 and we stored all the values, 0 being the first element and array of 9 being the last and the 10th element. Remember the length minus 1 concept. Okay, so now we will try to print all the elements one by one. That's pretty much what we are doing now. So as we covered in the previous lecture that we use system.out.println to print anything, and we understood the whole meaning of this, so I'm not going to repeat that. Now we want to print the first element. The first element is sitting at index 0 and we can access that element with this syntax by providing the variable name and the actual index value. So I'm just writing a random string here which says element at index 0, and then I'm putting this plus here and putting the variable name. This plus is basically used to concatenate the output of a static string with a random variable, or basically you can print anything with using plus. Plus is used for concatenation. So I'm just trying to print this whole value, but here this is a string value which is a static string, and then I have a value coming from the array. So whenever you have to print some value from a particular data type or variable or collection, then you can use this plus syntax to concatenate a string, static string, with your actual value. So that's what I've done here by saying plus and array 0. And similarly for index 1, I'm printing the first index, then for 2, 3, so far and so on so forth till the index 9. So basically I'm just printing all the values of the array starting from index 0 to index 9. So that's all which is written in this program. Now let's try to run this program. So I will right click, go to run as, and go to Java application and hit on this. And now if I just expand this console, you can see all the system.out.println statements have been executed and they printed this. So this is the static string part, in fact including the colon. This is the static string part, element and index 0, printing exactly as is, and then dynamically the 0th index element of an array is printed here. Similarly, we have printed the index 1 location element, index 2 location element, index 3 location element, and so on so forth till the index 9 location element. So in total these are the 10 elements, but the index always works from 0 to length minus 1. In this case it will be going from 0 to 9. So this is basically all which I wanted to cover in this lecture. The whole idea was to give you more understanding of arrays, and remember this is just an integer array. You can similarly create a character array. You can also create a string array for you as well. So it's completely related to the data type you are using. If you create a char array, then you can only store characters into it. If you create a string array, then you can only store strings into it. And now you can probably relate back to this particular thing which I explained in the previous lecture, that we create this string array for the reason that when you run this particular program, and if you want to provide any command line values, command line arguments to the program, those arguments will automatically be stored in this args, and then you can access this as args of 0, args of 1, etc. in your program. That's the whole concept. So this is basically the deep dive on array which I wanted to cover. And in the next session, we are going to cover about operators in Java. Let's get started with operators in Java. When we talk about operators in Java, there are multiple types of operators like assignment operators, arithmetic operators, unary operators, then we have conditional operators and logical operators, and we also have bitwise operators. And we will cover all of these operators one by one. We will understand what these operators are and how they work, and we will also look at a demonstration of it. So let's get started. The first operators we are going to discuss is about arithmetic operators and assignment operators, and we will also see if we can cover unary operators. So when we talk about assignment operators, I have again opened the official Java docs here. If we understand assignment operators, we have been using these operators all the while in all of the demos so far. And the basic idea is very simple. Whenever you assign a value to a variable, you use the assignment operator, which is nothing but the equal sign. We have already covered this in multiple demos, so I will not cover this as part of the demo. But what I'm going to cover in detail is about these arithmetic operators. So arithmetic operators are basically used to perform any kind of arithmetic operation on a Java program. It can be an addition operation, it can be a subtraction operation, it can be a multiplication operation, a division operation, or an operation by which you can find the remainder of the division. So we will look at each of these with an example, and as you can see, the symbols are expectedly what you generally use in mathematics. So you see the plus sign here, which is for addition. You see the minus sign, which is for subtraction. You see the star sign, which is for multiplication. You see the slash sign, which is for division. And you see the percentage sign, which is for finding the remainder of a division. So let's see an example of each of these and how we can use them in a Java program. So for the arithmetic operations, I have prepared a demonstration of it in the Eclipse IDE. Again, I'm using the same Java project which I have shown you we created in the previous lectures. So for all the demonstrations, I will just continue in the same project. So again, the way to create a class remains the same, exactly the same as how I covered in the previous lecture in the Hello World program, where we created a class. So here also I created a class. I named the class as arithmetic demo, and I have a public static void main method inside this particular class, and I have basically tried to demonstrate each of the operation. So let's start with the addition operation first. So I create an integer variable here named as result, and then I try to use the addition operator to make this variable store the result of this addition. So it's a simple 1 plus 2. You can also create two different variables for 1 and 2. Let's say x equal to 1 and y equal to 2. And you can also do int result equal to x plus y. It will have the same effect. But just for simplicity, I have put the literal numbers here. So result is storing the expression value of 1 plus 2. And then I'm printing this value here. You can see I'm printing the result variable here with using system.out.println. Then I'm storing this result into a variable, into a new variable, original result, with using the assignment operator. And then I'm trying to subtract something from it. So now I'm saying result equal to result minus 1. It means whatever the current value of result is, subtract minus 1 from that value. So the value was 3 here, and here 3 minus 1 becomes 2. So the new value of result becomes 2. The original result still holds 3 because it is storing the old value. The new value of result has now become 2. So I'm printing the original result, and then what I'm doing that I'm again assigning the new result, which is 2, to the original result. So now original result and result both are at 2. Then I move ahead and I try to demonstrate the multiplication operation. So I take the same variable result and I say multiply it by 2. So whatever the value of result was, which at this place should be 2, multiply that value by 2. So 2 into 2, the new value of result should become 4 after this multiplication operation. And again, I'm assigning the value of original result to this particular variable. And then I'm showcasing the fourth mathematical arithmetic operation, which is division. So you can see result by 2 here. So basically, whatever the current value of result is, I'm dividing that value by 2. So 4 divided by 2 should become 2. So again, the new value of the result variable should become 2. Then I'm printing the value and again storing the value back into the original result. Then the next operation is again an addition operation, where whatever the value of result is at this particular point, which is 2, add 8 to that particular value. So the new result value becomes 10, and then I'm printing that particular value, again assigning the original result to the result. And then to showcase the remainder operation, I'm doing result. We call this particular operator as mod or modulus. So result modulus 7. So the current value here is, in this case, would be 10. So I'm saying 10 mod 7. So 10 mod 7 would become 3, because if we divide 10 by 7, the remainder should be 3. And this modulus operator is used to calculate the remainder of a division operation. So that 3 will be stored in this result variable, and then we print that particular variable. So that is what I'm doing. If I take you back up there, I'll just minimize this window and this window as well. So if I take you back to the starting, I'm doing an addition first here at line 7. Then I'm doing a subtraction at line 12. Then I'm doing a multiplication at line 17 and a division at line 22. And then again an addition at line 27. And then a modulus at line 32. And I'm printing the respective values. So let us run this program and see what results do we get. So I right click, I go to run as, I go to Java application. There is also a shortcut for it. If you want to use the shortcut, you can use that. So I click on this and the output is displayed here. So you can see, let me bring this output back to its original position. Yeah, I just dragged it here to the top, to the bottom. So if we start from the top and see what all results did we get printed. So line 9 says 1 plus 2 equal to the value of result. So 1 plus 2 equal to, at this particular point, the result value was 3, because 1 plus 2 equal to 3. Moving on, the next variable here is minus. So the current value was 3. We said 3 minus 1, which becomes 2. And we store the value of result or 3 into this result variable, and we print that value at line 14. So original result plus original result is 3. Then a string here, minus 1 equal to. So this is just a string. And then the actual current result value, which is 2. So far so good. We move ahead, and then at line 19 we are multiplying the current value of result by 2 and again displaying the original result and the current value. So 2 is the original result here, because here 3 minus 1 had become 2. So original result value was 2. Multiply that by 2 becomes 4. Then moving on to the line 24, 4 by 2 should become 2. So 4 by 2 equals 2, the current value of result. Then again moving on to the next variable at line 29. Now the result value should become 10, because 2 plus 8 is 10. And again we are printing the original result and then the current result value. So the original result was 2, then we added 8 to it, and the new result value had become 10, which is coming from this particular variable. Moving on to line 34. We are again printing the original result, which was 10 here, and then we are saying this particular string, which is modulus 7, and the current value of result is coming from this expression, which is 10 modulus 7. And like I said, modulus or mod operation is basically used to calculate the remainder of a division operation, so 10 divided by 7, remainder is 3. So that becomes 3, and that's why you see the value 3. So this is a demonstration to show you how we can use the addition, multiplication, subtraction, division and modulus operators, which are all the arithmetic operators. So in the next session, we will be discussing about the other operator types, which are unary operators, and we will also discuss some other interesting operators which are popularly used in Java. Let's get started with unary operators. So when we talk about unary operators, technically they are also arithmetic operators, but they provide us a shorthand, or they have a more advanced meaning. So if you see on the screen, these are the unary operators. We call them as unary plus, unary minus, increment operator, decrement operator, and logical complement operator. So when we talk about the unary plus operator, basically it is used to indicate a positive value. So whatever value you are having, it will just make that number as positive number. You might be wondering that this plus has an addition meaning as well, right? Which we saw in the previous example. Yes, that's correct. but when we use that addition symbol, we use that between two variables. But when we talk about unary operators, they are used with a single variable. That is why the name unary, because they are used with a single variable. They require only one operand. So unary plus basically makes any number positive. Unary minus negates an expression and makes that number negative. Increment operator increments the value by +1. Decrement operator decreases the value by -1. And logical complement operator inverts the value of the expression from true to false or false to true. Let's understand this with the help of an example. So I have created a class here called Unary demo, and I have a static void main method here, and I have created a variable called result. And the first example is about using unary plus. So I'm creating a variable called as result, assigning the value as 1 and just putting 1 plus in front of it, which makes this as positive value. Though we can argue that this also has the same effect as this, and yes, that is true. But in case if this value was written as something like -1 instead of plus, then we could basically make that number positive by just putting plus in front of it. So that's basically the power of unary operators, and that's how you generally use unary operators. So I'll just put it back to +1. The next example is about decrement operators. So the current value of result was 1 because we did this. Now we are saying result minus minus, which means whatever the value of result is, just decrement it by 1. So the current value was 1. So now the new value of result after this evaluation becomes 0. So at line 14, we print the current value of result, which is 0. Moving on at line 16, we are using the increment plus plus operator here, which means whatever the current value of result is, just increment it by 1. So the current value of result was 0 till this line. So it becomes 1 because this means increment by 1. So line 18 will basically print that value 1. And then at line 20, I'm using the unary minus operator, which means whatever the value of result is, just negate it. Just put a negative in front of it. Just make that number negative. So if I just say minus result, the current value of result was 1. So it became -1. And then to showcase the negation operation, I created a Boolean variable, named it as success, assigned the value of this variable as false, and printed the value of success variable as is first, and then printed the value of success with a negation in front of it, with an exclamation mark, which will basically flip the value or invert the value of a Boolean variable. So if this was false, line 28 should print true. If this was true, line 28 should print false. In this case, this is false, so the line 28 should print true. So let's right click on this and run this program and see if we get the expected output. And yes, we see the output here. So let's try to interpret the output now. The line 10 should print 1. Yes. Then line 14 should print 0. We see 0 here. Line 18 should print 1 because we use the increment plus plus. So 0 plus 1 became 1. Then we use the unary minus operator. So the value should become -1. Yes, we see -1 here. And then for Boolean variable, we should see first the false because the value is printed as is. And then we are printing a negated value. So we should flip the value from false to true. And yes, it is printing the value as true. So this was about unary operators. Now, when we talk about these increment and decrement operators, what if I put this particular value in front of result? What effect is that going to happen? Let's analyze that part as well. So for that, I have prepared a separate demo. Again, I've created a class called pre-post-demo, and it has a public static void main method. I'm declaring an integer variable I with the value as 3. So the I becomes 3 here. And then I'm saying I++. As we have already seen in the unary demo example, this should increment the value of 3 to 4. So it will print 4, expected, right? Then at line number 9, I'm putting this plus plus in front of I. Now what will happen? Now it is going to increment the value of I and then basically assigning the value of I. So the whole difference between I++ and ++ I is that in this case, the value of I is assigned first and increment later. In this case, the value of I is incremented first and assigned later. So here the value from 4 becomes 5. So at line 11, if you see, if we print I, it will print 5 because we are saying that first increment the value and then update the value of I. So increment happens on I equal to 4 and I becomes 5. At line number 13, it becomes more interesting because here inside the system.out.println statement itself, I'm saying plus I. Now what will happen? Like I explained, first the value will be incremented and then the value will be assigned. So before printing, the value is getting incremented. So the value from 5 becomes 6 here at line 13. But if I try to do this, now I'm saying first assign the value of I and then increment it. So I at this line is still 6 because I has already been assigned 6. And as the post increment says, if you put this plus after the variable, it means that you are first assigning the value and then incrementing the value. So anything which happens after line 15, the value of I will become 7. But at line 15, the value of I is still 6 because we are using a post increment operator. So the value is still assigned to I as is and then incremented. And when we do system.out.println, the assigned value is printed, not the incremented value. So like I said, after line 15, the value of I will become incremented by 1 and it will become 7. So hope you understood this example and the difference between the pre-increment and post-increment. Remember the thumb rule that if we put plus before a variable, like at line number 9, the value will be incremented first and then assigned. So at line 13, the updated value will be printed because the first we are doing the increment and then we are printing the value or assigning the value. Similarly, at line 15, we are first printing the value and then incrementing the value. So when the value is printed at line 15, the old value of I will be printed, but after line 15, the new value of I will be accessible to the program. So let's right click on this and run this program. And now if we see the values, we assigned I to 3. We did a post increment here. So I becomes 4. We print the value of I. So here the value of I is 4. We see 4 here. Then at line 9, we are saying plus I. So 4 plus 1 becomes 5. Though this is a pre-increment, but since we are not printing this plus I as is, it does not have any change. So the value of 4 becomes 5. At line 11, we print 5. Then at line 13, we are saying plus I, which means increment the value of I first and then assign it. So the value of 5 becomes 6 and then I gets updated and printed. Similarly, at line 15, first the value of I is assigned and printed and then incremented. So at line 15, the value is still 6. You see this 6 here, and then the value is incremented. So after line 15, the value becomes 7. So that's how we are basically using the unary operators. And this is where I would like to end this particular session. In the next session, we will be discussing about other type of operators, which are comparison operators and logical operators, etc.
Let's get started with equality and relational operators. When we talk about relational operators, they are sometimes also called comparison operators. And the basic idea behind using these operators is to compare things or compare the values of variables or compare the objects in Java. So in Java, if you need to compare anything, for example, if you want to compare if something is less than the other thing, or something is greater than the other thing, or something is equal to the other thing, then you need to use the comparison operators which are provided by Java. Here you can see I have opened the official Java docs, and you can see a bunch of comparison or relational operators. Both of the terms are used interchangeably. Some people call them comparison operators and some people call them relational operators. So you can see if I want to compare if an object or a value is equal to another value, then I use the double equal sign. If I want to compare for non-equality, I will use exclamation with an equal to, which means not equal to. If I want to do a greater than comparison, then I will use the mathematics greater than symbol. If I want to do the greater than equal to or less than equal to, they again follow the same kind of terminology as we see in mathematics. So this is all we have in terms of the relational operators. So let's understand the usage of these operators with the help of some examples. So as you can see, I have created a class here, which is called comparison operator. There is a public static void main method inside this class. And this method has two variables of integer type called value1 and value2. Value1 has the value 1 and value2 has the value 2. And then I am trying to compare the value1 and value2 variables using the different relational operators we just covered. For doing that, I need to use a conditional operator as well. We will be covering conditional operators in much detail in the upcoming lectures. But for now, you can understand that when we talk about conditional operators, we talk about if and else statement. So if is again a keyword in Java, which can be used to compare things. And the syntax is very straightforward. You write the if keyword and then you write the actual comparison syntax or the actual comparison expression. So in the first example, we can see that I'm writing a condition which says evaluate if value 1 is equal to value 2. I should put a curly braces around here. You can see there are no curly braces here, but that is for a case when you have only one statement under it. But again, I will cover this in detail and I don't want to confuse the audience here. So I will just put curly braces around all of these if statements so that it becomes easy to interpret what is actually going on in these code blocks. As we know that these curly braces are used to define a code block. So the first if block says compare if the value 1 is equal to the value 2. If yes, then this condition will become true and the control of the program will go at line number 10. If this condition is not true, then the control will not go inside 10 because this condition is false. So it will never go to line 10 and it will move to line 11 or 12 instead. Similarly, the next condition is we are comparing the value 1 is not equal to value 2. So this condition will only be true if these two values are not equal or unequal. And if that is the case, then line 14 will execute it. Otherwise, line 14 will not be executed. Similarly, in this condition, I'm saying compare if value 1 is greater than value 2 or not. So if the actual value holded by value 1 variable is greater than the value 2 variable, then this condition will become true and the line 18 will be executed. Otherwise, it will be skipped. Then similarly at line 20, I'm doing the reverse. I'm comparing if value 1 is less than value 2. If that is the case, then line 22 will be executed. Otherwise, it will be skipped. And at last, I'm also showcasing an example of less than equal to operator that you put less than and equal to together. And again, you compare the two variables. Similarly, you can also use greater than equal to variable comparison operator as well in this example. So we have an example of equality, not equal to, greater than, less than, and less than equal to. Let's run this example to understand. So for running the example, I will just right click here, go to run as, and click on Java application. And we can see the output here. So as the value 1 holds the value 1 and value 2 variable holds the value 2, obviously 1 is not equal to 2. So the first condition is not going to be evaluated to true. So line 10 will never be executed because 1 is not equal to 2. Similarly, if I talk about the next condition, which was if value 1 is not equal to value 2, then execute statement 14. And yes, 1 is not equal to 2. That's why we see this particular system.out.println here. We see this printed. Moving on, is value 1 greater than value 2? So is 1 greater than 2? No, it's not. So line 18 will never be executed. Then the next one is value 1 less than value 2? So yes, 1 is less than 2. So line 22 will be executed. And we see the line 22 output here, system.out.println output. Moving on, is 1 less than equal to 2? Yes, 1 is less than equal to 2. So this particular condition is also true and line 26 will be executed. And that's why we see this here. And that's all. So we can see that we are able to use these comparison or relational operators to evaluate different conditions. And we write those conditions using the if block. And again, if you do not understand the if block fully, don't worry. We will be covering the if blocks in detail. But the focus here is in using the operators, the not equal to operators, the greater than equal to operators, less than equal to operators, etc. So I hope these operators give you better understanding of how to use them. Now moving on to the next section of this comparison operators, sometimes we also use some logical terms to do the comparison. For example, if I just move down here and I show you these conditions here, we call them conditional operators. Conditional operators are used to evaluate the conditions like and or, and we use them in two ways. Either we can use it as ampersand or double ampersand, or we can use them as pipe or double pipes. So the idea is basically to evaluate if one condition is true and other condition is also true, or one condition is true or other condition is true. So whenever you want to combine two conditions together, that's where you're going to use these logical operators or conditional operators. You can also use the simple English keywords like and or you can use the logical representation of these keywords. For example, ampersand, ampersand, or double ampersand is equivalent to and. Similarly, double pipe is equivalent to or. So we can use these as well interchangeably. You can use either of these operator representations to run a conditional check in composition, meaning you can compare two conditions saying, okay, if one is true and second is true, or one is true or second is true. So the whole focus is here in and or comparisons. So let's switch back to the IDE and let's look at an example of this to understand this in detail. So I will again take the similar kind of example. Again, I have created two variables here, value 1 and value 2. Value 1 has value as 1 and second variable value 2 has value as 2. And then I'm writing two conditions this time in the same if block. You can see I am writing first condition saying is value 1 equal to 1 and is value 2 also equal to 2. So this whole if condition is only going to be true only if both of the conditions are true. That's the property of and will force that both the conditions on the left hand side of it and the right hand side of it hold true, and then only the whole expression is going to hold true. Even if one of the conditions evaluate to false, the whole if expression will evaluate to false. Similarly, for or conditions, we again write a left hand condition and a right hand condition, and in between we write this double pipe. We can also write or in English. That will also have the same effect, and this will evaluate in a way that this whole expression will evaluate to true if even a single condition either on left side or right side of it becomes true. So or will just need one expression to be true to make the whole if condition true, whereas and will force both of the conditions to be true to make the whole expression as true. So and will require two trues to actually become true, but or condition will require only one true to become true. So if we try to do understand this logic, here I'm saying that if value 1 is equal to 1, which is correct, and value 2 is equal to 2, then make this condition as true. So yes, in this case, this condition will evaluate to true because value 1 has value 1 and value 2 has value as 2. So it will print the line 10. Whereas in the next condition, I'm saying evaluate if value 1 is equal to 1 or value 2 is equal to 1. So either of the expression if becomes true, either the left side, this expression, or the right side, this expression. Either of the expression becomes true, this whole condition will become true and line 14 will be executed. Line 14 will not be executed only in a case when both of the conditions here become false. For example, if I write it like this, then we know that value 1 is not equal to 4 because it's 1 and value 2 is not equal to 5 because it's true. In that case, both of the expression will become false and then line 14 will not be executed. If I write it like this, then the left hand expression is evaluated to true because value 1 is 1, but the right hand expression is false. But it's fine. The line 14 will still be executed because either of these side is true, so the whole expression becomes true. Similarly here, and will require both of the expressions to be true, and if either of them becomes false, then the whole expression becomes false. So in the current state, line 10 will be executed, but if I change this to this, then the left hand side of this ampersand will evaluate to false and the whole expression will evaluate to false in that case, and line 10 will never be executed. Let's try to run all of these scenarios to make a better understanding of this. So in this case, both of the conditions should work fine. So I will just right click and run as Java application. And yes, we see this line 10 being printed, and we also see this line 13 being printed. So both of the lines are printed correctly. Both of the conditions are evaluating to true. Now let's try to play around with it. Let me change this value to 4. So now value 1, this left hand side expression is false, which should make the whole expression as false, and it should not print the line 10, which is this statement. So let's run this program and see if that works. Yes, we see that this particular line is not printed now because this whole expression became false because the left hand side of this expression became false. Similarly, in the OR case, either of them have to be true. You can see currently value 2 equal to 5 condition will actually result in a false condition because this is not a true. Value 2 is actually 2, not 5. And still we see this particular expression because either of them have to be true. If I make both of them as not true, now both of the conditions on the left hand side of pipe and right hand side of pipe are false conditions. What will happen now? Nothing will be printed. The reason for that is that value 1 is also that this condition is also false and value 2 condition is also false. So the whole expression became false and this was already false. So this is all I wanted to cover in this lecture. We covered about the comparison operators and how to use them. And in the next lecture, we are going to talk about the bitwise operators. Let's get started with bitwise operators. Now, bitwise operators are very less commonly used in the Java programming world. Generally, we don't use them. And generally, we don't need to use them. You would generally use them when you are doing really complex bitwise calculation where you need to manipulate the bits. Now, what are actually bits? So if you remember when we talked about the integer type variables, we talked about how much memory each of the variable type or data type was going to consume. We said that this will take 1 byte and this will take 2 bytes, etc. 1 byte is basically made up of 8 bits, and bits are nothing but positions where either a 0 is stored or 1 is stored. Actually, the whole machine will convert your whole program ultimately in zeros and ones, which are nothing but bits. So if you want to do the manipulation at that level, so now you can understand you are actually working right at the machine level understanding. So if you want to manipulate the bits which are going to be understood by the machine at that level, then you can use bitwise operators. But like I said, generally we don't need to use them. Now, when we talk about bitwise operators, there are multiple ways in which we can use them. We can use them with the standard AND or OR operations. If you remember, we covered this AND or OR operations in the previous lecture. You see a difference here that in case of AND, we are using a single ampersand and not double ampersand. This is one of the concepts which we did not cover in the previous lecture. And I would just like to brief you about this concept that if you use double ampersand, that is also called a short circuit operator. And if you use a single ampersand, that is called a standard operator. To build an understanding about this, I will just quickly recap of what we covered in the last lecture and we'll try to explain these concepts as well. So let's go to the logical operator demo. And here, if you remember, there were 2 ampersands and 2 pipes. This is also a valid expression. A single ampersand is also a valid expression. The only change is, in this case, even if the left hand condition evaluates to false, still the right hand condition will be evaluated. Although we know that in case of AND, either of the expression needs to be false and the whole expression becomes false. So Java provides an advantage with that if you use double ampersand, and if the left hand operation becomes false, then it will not cover the right hand operation. It will not even evaluate the right hand operation because it doesn't matter. If the left hand operation has already returned to false or evaluated to false, then no matter whether right side is true or false, the whole expression is still going to be false, right? That's the property of AND. One of the side has to be false and the whole expression becomes false. So why evaluate two sides? Why waste the memory in evaluating the right side when the left side has already turned as false? Java takes advantage of that. And that's why if you use double ampersand, you save a bit of processing power of your computer by just evaluating the left hand condition. And if the left hand condition is false, it will skip evaluating the right hand condition and just make the whole expression false. But if you use this, a single ampersand, then both sides of the expression will be evaluated irrespective of their output. So in this case, even if the left-hand expression is false, it is still going to evaluate the right side expression. And similarly, it works for the OR case as well. In this case, in OR case, as we know, if one of the condition is true, the whole condition becomes true. The whole expression becomes true. So if the left-hand side becomes true, and if you use a single pipe, then it will still evaluate the right-hand side. But if you use double pipe like this, then if the left-hand side becomes true, then it knows that it does not matter if the right-hand side becomes true or false, because ultimately the whole expression is going to be true if either of the side is true. So if the left-hand side is already true, it will not evaluate the right-hand side, and it will say the whole expression is true. That's why you see the single ampersand being used for bitwise, just to explain why it is used and how it is used. For OR operations in bitwise, you use this cap or whatever you want to call it as. And for the inclusive bitwise or operation, you're going to use a single pipe. You also use some shift operations where you shift the value of bit of a particular variable to either left or right. Again, these are very complex calculations. If you want to use that, please read about this and use that. But in today's demo, what we are going to cover is the AND and OR examples of bitwise operations. So here I have again created a class called bitwise operator. I have a public static void main method. I have two variables here, which are int a equal to 5 and int b equal to 7. Now these 5 and 7 are actually stored as bits, as zeros and ones in the computer's memory. So how they are actually stored? They are stored in a standard bit representation, which you may have studied in your mathematics. If to give you a recap, this 5 will basically be written in the memory as this 0 1 0 1, and it starts from here. 2 raised to power 0 into 1 becomes 1, 2 raised to power 1 into 0 becomes 0, 2 raised to power 2 into 1 becomes 4, and 2 raised to power 3 into 0 becomes 0. So 0 plus 4 plus 0 plus 1 becomes 5, and that's how 5 is displayed to you. Similarly for 7, 2 raised to power 0 into 1 is 1, plus 2 raised to power 1 into 1 is 2, so 1 plus 2, 3, plus 2 raised to power 2 into 1, which is 4, so 1 plus 2 plus 4, 7, and 2 raised to power 3 into 0 is 0. So 0 plus 4 plus 2 plus 1, which is 7, and that's how this 7 is built and stored. And now if you try to do this, if you try to write this condition, you can also write the condition into a system.out.println block, and it will basically evaluate this condition. So now if you say A and B, in this case, this is going to do a bitwise operation because this is bitwise operand. It is going to do a bitwise operation, and what would be the result if you do an AND on this? So again, use the same logic as if in case of AND, if 1 is false, then the whole expression is false. So 0 and 0 becomes 0, 1 and 1 becomes 1, 0 and 1 becomes 0, because 0 means false and 1 means true. So if either of them is false, the whole evaluation becomes false. So that's why 0 and 1 becomes 0, and 1 and 1 is always 1. The value of this is again 5, as we already have evaluated. Similarly, if we do a bitwise OR, and if we do this, again we are doing an OR operation. So 0 or 0, or basically false or false becomes false, true or true becomes true, false or true should be true because one of them needs to be true. So this is false, but this is true, so the whole value becomes true. And finally, true or true is also true. So this is the final bitwise OR result. And if we convert this into an integer representation, that becomes 7, because 2 raised to power 0 into 1 is 1, 2 raised to power 1 into 1 is 2, so 2 plus 1, 3, plus 2 raised to power 2 into 1, which is 4, so 4 plus 2 plus 1, which is 7, and plus 2 raised to power 3 into 0, which is 0. So 0 plus 4 plus 2 plus 1 becomes 7, and that's how you get actually 7. So let's see if we get 5 or 7 in this bitwise operation. Yes, we can see the values as 5 and 7. So this is a bitwise operation happening. Similarly, you can also use the shift operations where in case if you're using this particular kind of representation or this particular kind of representation, they are called left shift and right shift operations. So if you use this in front of a variable, then for example, this 1 will be shifted here, and this 0 will be shifted here, and this 1 will be shifted here. So that's how the whole value is going to shift. Whole bits are going to shift one by one towards left. Similarly, if you're using the right shift, then all the bits are going to be shifted towards right by 1 bit. That's the whole concept of left shift and right shift bitwise operations. And if you want to know more about this, please read some official examples from the Java doc and some other examples available on the internet to build an understanding on this. So this is all I wanted to cover in this lecture. So in the next session, we are going to talk about the control flow statements like if, else, etc. Let's get started with control flow statements. So what are control flow statements and why do we need them? Control flow statements are the ones which can help you control and define the flow of execution in your program. Now, why do we need them? Is because if we want to evaluate some conditions or we want to create some branches of execution saying that if this condition becomes true, do this, and if this condition becomes false, do that. So you can see there are two different branches of execution of a program in this kind of approach. And that's where control flow statements can help us. There are a lot of different types of control flow statements like if, then, else, and switch, and for, and while, and do while. And we are going to cover all of them in detail in this series. So let's get started with the first one, which is the if statement. We covered briefly about this when we talked about operators, and I promised you guys that I will be covering this in detail. And this is the session where we will go deeper into this concept. As we have already understood that if condition is basically used to evaluate a condition if it is true or false. The result of an if statement will always have only two values. It can either have a true value or it can have a false value. There is no other possibility or there is no other value of an if statement or of an if expression. Now, like I explained, if you want to do a simple programming execution where you say if a particular condition becomes true, do this, and if this becomes false, then do that. It means you need to write this else condition as well, that if this doesn't hold true, what do I do and how do I write that? So let's understand that with the help of an example. For this particular example, I've created a class and there is a public static void main method, which is the entry point of this program's execution. I have a variable which is called test score. This is an integer variable with the value 76. And I have a char variable, which is grade. Basically what I'm doing that based on the test score marks, I'm trying to define the grades which a student will get. So for that, I have built a condition here. So you can see it starts with if, which is a keyword. Then you put these standard braces or brackets and you write your condition inside it. In this case, I'm writing the condition saying that if test score is greater than equal to 90, then the student should get an grade A. So here I've defined this grade variable and here I'm just assigning the value to the grade variable at line 11. If the test score is greater than 90, the grade should be A. But what if the score is not 90? What if this condition becomes false and you want to do something? In that case, you can write this else block here. We call this else block. So you write else as the keyword, you start the curly braces, and then you define the grade. If the score is not greater than 90, what should be the grade of the student? So in this case, we are saying the grade is F. So if we try to run this example in our mind, we see that the value is of the test score is 76. So 76 is not greater than equal to 90. So this particular condition will not be true. So line 11 will not be executed, but instead else block will be executed, because if the condition goes false, then else block should be executed as per Java. So this block will be executed and grade will get a value of F. And then we are printing this grade value by just writing a system.out.println, a string plus the value. So let's run this particular program and see what happens. We get a grade equal to F here in this sysout or system.out.println. because this condition was false. So the flow of the control of the program went to line 12 and then to line 30 because this was the else block. So this is one understanding where we can write an if and else logic. In some cases, you might not need an else block. So else block is not mandatory. It's an optional block. If you want to remove this and if you just want to do a sysout here, that is also fine. Sysout means system.out.println. For shorthand, we sometimes call it as sysout. So you can do something here as well if you don't need the else block. If you need the else block, feel free to write it, but this is an optional block. But in some cases, your conditions will be more complicated than just a single condition. If you try to understand it from a real world example, in real world, you will not have only two grades as A and F. You will have more grades, right? A, B, C, D, so on and so forth. So what are you going to do in that case? For that kind of case, Java provides us with a keyword which is called else if. Else if is just a continuation of if, saying that, okay, if this condition doesn't hold true, evaluate the next one with an else if. So I've commented out this code. Let me put this code back into its place and then we will walk through this code to understand it. Okay, so I have put the code back to where it should be, and this is how it looks like. So let's just walk through this. The line 10 and 11 doesn't change. It's still the same, but then I have added some additional conditions saying that, okay, if the score is greater than equal to 90, the grade should be A. But if the score is not greater than 90, but greater than equal to 80, then the grade should be B. Similarly, if the score is not even greater than 80, but greater than equal to 70, then the grade should be C. Similarly, if the score is not even greater than equal to 70, but greater than equal to 60, which means basically between 60 to 70, then the grade should be D. And if the score is even below 60, then the grade should be F. So you can see I have basically defined the whole logic for defining the grades here. And it always works in a top-down approach, one by one. The way in the sequence in which you will define the else if block will be the sequence in which they will be executed. So after the condition at line 10, and if this condition fails, line 12 will be naturally executed. If this condition also fails, line 14 will be executed, and so on and so forth. It will never be the case that if this condition fails, then suddenly line 16 is executed, and then again line 12 is executed. It will always work in a line by line fashion. So make sure whenever you are using the else if statements, write it in a sequence in which you want the natural program to be executed. So this is all we have here. And now let's try to run this example. Let me just bring the system.out.println line up, save this file, right click, run as Java application. So we see the value is grade equal to C, which means this particular code block was actually executed. Only this condition held true. Now let's try to understand how this happened. The value was 76. So 76 greater than 90? No, this condition becomes false. So line 11 is never executed. It naturally goes to line 12 because that's where we have defined the next else if block. Is 76 greater than equal to 80? No, it's not. So line 12 condition also becomes false. Line 13 never gets executed, and the control shifts to line 14. And there we have the condition saying that is 76 greater than equal to 70? Yes, this condition is true. So the line 15 gets executed. And once this condition gets true, none of the further conditions will be executed because you only need one true statement, one true execution in the whole if else if block. If that one code block gets true, that code block is executed, and then the execution jumps out of the if else if blocks, and it will directly go to line 22 and it will execute that. Had it been the case that this particular block was also evaluated to false, it would go to line 16, and if this was also false, it would go to the block which is else block. Let's see that. Let's make this value as 56. So now 56 is not greater than 70. So line 15 will never be executed because this condition will evaluate to false. 56 is greater than 60. No. So this will also be false. And ultimately the grade should fall to else block where we are assigning the grade as F. Let's see. Yes, we get the grade F because ultimately this block was executed because all of the above conditions evaluated to false. So this is all I wanted to cover in this if-else-if demo. There is another addition of another way of writing if statements, which we call as nested if, where we have an if block inside an if block inside an if block, and so on and so forth. How do we write that? And how does the control flows in that kind of an execution? We will cover that in the next session. Let's get started with using nested if statements in Java. Now, in the previous lecture, we saw how we can use an if-else block and also an if-else-if-else block. But there is another case where we can use these if statements, and that is when you have nested if blocks. When would you use it? Let's take an example. Let's say you have multiple conditions to check on a particular program, and where the output of the first condition is the input of the second condition, and the output of the second condition is the input to the third condition, and so on and so forth. If you have that kind of situation, you can write it in a nested if statement kind of block. So let's understand this with the help of an example. As you can see, I have opened an example here, which is about nested if statements. I've created a class which is named as nested if demo, and I have created a public static void main method inside this particular class. And now I have declared an integer variable with the value 50. Then I'm checking the first condition saying if I equal to 50. If that condition is true, then I will check the next condition, which is if I is less than 75. And then I am adding one more hypothetical condition saying if this is true, then also check if I is less than 55. So you can see if I equal to 50 holds true, then only this condition will be executed. Similarly, if I is less than 75, then only this condition will be executed. So they are dependent upon each other. This condition block is dependent upon the previous block to be true, and this if condition block is dependent upon this if block to be true. If either of these if blocks don't go true, the next subsequent nested if block will not be executed. So in this case, I'm checking it for first equality condition, saying if the value is equal to 50, then execute this statement at line number 10. Then check if I is less than 75. If that is also true, execute the statement at line number 12. And then if I is also less than 55, then also execute line number 14. I can also add an else block as well anywhere in this nested hierarchy if I want to. If I add an else block here, that else block will be corresponding to this block. If I add an else block here, then that else block will be corresponding to this if block. And if I add an else block here, then that else block will be corresponding to this particular if block. So you can also use those else if and else blocks as well with nested if blocks and make it as complicated as you want it to be. So that's about this program, and let's see if we run this program, what output do we get? And let's interpret that output. So I've just right click, run as Java program, and I see some output in the console. First, I get I is 50. So line number 10 gets printed because I is 50. Then I also see the next line output as I is smaller than 75. It means this condition was also true because 50 is less than 75. So line 12 also got executed. And then I'm checking if I is less than 55. So yes, 50 is less than 55. So line 14 also gets executed, and we get this statement on the console. So this was a simple way to see how we can implement the nested if conditions. Now we are also going to talk about another concept which is used in writing the if conditional blocks, which is called ternary operators. So ternary operators are used as a shorthand of writing if-else block. As you can see that these if blocks are quite verbose. We have to write a lot of code to actually write some conditions. In this case, I'm executing 3 conditions, but the code is almost 7 lines or 8 lines. So we will see how we can simplify this if we use a ternary operator. And for that, I have created another class, which is called ternary operator demo. And this particular class again has a public static void main, which is the entry point of this particular program. And then I have declared a couple of variables. First is int a equal to 1, and second one is int b equal to 2. I have also declared a result variable, and we will see how we can use this result variable. And at line 10, I have written my if-else expression. So you can see this if-else expression doesn't look like the one which we have seen before. So let's understand how do we write it. If you're trying to write an if-else expression with ternary expressions or ternary statements, then the first thing which you need to understand is the structure of it. So here, at first, you will specify the actual condition which you want to test in your if block. So this is my condition. Then after that condition, you're going to put a question mark. And after the question mark, you are going to put the actual result which you want to be executed if this condition becomes true. So if the if condition becomes true, what do you want to do? Whatever is that, you will write it here. And then if the condition becomes false, then the logic should go into the else block and the else logic should come after this colon. So all you need to remember is this question mark and this colon. Before the question mark, you're going to write the condition. After the question mark, you're going to write the statement which is going to be executed if this if condition becomes true. And after the colon, you are going to write the else block condition which is going to be executed if this condition becomes false. Another thing to notice is that ternary operators can be used only in cases when you have only one statement to execute in if block and one statement to execute in else block. It cannot be more than one statement. So instead of this, you can also write system.out.println here, which will also be fine. If I just write this system.out.print, not printf, but I want to write println, so I'll just write println. You can also do this. This is also fine. You don't need to store the result, obviously, but you can also write this condition in a way. But this only has to be a single statement. It cannot be more than one statement because this expression can only hold one statement at a time. So use it in situations where you have to check a condition and do something in the if block, which is only one statement, and again one statement in the else block. The same expression can also be written in a verbose if-else way in which we have been seeing it before. And I will also show that to you. And here, where this A and B is going, this is getting stored in this variable called result. So if this if condition holds true, then the result is A, and this is going to be stored here. And if it is going into the else block, then B is going to be stored in the result block. Let's run this program. So we can see we get the value 1 because we have set the condition as A less than B. So yes, 1 is less than 2. So this particular statement gets executed and this value gets stored here in the result variable. So that's how you can use the ternary operators to write shorthand if-else statements. The same expression can also be written in a verbose way. For example, you can write it in this way, saying if A is less than B, then result equal to A, else result equal to B. This code has exactly the same effect as this one line of code. So you can see this is pretty simple to write, pretty short to write. The code which I'm writing here in 4 lines can be written here in 1 line, and that's the power of ternary operators. So this is all I wanted to cover in today's session. So we talked about nested if statements and the ternary operators here, how to use them. In the next session, we are going to discuss about switch case statements. Let's get started with using switch statements in Java. So let us first understand why do we need switch statements. Generally, whenever you want to check a condition, you can use an if-else block. But what if you have multiple conditions to check? What if you have so many possible execution paths that it becomes too verbose to write it into an if-else kind of block? What if you have to check on constant values of certain expressions? How do you do that? It becomes even more challenging and the code becomes even more verbose. So in such cases, switch statement can be used in which you can write switch statement to have as many possible execution paths as you want, and it will work with constant values as well. So let's understand this with the help of an example as how and why will we use the switch statements. So for that, I have created this class which is called switch demo, and it also has a public static void main method, which is the entry point. And in this program, what I'm doing is I'm trying to accept a number as the month number in the program. And then with that particular number, I'm trying to print the corresponding month's name. So that's the logic. Pick a month number and you should get the month's actual name. So now in this case, you can imagine there will be at least 12 if-else if blocks, which is a long line of if-else statements. At the same time, if we try to do this for other conditions where the value is constant, please understand that the value of month is going to be constant. It's going to be the same number. So it's not similar to you evaluating a condition. It's similar to you evaluating a condition to a particular constant value. Imagine if you have to do some sort of a classification of employees in higher salaries and lower salaries, and there are hundreds of salary bands in the company. So are you going to write 100 if else logics? That is going to take a long time. And then what if new bands get introduced? Then it gets even more complex. So we will use switch case statements in cases where there are lots of if else conditions and the expression evaluates to a constant value. Remember, in the if else cases, the expression evaluates to a Boolean value. So here I'm supplying the month value as 6. Then I'm also creating a string month string variable just to print or store the name of the month. And then the way you write the switch statement is to write the switch keyword, and then in the brackets you supply the month integer value, and then you start writing your conditions. So you can see you write the case as keyword, and then you write the number or the possible values this particular variable or this particular expression can hold. So all the possible values this particular expression can hold will be written individually as cases. So case equal to 1. Here 1 means the value of month is 1. In that case, the month string which we created here shall store January. And then we see a statement called break. So break is again a keyword in Java, and this keyword has a special meaning. It has a special usage. You will use the keyword break to abruptly break the control of execution from the current code block, and the code block is identified with curly braces. So here you can see the curly brace starts from here and it ends down to line number 51 at here. So the moment your Java program is going to encounter this particular statement, it is going to jump out of the current code block execution and continue thereafter. That's the basic logic and usage of break statement. So use it whenever you want to skip the rest of the code after the break statement. If you don't want to execute the rest of the code, you will write break, and the moment the Java program sees this particular statement, it will jump out of the current code block specified by the curly braces and will resume execution after the code block. So in this case, it will resume the execution after the line 51. That's the usage and meaning of this expression called break. So in this case, we are saying that if the month value is 1, which we denoted as here, case 1, then store the value of the month string as January and break out of this particular code block, because we don't need to execute any further. We have found a match. Then another case would be if the month value is 2. So you write case, which is a keyword, and then the exact expression value, the constant value, which is 2. And if that's the case, then month string becomes February. And again, you break, because in this particular case, there will only be one condition true at a time. There will never be a case that month with the value 2 will have two meanings, will have two month names. A month with the value 2 will always have a meaning called February. It will never have two meanings or two month names attached to the same integer value. And that's why you do not want to execute any further. And that's why you write this break statement. If you do not write this break statement, it is going to evaluate all of the cases one by one. Even if the cases are not going to be true, but it is going to waste a lot of processing time evaluating all the case conditions which you have written here, which does not make sense, because we know that only one condition at a time can be true here, because we are evaluating and checking for a constant value, which is an integer value. So that's the reason we put a break in each case. If intentionally, if you want to check multiple cases, do not put a break statement, but the program can become really confusing in that case. So take your wise call. So here we put a break in each case. Similarly, case 3, the month string becomes March. Case 4, the month string becomes April. Case 5 becomes May. Case 6 becomes June. Case 7, we have month string as July. Case 8, month string is August. Case 9, we store the month string as September. Case 10 as October. Case 11 as November. And case 12 as December. After that, you will also see an interesting block called default. This is the another capability of switch statement, that what if none of the above conditions hold true? What if we specify a value which is not between 1 and 12 and it will not match any of the cases which we saw just above? And if you want to execute some code in that case, if none of the conditions matches, you may want to execute some default execution. Also, in such cases, you're going to use default. Default is the code block which will be executed if none of the case matches. So here you can see that if none of the cases match, then we are going to store the value of month string variable as invalid month, and then we'll eventually break out. And once we break out of this program, we just want to print the month string. That's all we are doing in this program, that we take an integer value as the month number, and then we print the corresponding month name here by looking at the case blocks. And we also define a default case block if none of the conditions hold true. So let's run this program. We have specified the value as 6, which should result in the month name as June. And yes, we can see we get June. Let's change the value and let's put the value as 10 and see what do we get. So right click, run as Java application, and we got October. Yes, exactly correct. Let's put an invalid value as 13 and let's see what happens now. Now we get invalid month. So our default code block just got executed because we entered a value which is not matching any of the case conditions which we have specified. So this is how you are going to use the switch and case statements while writing your conditions whenever your condition evaluates to multiple constant values. Remember, the key here is to understand if your expression is evaluating to multiple constant values which do not change. And in those cases, using a switch case block is a better idea than writing if-else statements. So that is all what we are going to cover in today's session. And in the next session, we are going to understand something about two-dimensional arrays and multi-dimensional arrays as well. Let's get started with understanding arrays in detail. We have been talking about arrays throughout this course of Java in the previous sessions as well, and we have covered some basic understanding of how to create arrays, how to declare them, how to fill values in the array, and how do we print the array with positions as well as the array as whole. But whatever examples which we took previously were one-dimensional arrays, because arrays can have more than one dimensions as well. You can create a one-dimensional array, you can create a two-dimensional array, you can create even a three-dimensional array, and you can go up to as many dimensions as you can handle in your Java program. So it depends upon the kind of complexity you want to have in your program and the kind of values, the kind of structure you are going to store in your arrays. And based on that need, you can choose whether you want to use a 1D array or one-dimensional array or a 2D array or a 3D array and so on. In these sessions, we are going to talk about 1D arrays, 2D arrays, and 3D arrays. And after that, we'll leave up to you to try out more dimensionals if you want to. We have already covered the basic array structures, which were one-dimensional arrays. So I will just give you a quick walkthrough of how we actually handled one-dimensional arrays. So this is a sample program to demonstrate one-dimensional arrays. If you remember, this is how we used to create arrays. We write the data type of the array, and then we write the square boxes, which denote that this is an integer array data type. We assign a variable to this, and then we initialize the array with the size 4. So new is the keyword which is used to initialize anything in Java. And we are going to use this heavily when we talk about classes and objects and even collections. Literally any object which you want to create in Java requires a new keyword. So here I'm writing new and then int 4, which means create an array of size 4. And then I'm filling the value of the 4 positions which I have created as part of this array. And if you remember, when we create these kind of arrays, we store them in a 0 index based position. The first value gets stored at 0th index position and then so on and so forth. So it will always start from 0 and never start from 1. Remember that. And after that, we just print all the values of individual positions of the elements in the array. And if I just run this program, all of the elements of this particular array should be printed one by one. So if I just show the full console of the output, you can see that element in index 0 was 10, element in index 1 was 20, element at index 2 was 30, and element at index 3 was 40. So this was just a quick refresher of how one-dimensional arrays can be written. And whenever you declare a very simplistic array, it will generally be a one-dimensional array. Now let's look at the two-dimensional arrays and how do we write them, when do we need them. For that, I have created another example, which says two-dimensional array. I just created a class and it has a public static void main method, and I've created a two-dimensional array this time. So let's understand this two-dimensional array in a bit detail. And when do we need that? Generally, you would need to use two-dimensional arrays whenever you are trying to do any matrix calculations. If you understand what do you mean by matrix, it's basically a 2x2 structure which stores the values in the form of rows and columns. So imagine a table of 2 rows and 2 columns, then it will be a 2x2 matrix. So if you want to store that particular table in a Java program, you would need to store that as a matrix, as a two-dimensional matrix, rows being the one-dimensional and column being the other dimension. And that's what we are doing here. And if you want to store that 2D matrix in a Java program, the approach and the procedure for it is pretty similar to how you create a one-dimensional array with slight changes. The first change is instead of a single square bracket, you're going to write 2 square brackets because it is a two-dimensional array. So remember, the number of square brackets you are going to put while initializing and declaring the array is the number of dimensions which your array is going to have. Since this is a two-dimensional array example, that's why you see 2 brackets here. If this was a 3-dimensional array example, you will see 3 square brackets here, and so on and so forth. So that's the first part of it. Second part to understand is to how to store the data. Remember, I told you always imagine the structure of rows and columns whenever you are trying to store a two-dimensional array in Java. So what are rows and what are values, and how do you represent them while you declare and initialize a two-dimensional array? So you start with the curly braces as a normal 1D array, but inside the curly braces, you create nested curly braces blocks. You can see 3 blocks here. They start with their own curly brace and end with their own. Then this curly brace starts here and ends here. And then this curly brace starts here and ends here. Idea is that you provide this outer curly braces to define the overall structure. And then inside each of the curly braces is going to represent a row in your two-dimensional array. So each of these values, these blocks, is going to represent a row. So I can say that this is the first row, this is the second row, and this is the third row. And if I try to visualize it in terms of columns, then this is the first row, first column, first row, second column, first row, third column. Similarly, second row, first column, second row, second column, second row, third column, and third row, first column, third row, second column, and third row, third column. So individual values are going to be represented as columns, and the whole curly braces is going to be represented as arrays. That's the basic mental idea or mental image you should have while declaring a two-dimensional arrays. Remember to declare the rows inside the nested curly braces, and whatever elements you have will automatically be indexed as columns. Another thing to remember that since this is an array data structure, everything starts from 0 and nothing starts from 1. So this will be row 0, this will be row 1, and this will be row 2. I'm talking about the position. We can still call it as first row, second row, and third row, but the position of this particular row element is 0. The position of this particular row element is 1, and this particular row element is 2. Similarly for column as well, this is column 0, column 1, and column 2. Similarly, column 0, column 1, and column 2, and so on and so forth. Once you understand this data structure well, and you have defined it correctly, then everything should fall in place. If you want to do a matrix addition, or if you want to do a matrix multiplication or a dot product, all of the kind of calculations can be performed using the 2D array concept. Here in this program, what I'm doing is I am printing the values of this particular 2D array into a matrix style. And you see some strange code here, which is for etc. Don't worry about this. I'm going to cover in detail what this for means and how do you write this. For now, what we can understand that we just want to print this. You might not need to print this in your Java programs when you write a production grade application, but you might want to do manipulations on these arrays as metrics. Maybe you want to create a transpose of a matrix, or you want to do a dot product or addition or subtraction or whatever be your use case. In this case, just for demonstration purpose, I'm printing the values as rows and columns, nothing else. So this all of this code from line 8 to line 14, or in fact line 13, is just showing how to print the values. You can see some system.out and you can see some construct here. And like I said, don't worry about this. I will cover this in detail. Let's run this program and see if my Java array is stored correctly and how can I represent this. So you can see I have represented it in a style of a 2D matrix where this is the first row, this is the second row, and this is the third row. Similarly, this is the first column containing the value 237. So column 0 will have value 2, and column 1 will have this value 3, and column 2 will have this value 7 for row 0. Let me also do something here which can help you understand this concept better. Let me do a system.out.println and let's print an individual value, because like I said, the for loop can be confusing here to understand. So let's say I want to print ARR of 0th row, first column, and see what kind of values do we get. Let me comment this code. Comment is control \, and this code will be commented, and this code will not be executed. And now only line 15 will be executed instead of the 4 block. So if I run this, I get the value 7. So row 0 and first column. Row 0, first column is 7. Let's try with 1, 1. I want to print the row at 1 position. Remember, not the first row, but the 1 position row, which is basically technically the second row. So second row, second column, and see what kind of value do I get in this case. I get 6. So second row, second column. Similarly, if you change this value to 2, then third row, second column, which should point to 4. Yes, we get 4. Similarly, you can write a value here as 0, and you can write a value here as, let's say, 2. This will print the 0th row and the second column. So similarly, whatever kind of value you want to write, you want to access, you can access it in this fashion. And remember, the column and row indexes will always start from 0. So this is a simple demonstration of how you can use 2-dimensional arrays. And in this session, we also did a refresher of 1-dimensional arrays. So that's all for this session. And in the next session, we are going to be discussing how we can define 3-dimensional arrays, and we'll also see an example of it. Let's get started with how to create and use a 3-dimensional array, or how to go about using multi-dimensional arrays in Java. So as you can see from this image, we talked about 1D array, which is having just one axis. Then we talked about 2D arrays in the last session, where we had rows and columns, basically an x-axis and a y-axis. And then we can also have a 3D array, which will have 3 axes, which will have an x-axis, a y-axis, and also a z-axis. Think of a simple box, which every box in this world will always have at least 3 dimensions. And from here, you can go even build more complex arrays, which can have 4 dimensions or 5 dimensions or as many dimensions as you want it to have. And today we are going to look at an example of how can we build a 3D array and how do we access those elements. But this picture is just to show you the mental model of when you will be creating a 3D array. So for example, generally an image data is stored in 3 dimensions. So you might want to store the image data into a 3D array. And there can be many other use cases in the mathematical and research computational use cases where you might want to use a 3D array. So, but remember, there's an x-axis, there's a y-axis, and then there is a third axis, which is called the z-axis. So let us look at a Java program to understand how we can build a 3-dimensional array. And for that, I have created this class, which is called multi-dimensional array. It has a entry point method, which is the public static void main method. And then I have created an integer array. And this time, instead of 1 or 2 square brackets, I have 3 square brackets. And if you remember, I mentioned this in the previous session as well. The number of square brackets which you're going to put while initializing the array is the number of dimensions of the array. And since in this particular program, I'm going to demonstrate a three-dimensional array. That's why you see three square boxes. Let me just minimize this. Yep. So we have three square boxes here, and we have created the variable name as ARR, or short form as array. Then we start with the outermost curly braces as is. Then we put another curly braces which starts from here and it ends here. Then another set of curly brace which starts from here and end here. So this is the first dimension. This is the second dimensions, and these are the third dimensions. That's how you're going to define the different dimensions. Remember, this is the first dimension when the first curly brace starts. Then you have this second dimension which covers this hole and this hole, and then you have third dimension which are these. So that's how you're going to visualize and put the three dimensions in use while declaring a three-dimensional array. And the values work in the same fashion. It's a zero index-based position. So since we do not have an official name for the third dimension, so I'm just going to use x-axis, y-axis, and z-axis to refer to the three axes. So this would be x of 0, this would be y of 0, and this would be z of 0. Similarly, x of 1, y of 1, and z of 1, and so on and so forth. So now if I try to access the value which is at 0th x position, first y position, and second z position, what's the value do we get here? Let's run this program and understand and interpret the output. Okay, so when we ran this program, we got the output as 11. So let's understand this output. So when we say the 0th position on x, the first position on y, and the second position on z. So this is the 0th position on x, and this is the first position on y, and then this element is 0, 1, 2 is the second position on the z-axis. So to describe it in a nutshell, this defines the x-axis. So we have two elements on the x-axis here, this one and this one. Then we have two elements on the y-axis on each x-axis. So this is 1, this is 2 on the first x-axis, and this is 1 and this is 2 on the second x-axis. So 2x and 2y, and then on the z-axis I have 3 elements each. So hope this helps you understand and visualize this. So x-axis, and this one is other x-axis, and then y-axis, and then in elements inside this are z-axis. So I'm saying 0th x-axis in this block, first on the y-axis, which is this block, and then second element or the z or second position element on this particular axis in this particular block, which is 11, and that's why we get 11. If I print 0, let's say I change this particular value as 1. So now the output should be coming from this side. So second x position, because it's 1, second y position, so this will go here, and then the 2 position, which is the third element of the z-axis, which is 13. So let's see if we get 13. Yes, we get 13 here. So this is just to show you how you can interpret this particular array, and always be mindful of how you are structuring this array. If your structure is gone wrong, then your program will become useless, and it will give you a lot of unpredictable outputs which might not make sense and which may introduce errors in your program. So be very careful how you define the structure of the elements here. That's the key. And after that, you just need to understand the x-axis, the y-axis, and the z-axis. Always remember all the axes start from 0. So when I say 2, I'm basically referring to the third element and not the second element. So this is all I wanted to cover in this particular session, where we describe how we can use a three-dimensional array. And from here, you can go to any lengths. Like I said, you can add more square brackets here and go to 4-dimension or 5-dimension or 6-dimension. But remember, the more dimensions you add, the more complexity of the program will be having. The program will become more and more difficult to debug and understand. So always try to take a wise call as to how many dimensions you want to use in your array. And that's it for this particular session. In the next session, we are going to talk about the different loop statements in Java. Let's get started with today's topic, which is about how to use do-while loops. Now, in the previous session, we covered the usage of while loops, but we have another type of while loop which is called a do while loop. So let's understand when do we need that and how do you actually use that. Let me switch to the Java documentation and if I can find some syntax of it as well. Yep. So as you can see here, if I just highlight this portion, this is how you actually write a do while statement block. So you write do, you start a code block, you write some executable statements, and then after the code block ends, you write a while expression and end it with semicolon. This is the syntax basically. It starts with do or curly braces, some executable statements, a while block or a while statement basically with an expression ending with a semicolon. Let's understand this with the help of a program to understand the structure better. So for this, I have created a sample program here, which is called do while demo. Again, having a public static void main method, and it has a variable which is count, and it is initialized as 1. Then I write do, I write this code block or the curly braces, and then I am just printing the value of count. Then I am incrementing the value of count, and then I am writing a condition which says while count is less than 10 and semicolon. If you compare this with the previous demo we ran, if I just put them side by side, we had while condition statement and the state change condition. Here we have do statement, condition change statement, and then we check the condition at the end. So the idea is that if you have a use case where before you even evaluate the condition, you want to print something, even before you evaluate the condition, if you want to do something, in that case, you will use the do while loop. Even before the actual while loop starts, if you want to execute a statement, you will use do while loop. For example, if you want to print the initial value of the count even before the condition checks, then you can use do while loop. If that is not your use case, you can use a simple while loop, which is described here in this program. So coming back to the do while, so I say do, and then I'm saying print this particular statement without checking anything. This condition will be executed for the first time without any condition check at all. This will just work as is, like a normal Java statement. After that, I'm incrementing the value of the count, and then I'm checking the condition. So remember, when this particular condition is being checked, the first increment has already happened. But in the while case, we did the comparison before even the first increment. The first comparison happened with the original value of count. But here, the first comparison is happening with the incremented value of the count. Hope you get the difference in a better context now, that you will use this when you want to write some initialization code before you actually hit the condition. So this condition will be evaluated with 2 less than 10, and then the value will be printed. Let's print this example, and we'll also try to play around with this example a bit more to build our understanding better. If I run this program, there is no difference in output if you compare this with the previous program we ran for the while. So it prints the count value. So this is coming here. Then it increments the value. Then it checks the condition saying is 2 less than 10. Yes, that holds true. If that holds true, it will go back to statement number 9, again print this, again do an increment on the count, and again check the condition with the updated value of the count, which will say 3 less than 10 now. Similarly, print the value, increment, check. This will continue to happen till this particular condition becomes false. And once this condition is false, it will exit out of this whole do while loop, and it will go to the line number 12. And if you have any statement written there, you can that statement will be executed in this case. So let's try to change some values here, and let's see if we can make sense of this program if we change the value. Let's say if I put 11 here, what will happen now? Let's run this program. You will say now you will see that this particular output is displayed which says count is 11. So what happened here, that count was 11. It entered the do while block. It went to this particular statement which said count is 11. Then it incremented the value. So the value became 12. And obviously 12 is not less than 10. So it did not print it again. It only printed once, even if the first time the condition was checked, the first condition execution itself resulted in false. Still, line number 9 got successfully printed. And that's the whole That's the whole idea behind using the do while. What if I change this value to 10? Let's see what happens. And after that, we'll run one more combination to just make it more interesting. This time again, count is 10. Line number 10 will be printed as count is 10. Then at line number 10, the count is incremented to 11, and 11 is not less than 10. So in this case, the loop ends and it will move out. Now, what happens if I do this? If I say less than equal to here, let's run this program and interpret the output. Now, again, only one statement is printed because in this case, the count is 10, 10 is printed here, and we are saying 10 plus 1, 11. 11 is still not less than equal to 10. And that's why the loop just exits. Let's make it 9 and see what happens. Now you see two values. So count is 9. It enters the do while loop, goes to statement number 9, prints the current value of count, which is 9, then increments the value to 10. Then at line number 11, this while statement is executed and the condition is checked. Is 10 less than equal to 10? Yes. 10 is not less than, but 10 is equal to 10. So this condition will hold true. It will go back here, print count is 10, make count 11, again check the condition, is 11 less than equal to 10? No, it's not. And then the condition will return to false and loop will be exited. So hope this will give you a better understanding now, since we ran different permutations and combinations of the values and we saw when this will be executed and when this will not be executed. But the bottom line is very straightforward, that whenever you want to write some pre-processing logic, even before checking the very first condition of your loop, then in that case, you will be using a do while loop. Otherwise, a normal while loop or a for loop will absolutely work fine. So that's the takeaway I would like you to take away from this particular session. And that's all for this particular session. We talked about do while, and we also tried to give you some sort of a comparison between while loops and do while loops. In the next session, we are going to be discussing about for loops in detail. Let's get started with understanding the loop statements in Java. So first of all, understand why do we need loop statements? So generally, whenever you are dealing with some data structures in Java, which can store multiple elements, for example, we saw array, which can store multiple elements. String is also basically technically a character array, which is storing multiple characters. So whenever you have these kind of data structures where you have multiple elements being stored in the same, then in that case, you would like to have a way to iterate or access all of the elements in a seamless fashion. One of the ways is to access them individually one by one, but that's too much of work. That's too much of code. There has to be a simpler way of accessing all the elements one by one if I want to. And that's where the majority of the use cases for using loops coming to picture. Now, Java provides multiple constructs to write loops in Java. There is a while loop, there is a do while loop, there is a for loop, there is also an enhanced for loop. And in the previous versions of Java, a use case of iterator was also very popular. So there are multiple ways in which you can actually iterate over a collection and access all the elements of the collection one by one. And you can use it to multiple useful cases. For example, if you have a huge array of employee salary and you want to give bonus to each of the employees and add the bonus to the salary, then you need to do this addition for all the employees. It would be nice to have to return a while loop, and the while loop can automatically access all the employee salary one by one and keep adding the bonus to the salary. This would be an easier way to do this rather than individually updating each employee's salary. And the first loop statement we are going to understand is a while loop. So the syntax of while loop is very straightforward. You write the while keyword, you enter the actual condition which will be evaluating to a Boolean true or false. So you write the expression which will be a Boolean expression, exactly similar to the conditions which you use to write in your if statements. So you write your condition which will evaluate to either true or false, and then you write your statement. And these statements will keep executing till the time this particular expression evaluates to true. So generally the way it works is that it will enter the while block, it will evaluate the expression. If the expression becomes true, then the statements inside this particular while block will be executed. And after the execution of the statement, it will again go back, again evaluate the expression. We call them steps basically. So it will go to the next step, again evaluate the expression. If this still holds true, it will again go inside, execute the statement, move on to the next step. It will again go to the evaluation. So this loop will continue to go till the time this condition will hold true. If it still doesn't make sense for you, don't worry, we will have a demo of it to make you understand how to use the while loops. And maybe it's a good idea to switch to the IDE and look at an example of it. So I have already created while demo for it. Here it is. It looks very small and simple, but it will get to the point where we can understand how and why will we be using the while loops. So I've created a while demo class. I've added a public static void main method here, which is the entry point. I have declared a variable which is int count equal to 1. So the count value is 1 right now. And then I'm writing a condition here. I'm saying while count is less than 10, do this. So it will print the current value of count. And after that, I'm using the post increment unary operator. If you remember, we covered this in the previous sessions. What is the meaning of this? It basically will increment the value of count by 1. This expression is equivalent to if I write it in this way. If I write count equal to count plus 1. This is exactly the same as this. No difference. So this will have the same impact. I will just remove this line because we already have the count plus plus here. So if we try to understand this, we are basically incrementing the count and then checking the condition again. So at first time, it will be 1 less than 10. Yes, that is true. It will go inside and print the count value, the current count value, which will be 1. And then it does count plus plus. So now the count value becomes 2. It will again go back here, again check the condition saying is 2 less than 10? Yes, that is true. So the while condition again becomes true. It will again go inside this, print the current value of count, which is 2, then do count plus plus. So it will again increment the value of count. So now the count value becomes 3. Again, go back here at condition and saying is 3 less than 10? Yes, that is still true. Again, come here, print the 3. Again, go here, make count as 4. 4 less than 10, prints 4. Again, count plus plus, count becomes 5, and so on and so forth. It will keep doing that till the value becomes 10. So at a step when count plus plus results in the count value being updated to 10, it will go here and say is 10 less than 10? Now that is not true because 10 is equal to 10, but 10 is not less than 10. So this condition will become false and it will exit of this while loop and it will come here and it will execute if there was anything written after the while loop that will be executed. So that's the idea, that you want to do something till a particular condition holds true. Then you can use the while loop, define your condition and execute the statements and try to do something which changes the state of this condition. Here I'm changing the count so that every time a new evaluation happens. If I comment this will result in an infinite loop because 1 will always be less than 10. I will not be incrementing the count here and it will keep running forever. It will never stop. It will just keep printing 1, 1, 1 every time till your computer program runs out of the memory. So always remember not to end up into an infinite loop. That's probably one of the biggest mistakes any beginner programmer does. So please try to be aware of that particular loophole, not try to run an infinite loop. Always try to write something in the code block which can change the state of the condition, and also make sure that that state condition sometime should become false. You should also make sure that always becomes false, because if I do this, then this condition will always remain true because it is already 1, then it will become 0, then it will become -1, -2, -3, so on and so forth. But that value of count will forever be less than 10. And again, you will never be able to exit this loop. Your program will be stuck in this loop till your program runs out of the memory. So always remember to write a statement or a statement of execution in your code block, which can change the state of the condition, which results in some eventual time when this condition becomes false. This condition has to become false eventually, otherwise you will never come out of the loop. Always remember that. So if we run this program now, let's observe the output. So we can see here this particular statement is printed for 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it. After 9, the moment the count plus plus resulted into the count value becoming 10, it checked that condition and then it just came out of the loop because 10 is not less than 10 and the condition became false. So always do something inside your code block which results at least of one scenario where this condition becomes false. And that is how you can use the while loop. Now you can see this is a pretty generic code and you can write any kind of condition here, write any code you want to execute here, and then do something to change the state of the condition as well in a positive way, in a way which results this particular condition to be false at some point of time. And then your while loop will run fine. So this is all I wanted to cover in terms of the while loop. We have a lot of more exciting stuff coming in terms of different loops. And in the next session, we are going to understand how a do-while loop works. Let's get started with for loops in Java. So far we covered about while loops and do-while loops. And we also saw different examples of using different types of data structures like arrays. But one of the core requirements whenever you are working with any kind of collection is to iterate over it. Exactly similar to what I explained in the do, while, and while lectures, that you would often require to iterate over a collection or a data structure. And for that, one of the most sophisticated and easiest way to do that is using for loops. So let's understand the syntax of for loop first, and then we will also look at an example of it in the Eclipse IDE. So I have just opened the official Java docs here. So if you see, this is basically the syntax of a for loop statement. So let's understand it. And let's also try to compare it with a while loop so that we can understand how it compares with the while loop. So if we see the syntax, we first see the term initialization, then we see the term termination, and then we see the term called increment. Now, if I try to compare it with a while loop, there also you basically did these three things. You first initialized a variable outside the while loop, which is called initialization. And then you wrote a condition, which is your termination condition. You wrote a condition saying, let's say, while I is greater than 10 or while I is less than 10. So that is the condition, which is also the termination statement. The loop will continue to execute till that condition evaluates to false, and that's when the loop terminates. That's why we call it as termination. And then the third piece of it is the increment, the I++, which we used to do in the while loops. So these three portions together make or constitute any kind of loop in any kind of programming language. And for loop, if you see, the kind of code which you use to write in a while loop in multiple lines, where you first initialize a variable, then you write a condition in the while block, and then inside the while block, you use to increment the variable. All of that can be done in a single line in the for loop. And that's why I said it is the most sophisticated and easiest way to write loops in Java. So you write all of these three things, the initialization, the condition, and the increment or decrement values in the single line. And then you start with the curly braces and you write the code which you want to keep executing till the condition evaluates to false. That's the basic syntax of it. So let us try to understand this with the help of an example. So here I have opened a class which is called forDemo, and this is a class which will demonstrate the usage of a for loop. So again, we have a public static void main method, which you can see here, which is the entry point. And then I use the keyword for. I put standard braces or the brackets, and then I do the initialization. So this part is the initialization part. You initialize the variable. So I just say int I equal to 1, initialization done. You end it with a semicolon so that it is a single statement understood by Java. And then you write this condition, which is your evaluation/termination condition. So this condition is basically the deciding factor of how long your loops should run. It's exactly similar to what you used to write in the while block. If I just show you the example, this is what we used to do. So we did the initialization at line number 7. Then we wrote this termination condition inside the while syntax or the construct. And then we did the increment here. So we are doing all of these three steps, but we are doing it in a single line. So this is the condition, and then we write our increment or decrement values, which are going to change the evaluation condition every time at every step. So we are saying I++. So technically what I am saying here is that start with I equal to 1 and then check the condition I less than 10. So in the first step, it will be checking if 1 is less than 10. If the condition holds true, go inside the for loop, execute the statement at line number 7, and then go back to this particular statement. So we do I plus plus. So I becomes 2, and then you again go back to the condition. And again you check if 2 is less than 10. Yes, it is. So again you go inside the for loop and do whatever is written there. There can be multiple statements here. For now, I have just written one system.out.println. So that happens. And once all the execution is finished inside the block, it will again go back to the increment. Does the increment, so 2 plus 1 becomes 3. Again does the evaluation. And if the condition holds true, it will again go inside. So this will continue. This condition checking, execution, and increment will continue till the time this condition holds true. The moment this condition becomes false, the control will come out at line number 9. So that's the basic anatomy and control flow. It's very important to understand the control flow of a for loop. Otherwise, you might end up into a program which is forever running and which will just eat up all the memory available in your JVM. So be very sure of what you write in your for loop. Be very sure of especially these two parts, the condition and the increment or decrement. So this is very important piece. The initialization happens only once, and then this condition evaluates. If the condition holds to true, some code executes, goes back to the changing statement, which can be an increment, decrement, whatever, and again compares the updated value with the condition. So this will keep happening. Let's run this code to interpret the output. So I will right click, go to run as Java application. And if I interpret the output here, I can see that it started with count is 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stopped at 9. So what happened there? Let's try to evaluate the termination condition. So let's say I has become 9 and 9 is less than 10. So it goes inside and it prints count is 9, which is I. Then it goes here and it says 9 plus 1. I plus plus means 9 plus 1, the current value of I plus 1. It becomes 10, and then it again compares the condition. So now 10 is not less than 10. 10 is equal to 10, but it is not less than 10. So the condition becomes false, and count is 10 is never printed because this condition has become false. It will jump out. So let's say if I do this, if I put an equal to here, and if I now execute the same program, this time I will see 10 here. And because I have said that, okay, check the condition, if 10 is less than or equal to 10, that will become true. It will print count is 10. Then it will increment and the count will become 11. The I will become 11. And then it will check 11 is less than or equal to 10. No, it is not. So condition becomes false and the control comes out of the loop. So that's how you should always try to interpret the loops. You can also run some infinite loops. For example, if I say I equal to 1, I leave it that, and I say I minus minus. So what happens? I equal to 1, 1 is less than 10. Yes, it goes here, prints the value, and then I decrement the value. I don't increment the value, I decrement the value. So whatever value comes out will always be less than 10, and this loop will run forever. For fun, let's try to run this, and I will have to kill this program manually, but just to show you what happens and what you should not do in your Java program. So you see, it will continuously keep printing the values till the program runs out of memory, till it eats up all the available memory. It is forever running. It will never stop because the condition will never evaluate to false. This condition will forever be true. So the loop will run forever. So I'm just going to kill the program, but this is something which you should avoid whenever you are writing Java code. And this happens quite often with beginner programmers. So this is all I wanted to cover in today's session. We talked in detail about the for loop. And in the next session, we are going to talk about another interesting way of writing for loops, which is also called enhanced for loops. Let's get started with enhanced for loops in Java. So we covered about the for loops and the structure of it and the control flow of it in the previous session. And today we are just going to talk about another way of writing for loops, which is a bit even more smarter than the traditional for loops, which we call as enhanced for loops. We generally use the enhanced for loops for scenarios whenever we have to iterate over a collection of items or an array of items. Those are the most popular and common use cases of using enhanced for loop. And this for loop is even simpler. Like I said, it's even simpler than writing a classic for loop. And the syntax is simply like this. You again start with for, put the standard brackets, and then let's start from the rightmost, because then I will be able to explain it better. You specify the collection in the rightmost side of the bracket. The collection can be an array, it can be a list, it can be a map. So whatever different kind of collections which are available in Java, and we are going to cover collections in detail. So don't worry if you don't understand what are lists and what are maps and what are sets. We will go into detail of each of these one by one in the upcoming sessions. But the idea is that you put the collection to the rightmost, then you put a colon, and then you put a representation of the member of this collection. So for example, here this numbers is basically an int array. So this int array means that this array can only hold integer numbers, and that's why we write int here, because this array is only having integers. Then we put any placeholder variable name. This can be anything. You can even write it as I if you want to. You can write it as anything, any variable name which you want to write. This is a temporary variable. So now this code is going to execute in a manner that it is going to iterate over this array one by one, starting from the first element, going till the last element. You don't need to write any initialization code. You don't need to write any termination condition code, and you don't need to write any increment or decrement code also. And how these three values are actually taken care of, let's understand that as well. So when we talk about the initialization, as I have put an array here, a data structure here, the automatic initialization index is going to be the first index. So when we do the iteration, when this for loop is going to execute, it is automatically going to initialize a temporary variable with the value at the first index, which is the index 0. As you know that array is a 0 index based structure. Then comes the condition part. So the condition evaluation is going to be again based on the size of the array or the size of the data structure which you are using. It is going to start from the first index, which is the index 0, and it is going to iterate till the array's last element is reached. So technically start from the index 0 and go till the last element. That's your evaluation condition. And then comes the increment part. So at each step, after it has successfully accessed the first element, automatically the index is going to be updated to pointing to the next element. So if it starts from here, once the first step iteration is complete, I is automatically going to be incremented to index 1. And then it will basically, this I will be holding 2. Then in the next iteration, the same I is going to be holding 3. Similarly, I will keep holding the new value of the collection item one by one till the collection item's last element is reached. So this is the basic premise, that you can write a collection variable here and keep iterating over it, and this whatever variable you write here will hold the current item's value one by one. So in the first step, this I is going to hold 1. In the second step, this I is going to hold 2. In the third step, this I is going to hold 3, and so on and so forth. That's the basic idea. So now let's run this program to see what kind of output do we get. So you can see we basically are able to print all the elements of the array. And that's probably one of the most popular usage as well, that if you want to just print all the elements or access all the elements of an array or a collection one by one, then just use enhanced for loop. So you can see at each step, it is printing the value of I. And the value of I is basically the subsequent elements of the array. That's the whole idea with enhanced for loop. Under the hoods, if you talk about how does it work under the hood, it is actually using the classic for loop construct itself. But for developers, it is making it easier because it knows that if you are iterating over a collection, you will start with the first element and you will go till the last element. So it knows the initialization value, the termination condition, and it also knows the increment condition. And that's the reason you will use enhanced for loops in Java for iterating over collections. And in the next session, we will be talking about the nested for loops concept, and we will be looking at an example of how to implement nested for loops and when do we use nested for loops. Let's get started with nested for loops in Java. So we talked about the while loops, the do while loops, the classic for loop, also the enhanced for loop. So now we are going to look at a variation of the classic for loops in a condition where we have to use more than one loop in a nested fashion. And how do we do that? What are the use cases when we use that? So in front of you, you can see an example which I have prepared for nested for loops. And in this particular example, I have created a two-dimensional array. As you can see on the line number 6, I have created an integer array and I have put two square brackets here, which are basically symbolizing that this is a two-dimensional array. So this two-dimensional array is going to hold technically a 2D matrix. And we are going to use the concept of nested for loops to print this 2D array in a 2D matrix style where you will be able to see the rows and columns clearly. Let's first try to interpret this particular 2D array. So we have a curly braces outside, and then we have these three inner elements, which symbolizes three rows basically. So this is the first row, this is the second row, and this is the third row. And then each of the rows have three elements each, which symbolizes the column values or the item values. So it's basically a 3x3 2D array, which has three rows and three columns. So we can say that this is basically a 3x3 array, which has 3 dimensions on the row side and 3 dimensions on the column side, or just a 3x3 matrix or 3x3 2D array. So as we know that in case of arrays, everything starts from 0. So technically, if we talk about the indexes, it would be the index 0, index 1, and index 2 on the row side. And similarly, index 0, index 1, and index 2 on the column side. So that's something which you should remember, because we are going to use this particular concept when we write the for loop. So let's try to write the for loop now. If you look at line number 8, we put this keyword called for, and then we write the initialization. So we say int I equal to 0. Then we are writing the termination condition, and we are saying run this particular loop, run this whole loop which ends at line 13 till I is less than 3, and keep incrementing I at every step. That's what I'm doing in the line number 8. Then inside the for loop, I'm writing another for loop which has another different variable called j. It can be anything, you can name it anything you want. And this also starts with 0. And this also has a similar condition which says run this particular loop, the line 10 basically, or this loop which is signified by this curly braces. Run this particular loop till the time the value of j is less than 3, and keep incrementing j at every step. And at line number 10, print the element of array which has the current value of I and the current value of j. These are basically the positions. These are not the elements. The element would be represented by this whole, but print the element which is at current I and j's position values. That's what this code means. So let's try to do a dry run on this particular code to understand how this is going to work. So at first we have I equal to 0. 0 is less than 3, and it goes inside. It initializes j as well with 0, and j is 0 is also less than 3. So this condition went true. That's why we went to line number 9, and line number 9 condition also went to true. So we went to line number 10. Remember that in this particular case at line number 10, the values of I and j are 0 and 0 respectively. And we are saying print the array of 0 and 0. So 0th rows, 0th column element should be printed. So this is the 0th row because this is the first subblock, and this is the first element. So in this case, in line number 10, 2 should get printed. Then it goes here and it increments the j to 1. So 0 plus 1 becomes 1. It again checks the condition, is 1 less than 3? So yes, 1 is less than 3. It goes here. Remember, it did not go up at line number 8. It just came back from line number 9. So when it comes here, I is still 0, but j has moved from 0 to 1. So now we are trying to access the element which is at 0th row, first column. which is going to be 7. So 7 is going to get printed. Similarly, on the next iteration, j is going to get incremented from 1 to 2. And again, the condition will be evaluated. So 2 is less than 3. All good. It will again come back to line number 10. And now it will say print the value of 0 row, third or the second column or the third element. So 0th row, third element, which is the 9. So 9 will get printed. Then again j will be incremented and j will become 3. 2 plus 1, 3. And now the condition will be evaluated. Is 3 less than 3? No, it is not less than 3. The condition becomes false. So it breaks out of the loop, goes to line number 12, prints an empty line because we are not writing anything here. So it will just print a blank line. And now it will go back to line number 8's condition and it will do an increment of I. And now I will move from 0 to 1. And now the evaluation will happen. Is 1 less than 3? Yes, 1 is less than 3. So it will again go to line number 9. Again, initialize j with a fresh 0. The previous j got destroyed the moment you came out of the loop. So this is a new j. So this j again gets initialized to 0. 0 is less than 3. It goes here. Remember, I was 1 in this time. So now it will print the value of this 2D array, which is sitting at 1, 0. Basically second row, first element. So second row, first element, which is 3. Again, j is going to get incremented and it will become from 0 to 1. So 1 is less than 3. Yes, it will again come here and it will print the value of the array, which is sitting at array of 1, 1 for a row equal to 1 and column equal to 1, which will be 6. Similarly, j will get incremented again. Again, 2 is less than 3. Come back here, we'll print 1. Then again, we'll increment j. J will become 3. 3 is less than 3. No, it's false. The condition is false. So it jumps out of the loop, goes to line number 12, prints a blank line, again goes back to 8, line number 8, increments I, and I now becomes 2. 2 is less than 3. Yes, it will again go here, initialize j again with 0, and again does the same thing for the row 2 and column 0, 1, 2. And again, it will come out of the loop. This time, again, when it will go here, the value will become from 2 to 3, and 3 is not less than 3. So then it will break out of the outer loop. So the idea is execute the inner loop for every value of the outer loop. Remember this line because that is how you will be applying your knowledge of nested for loops to be used in certain condition. So whenever you have a scenario where you have to iterate over a collection based on a certain value of another collection, then you can use nested for loops. Or you have a scenario where you have to iterate over 2D or 3D arrays. For example, if we were dealing with 3D arrays, then you would have seen 3 nested for loops here, and where it will apply the same logic that iterate over all the collections, all the values of the inner loop on a particular value of the outer loop. Then increment the value of the outer loop and do the same thing again. Iterate over all the values of the inner loop based on a fixed value of the outer loop. So let's run this program and let's see what kind of output do we get. So like I said, our motive, our target was to print this in a matrix style. And you can see that it is printing in a sort of a matrix representation. So the first row gets printed here, then the second row gets printed here, and then the third row gets printed here. If you try to decipher it, it will work exactly the same way as I explained. So I equal to 0, 0 less than 3, condition becomes true, comes here, j equal to 0, j less than 3, condition becomes true, comes here, prints the array of 0, 0, which is 2, then prints the array of 0, 1, which is 7, 0, 2, which is 9, then j becomes 3, it breaks out of the loop, goes up here, I becomes from 0 to 1, 1 is less than 3, yes, again comes here, reinitializes a fresh for loop with a new j setting to 0, and it will print the array of 1, 0, 1, 1, 1, 2, then similarly array of 2, 0, 2, 1, 2, 2. So that's basically what we are doing. We are iterating, we are picking the first row and iterating all elements of it, picking the second row, iterating all elements over it, and so on and so forth. You can do this for any n-dimensional kind of array or a collection. So this is all I wanted to cover in today's session, where we discussed about the nested for loops concept and how and where we will use it. And in the next session, we will be discussing about the Java collections framework. Let's get started with collections in Java, or the collections framework in Java. I must say that this is probably the most important concept of the Java programming language, which you will be using heavily whenever you are working in any production grade application. So let's understand the collections framework and the different classes and the utilities available inside the collections framework. This is going to be a theoretical lecture because there is a lot of ground to cover in this lecture. So we will only focus on understanding the relationship between the classes, why those classes are created, because each class has a different purpose in this framework. And we will obviously talk about the hierarchy as well. In the upcoming sessions, we will go into the hands-on exercise of some of the most popular collections. We will not be able to provide hands-on of all the collections classes which you can see on the screen, because then it is going to take a very long time to complete this concept. But we will cover the most popular ones or the most used ones out of this particular framework. So let's get started. As you can see, let's first understand some of the symbols here, and let me just zoom this in a bit so that it's visible. Yep, now I have just increased the resolution a bit. So you can see there are three different symbols or legends here. You see this oval shape, which is called interface. So you can see some interfaces here. Then you see this rectangular blue box, which is called abstract class. And you can see some of these blue boxes. And then you see the purple box, which is called the class. And you see some classes here, these ones. So for now, we haven't covered the concept of interfaces and abstract classes, but we will cover that in the coming lectures. And for understanding the collections hierarchy right now, at least the concepts of it, you don't need to be fully aware of the concept of interfaces or abstract classes. So let's dive deeper into the framework. Iterable is basically an interface. To give you a very simple definition of an interface basically is sort of a declaration which will tell you what kind of classes will be present under the interface. For example, if you have to, let's say, store all the cars and all the bikes and all the bicycles and all the trucks from all around the world, then you can create an interface called vehicle and create all of these classes under the interface. And these classes will be about cars, about trucks, and about other kind of vehicles. So an interface is a generic blueprint of specific class implementation. That's a very simple definition of an interface. And like I said, we will go deeper into this concept in the upcoming lectures. So that was about interfaces. Similarly, when we talk about abstract classes, the next legend here, abstract classes are also similar to interfaces where they provide you a generalization, but at the same time, abstract classes provide you a way to also write some concrete implementation. For example, if we take the example of a bank account, so there in a bank, you have different kinds of accounts. You have savings accounts, you have recurring accounts, you have current accounts, and there are many other different types of accounts. So there would be some common implementation and logic which will be applicable to all the account types. For example, an account must have an account holder. That account holder must have a valid KYC done, for example. So there would be some sort of common logic which will be applicable to all of these, right? So that common logic, so you have two options. Either you can write that common logic again and again in the savings account class, in the current account class, in the loan account class, etc., or you can write it at a central place and just refer it from there. So that's where you will use abstract classes. So you will create an abstract class of an account, and then you will create these child classes under this account class, which will be the savings account class, the loan account class, the current account class, etc. So this is a very lightning introduction to you about interfaces and abstract classes. And class, as we know, is basically a concrete blueprint which holds data and logic together. So here iterable is an interface which will just specify that all the kinds of data structure which can be iterated, which can be looped over, should be present under this particular interface. That's why we created this interface. So under iterable, we have this collections interface, and this will govern that everything which will present under the collection interface will be holding some sort of a collection of items. Now we look at the next set of interfaces. We see a set interface, we see a list interface, and we see a queue interface. When we talk about the set interface, these three different types of interfaces represent three different properties of collection, and these properties are exclusive of each other. For example, if we talk about set, so set has a property that everything which you put into set will be unique. It will never ever tolerate or contain any duplicate elements. That's the property of set. So now you can see whenever you have a scenario where there is a strict constraint that your collection should never have duplicates, you will use sets. When we talk about lists, list is probably the most lenient representation of a collection. It can store anything. It can store duplicates as well. It will not raise an error or a warning if you store same element multiple times. It will happily store it. But at the same time, the list is basically an index-based collection. You can access the elements starting from the index 0 till the last element. That's the basic value proposition. So whenever you have a requirement where you want to access the elements into a predefined sequence and one by one, then you should use list. Also, the order is fixed here. The first element will always come after the 0th element. The second element will always come after the first element. So whenever you iterate over this particular list, you will never have a scenario where you do not know the order of the elements being accessed. They will always be accessed in a predefined order. So it's basically, we can call it as an indexed ordered collection which can hold duplicates. Then the third one is queue here. So queue is basically, as you can, this is basically inspired from real world. So think of any queue. If you go to buy something at a grocery store, or if you go to buy a ticket at a railway station, or you go to the check-in counter at the airports, so you stand in a queue. And the concept of queue is that it works on a concept of first in, first out. The person who first went into the queue will be the person first being served and coming out of the queue. And if the second person comes, that has to be standing behind the first person. And once the first person is served and goes out of the queue, the second person comes at the front of the queue, and that particular person is served. So you can see it's if you have to store that kind of behavior, or if you have to implement that kind of behavior in a Java program, then you would use queues. So this was about the top level interfaces, which are set, list, and queue. And out of these, list and set are very, very popularly used, very heavily used in any kind of Java enterprise grade application. Now there are more interfaces like sorted set, navigable set, and dequeue. Sorted set is basically forcing additional constraint on the set that the elements will be unique. At the same time, you can also have the elements into a sorted order. That sorting can be an incremental sorting or decremental sorting, that depends. But the whole idea is that it will be sorted. Similarly, navigable set brings another navigation kind of properties. Dequeue is basically a double-ended queue where the elements can be inserted and removed both from the front and from the back. So there are the different properties of these interfaces. But like I said, the most popular ones are these three ones. Now let's talk about the abstract classes. So the abstract classes you see here are abstract collection, abstract set, abstract list, abstract queue, abstract sequential list. Generally, you will not be using these directly. You don't need to use them directly, but you should be aware that they exist. If you have a very specific case where you want to use these abstract classes, you can use them in Java program, but most of the time you don't need to use them. And most of the times you will be dealing with either the interfaces or you will be dealing with the concrete classes. Now this lecture is getting a bit long, so I will like to stop this lecture here. So we covered about the interfaces part of the collection, and we also understood a bit about the abstract classes, though we are not going to use abstract classes in much detail in the programs. In the next session, we will cover the second part of this collection framework, or the remaining part of this collections framework, which is around the classes. Let's get started with discussing the concrete classes in the collections framework. In the previous session, we talked about the interfaces part of it, where we discussed about sets, the lists, and the queues, and we also touched a bit upon the abstract classes. And like I mentioned earlier, you don't need to generally use these abstract classes directly in your Java program, but you must be aware that they exist. You see some arrows here, right? If I just scroll up, you see multiple kind of arrows here. These arrows mean that if the arrow goes from bottom to top, it means this particular element is a type of the parent. It's basically denoting a parent-child kind of relationship. So for example, here you see tree set is basically a navigable set, and also extends abstract set, which extends set. So similarly, you can see all kind of complex relationships here, and generally you don't need to remember all of those. You only need to remember the few, and those few are basically easily can be spotted. For example, whenever you see a tree set, it means it's basically a type of set. Whenever you see a word called list, that means that it is a type of list. And whenever you see a word called queue, then it means that it is a type of queue. So let's understand these classes. Let's first go to the list interface. So you can see list interface has the relationship with abstract list, and from there it goes down to array list. Abstract list has another child which is called abstract sequential list, which is another abstract class, and which has a concrete class which is called linked list. So let's understand these two collections, or these two types of list right now. So when we talk about array list, let's understand this. We already have covered arrays. So what are array lists? They are very similar to arrays in a way that they are also indexed based collections. So you can store elements and access them based on the index position, starting from 0, going till the length -1 index. And this is an ordered collection. You can access the elements only in a predefined sequence. It can obviously accept duplicates as well. And these all our properties are also applicable to arrays. The differentiating factor here is that array list is a dynamic array. It's not a static array. If you remember, when we talked about arrays, we had to initialize it, or we had to specify a fixed size of it while we initialize it. Once you have initialized the array size, you cannot change the array size. It is static, it is fixed. So if you have created an array of elements 10, and if you're trying to store the 11th element, you are going to get an array of array index bound of exception. But in case of array list, it dynamically updates its size based on the number of elements stored. You can still initialize it with some initial size. Let's say you initialize an array list and you say that you want to initialize it with a size of 10 elements. Absolutely fine. But the moment you try to store the 11th element, array list is going to dynamically update its size from 10 to something else. So it will keep updating its size based on the number of elements which are coming to the collection. That's the whole property of array list. So remember, it's used in the cases when you have an ordered collection to store and you want to access them based on the index, and you want a dynamic update of the size. The second sibling of it, which is linked list, is also a type of list, but it has slightly different properties than array list. In case of array list, it was an index based collection. You access the element based on the indexes, but in linked list, you access the elements based on the previous and the next element. That's pretty much what it knows. So an item can only be accessed in a particular sequence starting from head to the tail. And when we talk about linked list, the idea is that you have an element which will have a data, and it will also have a pointer or basically a reference. That reference will be pointing to the next element in the linked list. Similarly, the next element will store the value, the actual data, and it will also store a reference to the next element. So you can see, if you have to go to the fifth element, you cannot directly say linked list of 5 the way you can say this in array list, because array list is an index-based position list, right? So you can access the 0th element or the 5th element or the 10th element directly, just in one line or one go. But in case of linked list, you cannot access the 5th element or the last element of the linked list directly. You have to start from the first element and keep jumping the references till you reach the last element. That's the property of linked list. So these are the two types of list. Now let's talk about the type of set. A type of set which is not mentioned here is hash set, which is a very popular type. So a set generally has two popular types, hash set and tree set. So let's talk about both of those. If I talk about hash set, the property is that it will inherit the existing properties of set, which is that element should be unique. That's good. But along with that, hash set will not remember or honor the order in which the elements are inserted into it. It will, if let's say if you insert 15 or 20 different elements inside hash set, and then if you try to iterate over the hash set, every time the order in which the elements are accessed and printed will be different. Every time the order of accession will be different. Every time the way in which the elements are accessed, their order will be different. You cannot predict that. And that's the property of hash set. Whereas when we talk about tree set, in case of tree set, you can have a sort of fixed order and a tree hierarchy. So in a tree hierarchy, if you know about the tree data structure from the data structure and algorithm section, you already would know what a tree looks like. Basically, it has a root and it has child. This is basically, you can call this a tree as well, right? So whenever you have to store the values in a tree fashion where you can navigate through the parent and childs, then you would use the tree set. And remember, since it is a set, it will still inherit the uniqueness property of set. So that's about hash set and tree set. So we covered about list, we covered about sets. Now let's talk about these ones, which are vector, stack, and priority queue. So let's first understand about priority queue. So you would use a priority queue when you need a FIFO arrangement, but at the same time, if there are few elements in the queue which cannot wait to be executed or processed when their turn comes, they want it to be executed on priority. So whenever you have such use case where you want to maintain a FIFO fashion collection, but at the same time, you also want to allow few elements of it to override this FIFO arrangement and get processed ahead of their queue number. So you can use priority queue in those cases. Talking about stack, let's understand stack first. And stack is a LIFO arrangement, last in, first out. So remember in your house when you put plates, the normal dinner plates over one over each other, you are basically creating a stack. So the property is that the plate which is put first on the table will be picked up at the very last. And the plate which is put the last on the stack, let's say you put 5 plates on top of one on top of other, then the 5th plate will be consumed first. Anybody would pick the plate from the very top. They will not pick the bottom plate because it's almost impossible. If you have a big stack, you cannot pull out the bottommost plate. The stack will fall down. So you will always pick out the elements from the top. So it has a LIFO arrangement. So whenever you have to create a last in, first out kind of arrangement in your program for storing collections, you will use stack. Talking about vectors, vectors are very similar to lists. They're exactly similar. There is basically one major difference is that vectors are thread safe and lists are not thread safe. Now list has provided a way to be thread safe. We will cover that later. But for now, you can understand that whenever you have a program in which you want to access a collection in a thread safe manner, where 2 threads cannot modify the same element at the same time, then you will use vectors. So we covered about the complete collections framework classes, the interfaces, and the abstract classes. And always remember the reason why you will use array list or linked list or a hash set or a tree set or a vector or a priority queue or a stack. That is the most important concept I want you to take away from this session. Let's get started with array lists in Java. So when we talk about array list, we are technically talking about a list. In the previous session, I covered in detail about the various implementation of list interface, which were array list and linked list. And in today's session, we'll be focusing only on the array list. I have opened the API documentation of the array list class. So if we just scroll down, we will see a nice description which is provided by Java. And it broadly covers all the points which I described in the previous session, which were that an array list is basically an array-based implementation of a list. It's an index-based implementation, so you can access the elements based on their index position. You can directly access any element if you know its index. It accepts any kind of duplicates as well. And by default, it is not thread safe. If two threads are trying to access the same collection at the same time, or maybe trying to modify the collection, then you will get inconsistent behavior. So that was about the basic description of ArrayList. It provides a lot of interesting utility methods as well for adding elements, for adding multiple elements, for removing elements, for fetching an element from the array list. And we will cover those methods in detail in the demo. And with that, maybe let's switch to the demo. So for this, I have created a class which is called ArraylistDemo. It has a public static void main method, and it has an ArrayList example written inside it. So at line number 10, you see that there is an initialization happening for the array list. And this is how you basically initialize the array list. To start with, you write the interface name. You can obviously write array list as well here. Instead of list, you can write array list. That is absolutely acceptable. But the reason I have written list here is because it is a better practice, or I would say it is a best practice, to always initialize the concrete implementations with the interface type. I'm making a very generic statement which is applicable to collections and at any other type of classes and objects you might be creating in your program. Always try to declare it with the type of interface and then define the concrete implementation on the right hand side. So the LHS or the left hand side will contain the interface declaration and the right hand side will contain the concrete implementation. The reason for this is that if tomorrow, if you have to change the representation of this array list to, let's say, a linked list, then you don't need to do a lot of work because the linked list is also a child of the list interface. So since list understands and knows about both of the classes, you can interchangeably use this reference to point to any of those implementations. That's why it is considered a best practice to basically write the left-hand side as the interface and the right-hand side as the concrete implementation. That's the first bit of it. Second interesting thing you notice is this. So you see these expressions here, and this basically encloses any kind of generics or class type. What are generics? We will cover this in detail in the upcoming sessions. For now, what you can understand and what you should know that these are denoting a class type of which the objects will be stored inside this particular list. So once I say list of integer, it means that this particular list is only going to hold integer objects. If you try to insert a string object, or if you try to insert a character object, or if you try to insert a float object or any other kind of object, it will create an error because remember in the very first lecture, we said that Java is strongly typed language. It has very strong checks for these kind of data type mismatch. So if that's why it will expect you to specify the object type here, and whatever type you have specified here, that's the kind of objects which are going to be stored inside this list. I have been using these terms called classes and objects interchangeably, but for now, what you can understand that this is a type. How we write classes and how we write objects and how we create objects. Again, I will cover this in detail in the upcoming sessions. So we have specified the list interface, and I'm saying that this particular variable should hold any list of integer type. Then on the right hand side, I'm specifying what type of list this array list is. And this array list will be an array list class type. And again, I have to specify the class type specifications. And then I'm specifying a size here. This is the size of the array list, the initial size of the array list. You can obviously write it without this as well. This is also a perfectly fine statement in Java. And in this case, the array list is going to be initialized with its default size. If you specify a value, then the array list will be initialized with only that size. It is also considered a best practice to always initialize the array list with some known initial value. Let's say if this array list is going to store only 2 elements and the default size is definitely way bigger than 2 elements, then you're going to waste a lot of memories. So that's why it is a best practice to explicitly specify some sort of an initial size. This is also acceptable because it is automatically inferring the type from the declaration. You don't need to specify it again here. In fact, some of these modern IDEs will also show you a warning if you write it here. So the next thing I'm going to do is basically going to add some elements to this array list. So I've created an array list which should hold only integer values, and it should hold to start with 5 values, but it will not complain if you try to add the 6th value. So for that, I have just written a small loop here. Let me just put curly braces around it for readability. So I'm saying int I equal to 1, I should be less than equal to 5, I plus plus, and I keep doing ArrayList.add. So this add method is the method which is used to add elements to the array list. So whenever you have to add an element to the array list, remember you need to use the method add and then specify the actual element which is supposed to be added. So I'm adding 1, 2, 3, 4, 5 in this array list one by one using this loop. And then I'm just printing the whole array list. That's what I'm doing here. After that, to showcase another operation of this array list, I'm removing an element. And if we have to remove an element from array list, just simply call ArrayList.remove and specify the index from which you want to remove the element. Remember, you need to specify the index. And as I said in the beginning, this is an array-based implementation. So this is going to start from 0. So when I say remove the element at index 3, technically it's the 4th element of the array list. After that, once we have removed the element, I'm again displaying the modified array list and then printing all the elements of the array list one by one. And for fetching the element, if you see here, if you observe this particular for loop, I'm using a couple of more interesting methods of the array list. Let's understand those methods as well, and then I will run the program. So here you see that I'm saying int I equal to 0, and then I'm saying I less than ArrayList.size. So if this array list has a initial capacity of storing 5 elements, and I've just added 5 elements to it, then the ArrayList.size will be 5, but it says less than. So it will start from 0 and run till I equal to 4, because the moment I becomes 5, 5 is not less than 5, and it will come out of the loop. So basically I'm trying to start this loop where i's value starts from 0 and goes till 4. And here I'm calling another ArrayList method which is used to fetch an element from the array list. So whenever you have to get an element from the array list, just call .get on the array list. So ArrayList.get, and I'm specifying the I value. So ArrayList.get of 0, get of 1, get of 2, get of 3, and get of 4. And that's technically the 5 elements which are stored in this array list. So let's run this program. So, and now let's observe the outputs here. Let me just bring the outputs down. Yeah. So at first I'm just printing the array list. So nothing. I'm just adding the elements and printing the complete array list. So if you want to just print the whole array list, just put that inside system.out.println, and the whole array list will be printed. That's line 17. Then I remove the element at index 3. So if I traverse through this particular list, this is index 0, index 1, index 2, and index 3. So index 3 has an element which has a value 4. And I'm saying ArrayList.remove the element at index 3. So this particular element should be removed from this particular list when I call the line 20. And then if I print the modified array list at line 24, I can see that 4 is gone now. It's only 1, 2, 3, 5. That's the remaining list. You also notice that whenever I call system.out.println with array list, I get this square brackets, which is the representation of an array list. If you don't want that, you might not want that always, right? If you want to print this nicely without the square brackets, then you have to iterate over the array list. And that's what I'm doing here. I'm going from 0 to ArrayList.size, and I'm doing get of 0, get of 1, get of 2, and get of 3. And that's how I get these values without 4. We can also write the same loop using for enhanced loop. So let's say if I write for int I colon array list, and then inside it, I can just say system.out.println I. And if I comment this particular loop for a moment and run this program, I see the values one by one because it's ln, so every output comes on a new line, but you can pretty much see the same output. If I remove this and if I write it like this, just adding an extra space, it will look a bit more nice, a bit more formatted. like this. So as you can see that we can get the pretty much the same output either using a classic for loop style, which is a bit verbose, or you can use an enhanced for loop, which is a much simpler and shorter and less verbose way of doing exactly the same thing. You don't even need to call the ArrayList.getI. But the reason I put this example because I wanted to show you the get functionality as well. So that's all we are going to talk about in this session. In the next session, we will be discussing about linked list, which is the another implementation of the list interface. Let's get started with linked lists in Java. In the previous session, we talked about array lists, and today we are going to talk about the another type of implementation of the list interface, which is called linked list. If you remember from the previous sessions, we discussed about the properties of the linked list, and all those properties are listed here as well. So basic idea is that whenever you want to have a kind of implementation where the order of the elements is strictly maintained, where the first element can refer to the second element can refer to the third element, and so on. In those kind of cases, you are going to use linked list. Another property of linked list is that you cannot randomly access an element directly as you could do in case of ArrayList. In case of ArrayList, you just write ArrayList.get and you provide the index location and you get the element right away. That's not possible in linked list. In linked list, if you have to access the, let's say, the second last element or the fifth element in a 10 size element list, in that case, you have to start from the head, which is the first element, and keep traversing till the fifth element. That's the only way possible to access the fifth element or any random element. So that's the property of linked list. It is also not synchronized. So if multiple threads are trying to access a linked list concurrently, at least one of the threads and one of the threads tries to modify the list, then it must be synchronized externally by some other ways. Otherwise, you'll get unpredictable results. And again, this also provides a bunch of utility methods, and we will cover some of those methods. As you can see, add method for adding an element, add all, add first, contains, get first, get last. We will cover some of these methods in the demonstration, which follows this particular documentation. And with that, let's jump to the implementation. So I have prepared an example here for the linked list, which is called linked list demo. I've just created a class for it. And we have created a public static void main method here. And here you can see at line number 10, I have declared a linked list. So this looks very similar to the way we declared an array list. You see, if you have noticed on the LHS, I have written the concrete class and I've not written the interface. Reason being, I'm using some concrete methods and actual methods which are only available in the linked list class. So I am not looking at the reusability aspect in this particular example. If you are, then you have to add extra code for it. But here I'm just writing linked list. And again, in this particular linked list, I'm saying that I would only store string objects. So that's why inside these braces, I write string, and then I say new linked list string. Again, I have not specified the size, so it will take the default size as per the JVM implementation. Now I have declared my linked list, and it's time to add some elements to the linked list. For that, I have the method add, which is available in this linked list class, which will provide me with the capability to add elements. So at line number 12 and line number 13, I'm adding 2 elements. And if you remember, I told you that it works in a reference-based implementation. So at first, an element A will be added. And when you try to add element B, element A's reference will be updated to point to B. That's what will happen in this linked list. And then at line 14, I'm using another interesting utility method of this linked list class, which says add last. What this method does, that specifically it will add the element at the very end of the linked list. So that was about add last. And if I talk about line 15, I'm using another interesting method of linked list class, which is called add first. So what this will do, that this is going to insert this element D at the very beginning of this linked list, like even before A, D will be inserted. So whatever your linked list looks like, whenever you call add first, that element is going to be inserted at the very head of the linked list or the very beginning of the linked list. Linklist also provides another variant of the add method. So there's one way to just add the string element directly because this is a string linked list. You can also add it based on the position. So you can say add E at the second position inside the linked list. So let's observe this output. Let me comment all the code below line 18 because we will be using some more methods here. So we'll cover that in a while, but let's first understand the output at line 18 if we run this program. So right click, run as Java application, and this is the output we get. So let's understand the output. Or maybe let me do this. Let me put this here one by one so that we can interpret the output. So I'm adding two elements and printing the list, then calling add last and printing the new list, then calling add first, printing the new list, and then calling list.add2, e and printing the list again. So let's observe these outputs one by one. I'll comment this and let's run this now. So if I run this particular program, the program till line 14 is executed because rest of the code is all commented. Let me comment this as well. And if I run it again, yes, this is the output I get. So at line 12 and 13, I've added two elements and I print the list. There are only two elements and they're printed in the fashion A, B. Everything is good here. Now let's uncomment this code. And now I'm calling add last method and I'm adding an element with string C, which should be added at the very last of this particular list. So let's see now what happens. Let me comment this one so that we only see one list at the output. Okay, we see A, B, C. So C has been successfully added to the end of the list. Now let's interpret this particular method, which is called add first. So I'm going to uncomment this and comment the previous sysout. So now there's only one sysout here. So I'm adding two elements, adding C at the last, and now adding D at the very beginning and printing out the list. Let's see what happens. Okay, so the D has been added at the very beginning of the list, even before A. So now it looks like D, A, B, C. So far, so good. Now let's move to this particular code. And now I'm saying add an element called E at the second position inside this list. Remember, second position. So let's run this list now, this program now. So now I see D, A. If you remember, the previous output was D, A, B, C. If I just uncomment this for a while, just to make it more clearer, and if I run this program, the previous list was D, A, B, C, and the new one says D, A, E. E has been inserted at the position 2. So 0, 1, 2. Position 2 has been added with this new string E, and my list is modified. Now it's time to find some interesting operations about the removal. So what happens if I try to remove elements from this list? And then we will observe the output again. So let's say if I say list.remove B, and so I'm saying just drop this particular element. So you can directly specify that particular element's value, and that element will be removed from the list. And let's see what output do I get if I just call list.remove B and I comment the rest of the code. We should see a new output here, which should not have B. So running the program again, yes. So this was the old collection, and this is the new collection from which B is gone because I've called list.remove B. Now you can also remove elements based on the index position. Instead of specifying the element explicitly, you can specify the index position. And what happens if I call list.remove 3? Let's observe the output here as well. So I'm just going to copy paste this out, and we'll see what output do we get if we remove the element at third location. Okay, so this was the previous output after removing B. And if I call list.remove 3, so 0, 1, 2, 3, C is the element which is at third location, and it is gone. When I call list.remove 3, C is gone, and D, A, E is only remaining. Now let's try to understand this particular line which says list.remove first. Expectedly, this is going to remove the element from the very beginning. So whatever element is present at the beginning, it is going to remove the element, and then we are going to print the list, the modified list. So we were here till DAE, and D was the element which was at the beginning. And if I called remove first, D is removed, and now only A, E is available. And now I use another interesting method, which is called list.remove last. And then I print the list, the modified list. So this is the list remaining, and I'm calling remove last. So E should be dropped and only A should be left in this particular list. Yes, we only see A here. So this is basically what I wanted to show you in this program, that we can perform different kind of operations using different methods like add, add first, add last, remove, remove first, remove last. Obviously, there are more interesting methods available in this particular class. Do check out the API documentation for it. And there you can see all the different interesting methods which you can use while implementing linked list. So this is all I wanted to cover in this particular session. And in the next session, we are going to cover an interesting framework class, which is called set. We are going to learn about sets in Java in the next session. Let's get started with Hashset in Java. If you remember, I covered in the collections framework session that Hashset is part of the set interface hierarchy, and sets have a property that they keep the collections element unique. If you try to add duplicate elements to a set, it will not accept that, and it will still maintain the uniqueness property of the collection. Hashset provides some additional features to the set, which is that in this case, the elements would be accessed in a random fashion. They will not be accessed in a fixed sequence, rather they will be accessed in a random fashion. Hence the name Hashset. So if you read about this particular class in the documentation, it will basically cover all the things which I just described. It also accepts null elements if you want to insert null. But why would you try to insert null? That's the first question which you should ask. It again provides similar kind of utility methods to the list interface collection hierarchy we covered, like some utility methods to add the elements, to remove the elements, to check the size of the collection, and to check if an element exists in the collection or not, etc., etc. And we will cover some of these methods in the demo. This is again not synchronized, so this is not a thread safe collection, which you should know. So let's look at a demonstration of Hashset and how do we actually create a Hashset, how do we operate upon a Hashset using different utility methods. So as you can see, I have created a class here which is called HashsetDemo. There's a public static void main method, and then at line number 10, you will see that I have created the Hashset. And again, it starts with a concrete class here which says Hashset, and you can obviously write it as set as well, which will also work fine. So we write the set type as string. So this particular set is going to hold only and only string objects and nothing else. And this set is basically a type of Hashset. Again, this is not mandatory, so you can remove that. It will still not complain and the program will run fine. If you want to specify a size, please do that. If you do not want to specify the size, nothing goes wrong and it will be initialized with the default memory footprint. But remember, doing this wastes a bit of memory. So if you're running this program on a machine which is really tight on memory, always put some kind of initialization size based on your knowledge of how many elements are going to be stored in this collection. So after that, at line number 12, we start adding elements to this collection. And for adding the elements, the method which is provided by the Hashset class is add. So you use the add method to add new elements. So at line number 12, line number 13, 14, and 15, I use the method again and again to add some elements. If you observe the line number 14 and the line number 15, these two lines are adding the same element. So I'm trying to add C twice to this particular Hashset. And we will observe the output to see what happens if we try to add duplicate elements in the Hashset. Because if you remember, the sets are supposed to be unique. They should not be storing duplicate elements. That's the property of sets. So that's what I demonstrate by adding duplicate elements to see how it behaves. And let's do that. Let me comment the rest of the code for a while. And let's run just this part of the code where I add C twice and I print the Hashset. And let's see what happens. So I go to run as and I click on Java application and I only see 3 elements. Even though I added 4, I only see 3 and C has been added only once, not twice. Now you might be wondering whether this C is the C added at line 14 or the C added at line 15. So to understand that, we need to understand how Hashset's add method works. So this add method is basically returning a Boolean value. if the element is added successfully, this add is going to return true. And if the element could not be added successfully, this add method is going to return false. So let's do that. Let's store the result of these add methods. Let's call this R1 and let's call this one as R2. Okay, and now we will try to print R1 and R2 and see what happens. So if we write system.out.println and I say R1, and then I just copy this after line 16 and write R2. And now we will observe the output of these to see which when we did the add at 14 and when we did the add at 16, which add actually resulted in C getting added. Did C get overwritten or did C did not add twice? What happens? So we see that when we do the add at line 14, we get true. So it means that this add was successful and C was added here. And when I did the add again at line 16, this returned a false. It means the hash set rejected this add operation. So this C was not added. So the actual C was never overwritten. The original C was maintained. And when you try to add a duplicate value with the same value, a duplicate element with the same value, Hashset is going to reject that. So that actually proves that the set will maintain the uniqueness property and it will reject all the duplicates subsequently. That was about the add property. Now let's understand another interesting property of the contains method. Contains method of the set class is used to find if an element exists in the set or not. So you can just use the Hashset variable name dot contains and just type the actual element. And this is going to return true or false based on whether this element is present in the hash set or not present in the hash set. If it is present, then this contains method is going to return true. Otherwise, it is going to return false. So let's run this method and observe the output at line 21. So it says list. We are writing this particular string, which says, does list contain C or not? And it returns true because yes, my hash set does contain C. Now coming to line 23, I use another method of the hash set, which is the remove operation, which you can use to remove an element from the set. And then I'm again doing a sysout and I'm asking to print the set. This should be set and not list. So then I'm checking if what happens to my hash set if I call the remove method, and I'm just printing the modified hash set at line 24. So let's see what happens with the effect of remove operation. Okay, so after removing A, this is what remains in my hash set, and A has been successfully dropped if I call the remove method. And then I try to just iterate over the hash set to show you how does this iteration work. It again works on exactly the same way it has been working for the list implementations, that on the RHS of this column, you write the collection name, so hash set, and on the LHS of this column, you write the representation of the element. So this hash set is going to contain string, and this is just a placeholder. It can be anything. This is just a temporary variable to store the current value at the current step of the hash set iteration. And I'm printing all the items one by one. So if I run this, I'm able to print B and C because that's all which is remaining in this hash set. So this was a very quick demo to show you the functionalities of the hash set. How does hash set maintains uniqueness? How do you remove elements? How do you add elements? How do you check for an element's existence using contains? There's also a method to get the element of the hash set if you want to. So these are all the different properties and methods available in the hash set. And do check out the API documentation of the hash set to learn about more methods. So that's all I wanted to cover in this particular session, where we focused only on hash set. And in the next session, we'll be discussing about tree sets, and we will also see an example of how do we implement tree sets in Java. Let's get started with tree sets in Java. So in the previous session, we talked about hash set, which is one of the implementation of the set hierarchy. And today we'll be focusing on tree set. And if you remember, when we talked about this collection framework, I discussed briefly about tree set, that the main reason you will use tree set is basically when you want to maintain natural ordering of the elements. If you're adding your custom elements, then you need to tell Java how to compare and sort and order the elements. But that's for another day when we'll cover about the detailed comparable and comparator interfaces. For now, what you can understand that whenever you have to maintain the natural order of the elements automatically, then you should use tree set. Along with that, the set property still holds true that this tree set cannot have duplicate elements. We should also know that tree set is not synchronized, so it is not a thread safe collection. So be aware that whenever you are trying to use tree set in a multi-threaded environment, you need to write more wiring code around it so that tree set works as expected. Okay, that was about the brief theory about the tree set. You can read about it in detail in this tree set documentation class. And with that, let's switch to a demonstration of the tree set class. So I've prepared a class here which is called TreeSetDemo. As you can see, it has a public static void main method, and at line number 8, I'm initializing the tree set. It's again the standard representation of initializing a collection which we have been using throughout the different examples of the collections. So tree set of string. So this particular tree set is going to hold only and only string elements. If you try to add another element, it is going to throw a compilation error. And on the RHS, I'm just saying new tree set. And again, this is not mandatory, so I can remove that and it will still work. You can specify the size. Whenever you know about the scope of the collection, you should always specify the size. For this demonstration, it's a lightweight program, so it's fine. After that, from line number 10 till line number 13, I'm again going to add some elements. And again, if you see, I'm adding elements in random order. I'm adding B, and then I'm adding A, then I am adding C twice just to show you the uniqueness property of the tree set. Does it still hold true or not? We will be able to figure that out from this particular example. And we will also see if I'm adding B before A, will it be printed in a fashion called BAC, or will it be printed in a fashion called ABC? We should also know that. So let's try to run this program and understand the output. So if we look at the output, we see A before B. But here when we added the elements, we saw B before A. We added B first, and then we added A, and then we added C twice. And as per the uniqueness property of the set, the second addition statement at line number 13 returned false, and set rejected this addition because it could see that C was already present in this particular collection. So C is added only once. But what's interesting is that B is added first, but B is printed after A. So the natural order of the elements in this collection is automatically maintained by tree set. So what under the hood tree set does here, that it looks at the type, which is a predefined type in Java. String is a predefined class in Java. So it will use its own sorting algorithm to sort the strings based on their natural order of sequence. And in the natural order of sequence, A will always come before B and B will always come before C. So it will automatically apply that sorting and will present the result to you. If you're using a custom class here, let's say your own student class or your own customer class or your own account class, in that case, that account class or student class or customer class needs to tell Java how to sort elements. And for that, you need to write comparable and comparator implementations, which we will cover in detail in the future sessions. But for now, you must understand that whatever the type of class you are specifying here should tell Java how to sort the elements. Either Java should know it automatically. If it's a predefined class like string or integer or float or double, then Java would automatically know by default how to sort the elements. But if you're creating a custom class of yours in the tree set and specifying that as the tree set type, then you should also tell Java how to sort the customers, whether you want to sort them based on their first name, whether you want to sort them based on their age, their salary. Java doesn't know that. So you need to tell Java about that if you're trying to use a custom class as the type in tree set. In this particular example, I'm using string here and it will apply the natural ordering. Let's put C here in the very beginning to see what happens. And I can comment this as we have already maintained and verified that C is only printed once and added once. So I'm adding C, B, A, and let's run this program. I still get ABC because again, the natural order is implemented. Contrary to this, when we talked about Hashset, remember I told that Hashset is a random access element collection list. So if you run the hash set, if you try to print the hash set again and again and again, you might see a different order. Sometimes if I use a hash set here, sometimes it will print ABC, sometimes it will print BAC, sometimes it might print CAB, any kind of sequence, any kind of random sequence, it will pick automatically. That's the property of hash set. But in case of tree set, no matter how many times you run it, you will always get the same order based on the sorting implementation available in the class type. So that's all I wanted to cover about tree set. Please read about its Java documentation in the API docs to understand what all other methods and utilities tree set provides. But it's pretty much similar to what we saw in the hash set example, like remove or get, etc., and contains, etc. So all similar methods are available in the tree set class as well. And that's all we'll focus on this particular session. And in the next session, we're going to talk about an interesting framework called maps. Let's get started with maps in Java. So first of all, before we understand this particular diagram and the classes in this map framework, let's understand why do we need map. So there would be instances when you would write a Java program or any kind of program, there would always be instances where you would need to store a key value kind of arrangement. A very simple example can be that you want to maintain a company database and you want to just bring the whole mapping of the employee ID to the employee name into the Java program. How do you do that? You need a key value sort of arrangement where you can store the employee ID as the keys, and each of the employee ID key would correspond to an employee name, which will be called the value. So you need a key and value arrangement in a Java program to store that kind of information and use that kind of information in your program. And that's where map comes into picture. Whenever you have to store a key value arrangement, remember, you would always think about maps. Maps should be the right collection or the right data structure to be used if you want to store any key value arrangement in your program. So that's about map. And here you can see a nice framework representation of map. And this is going to be a theoretical lecture where we will understand how this map framework works, what is the property, and what are the different implementation classes. And then in the future sessions, we will again look at some examples of the most popular map implementation classes which are used in the Java world. So again, the orange oval are interfaces. The blue boxes or the light blue boxes are the abstract classes, and the purple boxes are the concrete classes. So map is an interface which will provide this kind of a blueprint that every class underneath it would be working on a key value arrangement. When we talk about this key value arrangement, so we have these keys and we have the values. So the keys here are supposed to be unique. The values can contain duplicates. Remember, this is a very important concept that in map, the keys will be unique and the values can have duplicate. And because we want to maintain the uniqueness in the keys part, that's why the keys are technically stored as a set, because we know that set cannot contain duplicate. Sets are by design made to be storing only unique elements. So map uses the set class to store its keys, and to store the values, it generally uses a list class. So you can see map is basically reusing the classes from the collections framework, sets for storing the keys and lists for storing the values. That's the basic anatomy and basic idea of how map is working. Now you see some classes here called abstract map and sorted map. And again, similar to the set hierarchy, whenever you see the sorted word, and if you look at the concrete class, which is called TreeMap, this is going to provide you some sort of an order, sorting order automatically. And then you have the Hashmap class, and this class is going to be providing a random access. This will not maintain the insertion order. This will not provide you a natural sorting order. This is just to store elements in random order. And the element here, a single element here, is basically consisting of two parts, which is key and value. Always remember that. You also have hash table here. Hash table is basically a synchronized representation. This is a thread safe. Hash map and tree map are non-thread safe. So multiple threads, if you try to work in a multi-threading program with these hash map and tree map, you're going to get very unpredictable results. But if you use hash table, then it is inherently thread safe. So it will only allow one thread to access the hash table at a particular time. You will also be thinking then it's always better to use hash table, right? Because you will never get into those weird errors and you don't have to migrate your program to a multi-threaded environment whenever you are trying to use hash tables. Yes, that is true, but hash tables are slower for the same reason, because only one thread can can access it at a time, and that's why hash tables are slower. And hash map and tree map are way faster because they allowed multiple access at the same time. So you have to always be mindful of what kind of collection type you're using. There are some external ways as well to make these hash maps and tree maps and hash set and tree set and array list and linked list as synchronized as well. And we will talk about that in a future session. But for now, you can understand that hash map and tree map are non-thread safe and hash table are thread safe. There's another class which is coming out from the hash map class, which is called linked hash map. And linked hash map, as the name shows, it will basically carry two properties. It will carry the property of hash map, where the elements are stored or displayed or accessed in random order. And at the same time, it is also providing the linked property of the linked list, where the sequence is maintained. So you can see you can actually get the insertion order. If you use a linked hash map, the way in which you insert the elements would always be the way in which the elements will be accessed. So you are getting sort of a ordering property, but the order is the insertion order. It's not the natural sort order, it's the insertion order. That's why the name linked hash map, because it brings the linked list part of the link property inside the hash map, where the elements would be presented to you in the order they are inserted when you call the add method. So that's what we covered here. We covered about map interface. We covered about hash map class, which is going to store the values and the access will be random. The value means the element means a key and value. We sometimes also call this as an element. You will see that representation sometimes. Some people also call it as iterable element. It's all the same thing, but it's a key and value arrangement. Tree map also stores the key value arrangement, but it will provide you a sorted representation. And here the sorting will happen on the keys, not on the values. The sorting will be happening. The natural order of sort, which will be maintained by the tree map, is only applicable to the keys here. Similarly, linked hash map, it will insert the elements, but when you try to access it, it will maintain the insertion order. No matter how many times you access it, it will only be presented to you in the order the elements were inserted. And hash table is very similar to hash map, with the difference that hash table is thread safe. Multiple threads cannot manipulate the hash table at a time. It will only let a single thread access itself at a time. So that's the property of hash table. The most popular classes are generally these ones: hash map, tree map, and linked hash map. Very rarely you will also see hash table, but since we have some ways to get these synchronized, so generally you would not see much of the hash table implementation. And that's all I wanted to cover in this particular lecture, where we walk you through the concepts and the theory of the map framework. And in the upcoming sessions, we'll go deeper into the concrete classes. And in the next session, we'll specifically be discussing about hash map. So we will understand how hash map works. We will create a hash map, and we will again look at some utility methods which are provided by the hash map class through the demonstration. Let's get started with hash maps in Java. In the previous session, I covered about the theoretical concepts of map and the key value arrangement, and the keys being basically a set and the values basically being a list. And now we are looking at the API documentation of the hash map class. You can see the k, v here. These are the types of the key and the value which the hash map will accept. You can see k is basically the type of keys and v is basically the type of mapped values. Like I explained, it's basically keys are stored in a set fashion and values are stored in a list collection fashion. This is not by default synchronized. So if you want a thread safe collection, then you would have to do something else, which I will cover in the future sessions. This is a very brief overview of what Hashmap is, but let's look at the example to understand better, and then I will be able to explain it in bit more detail. So now we are looking at an example, which is basically a class which is called Hashmap demo. I have a main method here, and then at line number 10, I'm initializing the map. And as you can see that on the LHS, we see the concrete class Hashmap, and I can do this, and this will still work provided you have the import here. I had the import here, so it will work fine. And I'm saying that this map is going to contain a key value arrangement where the keys are the string type and the values are of the type integer, and it's ultimately a hash map. Here I don't need to again provide the generics because I have already provided the generics here. The name of the map is just simply a map. And again, you can specify a size or you can skip the size based on the memory requirements and the program requirements. Now coming to the point where you want to add elements to the map. Now, since this is a key value arrangement, here the name of the method through which you are going to add elements is put. So you call map.put and then you provide the key, comma, you provide the value. That's the syntax for adding an element, or we technically call that element an entry. This key value together is called entry. So if you have to add an entry to the map, you have to write it in this way where key, comma, value is the convention. So I'm adding 3 elements or 3 entries here, which is A, 10, B, 20, and C, 30. A, B, C are basically the keys, and 10, 20, and 30 are the corresponding values of these keys respectively. After that, I'm showcasing another utility method of this particular class, which you can use to find the size of the map. So you can just call map.size and it will print the size of the map. After that, I'm printing the actual map, the whole map. And then I'm using some more methods, but again, let's comment this code and let's understand this code one by one so that there is no confusion. So to start with, I'm going to add some elements, some entries, and I'm going to print the size of the map and the map itself. Let's run this program. So here you can see the size of the map is printed as 3 because I've added 3 entries. And then when I call map inside the system.out.println method, I get the whole map printed here. And this is how the map will look like when it is printed. You can see key equal to value syntax here, where A equal to 10, B equal to 20, and C equal to 30 are the key value representations or the entries here, separated by comma, enclosed by the curly braces. That's how our map looks like. So far, so good. The next thing which I'm going to showcase to you is the contains method. And since the map has this set, which is the keys basically, that's why map provides a method called contains key. Basically, you can check if a particular key is present in the map or not. And if you know the key is present, then it's very easy to get the value from the key. Map will provide a method also where you can supply the key and get the value. So knowing the key is the most important part. And that's why map provides a method called contains key. So you can call this method, specify the key which you want to check for the presence in the map. It is going to check whether A is present in this map's key set or not. If the A is available in this keys, we can see A is available, then this condition is going to hold true. And then, like I said, if you want to fetch the value, then you can call the get method providing the key. You can fetch the value from the key. That's the core idea which you should remember. So I call map.get, specify the key, and this is going to spit out the value which is being pointed by this particular key. In this case, A is pointing to 10. When I say pointing, it's not pointer, remember, it's just a reference. So map.get of A is going to get the actual value which this key is pointing to, which is 10. And then I am printing this integer A, which is the actual value pointed by this particular key. So let's run this program and see if this works. So we get these two outputs from the above, and then this is the output which is coming from the if block. So it checked whether the map is containing a key with the name A, Yes, it was able to find that. And then we asked the Java program to fetch the value corresponding to this particular key. So we just called map.get of A, and it fetched 10 and it printed 10 here. That's why you see 10 here. Okay, so that's how you can basically use the contains key method and the get method. Now, what if you want to iterate over all the keys? What if you what if you have to use the all the keys and you have to make some pattern or make some observation about all the keys in your map? You can do that by iterating over the key set. And for that, map provides a method called keyset. So you just called map.keyset, and this is going to fetch all the keys in a set representation and will be provided to you. So here, when I call map.keyset, this is basically giving me a set which is containing all the keys, and then I'm iterating over the keys one by one. You would be familiar with this syntax by now, which is the enhanced for loop syntax. And inside this, I'm printing the key, which is the current temporary variable holding the current key, and the value pointed by that particular key at that particular step. And I'm again using the same method get, which I showed you here. Same method. So you provide the key and you will get the value. So I'm going to get all the keys, iterate over the keys, and then print the key and the value. Let's see how this looks like. So till this we were good. And here you will see the output which is coming out from this particular for loop. From this particular for loop, line 25 to line 27, where I'm iterating over the key set, printing the key and value one by one. So this is how to show you, if you just have access to the key set, you can still iterate over the whole map. But what if you know everything? You have access to the key set, you have access to the values, and if you just want to iterate over it, then you can use this particular way. And instead of map.keyset, you're going to use map.entrySet. If you remember, map treats each key value arrangement as a single entry. Entry is the keyword here. So map.entrySet is going to give me all the entries in the map, and then each entry is basically of type entry class. This is the representation of each entry, and we know how this representation formed. Entry is the class basically which is coming out of this map collection hierarchy, and then let me just save this, and then string is the key and integer is the value held by each entry inside the map. So that's what we are going to do. We are going to pick up all the entries in the map and going to iterate over the entries one by one by writing this enhanced for loop. And entry is the temporary variable which is going to hold each entry one by one at each step. And then it's very simple. You call entry.getKey, you will get the key, and you call entry.getValue and you will get the value. So it's much simpler than this one where you had to do map.get to understand. Here it's very implicit. GetKey is going to get you the key and getValue is going to get you the value. So you just need to call map.entrySet, iterate over the entry set, and get each entry's key and value and print them or do whatever your program requires to be done. That's how you will use it. So let's run this one as well to verify if this works. Okay, so this is the output which is coming from the last loop, this loop basically. You can see key, I did not put any space. That's why you see key A, key B, and key C together. Let me put a space here and put a hyphen so that the output looks better. And let me rerun this. Yeah, this is much better. So you can see the key A, value 10, key B, value 20, and key C, value 30. This is coming from this particular for loop, which I just showed you. So this is all I wanted to cover in this particular session. We went deeper into the hash map representation and we saw a bunch of methods, contains key, key set, entry set, get, put, etc. And we showed how we can use the hash map for different purposes in the program. In the next session, we'll go deeper into the tree map concept and we'll also look at a demo of tree map and we'll understand how it works. Let's get started with tree maps in Java. Now, if you remember, in the last lecture, we talked about hash maps in Java, and we also had a look at an example where we saw how a hash map works and how we can use a hash map. We also had a look at different utility methods of the hash map as well. Now, in today's lecture, we are going to focus on tree maps, which is another type of map as we discussed when we were discussing about the map framework. And the main property of a tree map is that when you enter elements into a map, they will naturally be sorted or naturally be ordered. Now, when I say naturally ordered, what it means that if you put the keys as, let's say, integer, then the tree map will automatically sort all the map entries in an integer sorted fashion, where you'll see the natural number sorting behavior like 1, 2, 3, and so on. Similarly, if you store alphabets or strings, then those will be sorted in a natural sorting alphabetical order starting from A to Z. So these are the data types which the Java is already aware of on how to sort them, like integers, doubles, floats, strings, etc. But there can be a case where you have your custom key. This particular key is your own custom class. If that is the behavior or if that is the scenario, then in that case, you will have to provide an implementation to Java to know how to sort those elements, because Java doesn't know, for example, a student class or an account class. Java doesn't know how to sort that. So if you have that kind of scenario, then in those cases, you will have to provide your own sorting implementation. And we will cover about what kind of sorting implementation you can provide in those kind of scenarios in the upcoming lectures. For now, we will have a look at an example of TreeMap, where you can see that I've created a class which is called TreeMap demo, and I have initialized a TreeMap with the keys as integer and the values as string. So this means that each entry of the map will have key as the integer value, and the value of that particular entry will be of string type. So basically an integer to string mapping is what each entry of this tree map is going to store. So nothing different here. You would have already seen this kind of initialization for any kind of map. And after that, at line 11, I use the standard put method of the map, and I started storing the values. So at line 11, I'm saying store 3 and A. So 3 is the key, and string A, remember this is not a character, this is a string, because I have specified string here. If you specify a character here and if you try to store a string, this is going to throw an error and you need to fix that. So I store 3 as the key and A as string as the value. Similarly, at line 12, I store 2 as the key and B as the value. And at line C, I store 1 as the key and C as the value. So these integers are the keys and the string are the values. And if I just put them and if I just try to print them, what happens? What kind of order can we expect? Let's try to analyze that. So I right click on this, I go to run as, and I go to run as Java application. It will run the program because I have a static void main method. And now you see that the map is printed in a different fashion than the way it was added. We added the map elements in this sequence that we added 3A first, 2B second, and 1C as the third element. But when we started printing them, we saw 1C printed first, 2B printed second, and 3A printed third. So what this denotes that this tree map, because the key was integer here, it automatically sorted these keys into a natural order sorting, and it provided, when I tried to access the map, it provided the access in that sorted sequence only. No matter how many times you run this particular program, it is always going to return the map in the same format, in the same sequence. The sequence of representation of the elements is not going to change. And you can basically do the similar behavior. For example, if I just change this to string and integer, let's do it like this. And if I again swap the elements here as well, I say A, 3, and I say B, 2, and here I can say C, 1. If I do this, I just switch the keys and values position. Now the string is the key and the integer is the value. And let me just put these two before A so that we can demonstrate the behavior of the tree map properly. So I'm inserting B2 first and C1 second and A3 third. And I just save this file, and now let's run this file and let's see how the output comes. So now you can see that since the key is now string, it has automatically applied the natural sorting ordering of strings, which is starting from A going till Z. And that's why you see A entry as the first entry, B entry as the second entry, and the C entry as the third entry. Again, no matter how many times you run it or you iterate over it, you try to access it, you will always get the sequence in the same fashion. So this is a basic overview of how tree maps work. Now you can, and I would strongly recommend you to go and read about all the other methods which are available in the tree map, which you can use. For example, how can you remove elements? How can you iterate the elements of the tree map, etc. In fact, the iteration is going to be exactly the same way as we have seen in the case of hash maps, because iteration behavior doesn't change. But if you want to see what all different kinds of methods TreeMap support, it supports a lot of different methods. We can't cover all of them in this short tutorial, but I would strongly recommend you to go and read the Java Docs API of the TreeMap to get familiar with those methods so that you know what kind of functionalities TreeMap can provide. In the next session, we are going to have a look at how we can use stacks, and we will look at a hands-on example of how we can build stack and how we can use them in a real life scenario. Let's get started with stacks in Java. Now, if you remember, when we were covering about the collections framework, I walked through a complete hierarchy of interfaces, abstract classes, and concrete classes. And I briefly talked about what are stacks and what kind of functionality they provide, in which scenarios you would use them. So let's do a quick refresher of what stacks are and why do you need them. So stack is basically a kind of list, we can say. Technically a list, but it's not exactly a list. So never say that stack is a list. It's just because it is extending the list interface. That is why you can say it is a type of list. But actually it's not a type of list. It has its own representation. You will use stack in the cases where you will have to maintain a LIFO representation of the objects. Now, what is a LIFO representation? It means last in, first out. That's basically the full form of the LIFO acronym. And what it means that the element which goes at the last inside the collection will be the first to come out. Think of it as a stack of plates at your dining table, where you put plates over one another, and the last plate which you put on that plate stack will be the first one to be picked up by somebody who wants to eat something, because people will not take out the bottommost plate, otherwise the whole stack will fall. That's why they will take the topmost plate, and that's why we call that plate representation as stack of plates. And this representation in Java is exactly inspired from that, and we call this stack. You see a bracket here, you see a generics representation here which says E, which means that stack, you need to define what kind of stack it will be, whether it will be a stack holding integer values or string values or any of your custom class values. So that is the basic property, that the last element to be going inside the collection will be the first element to be coming out. So let's have a look at an example of how you can use stack and what are the different properties which we can leverage while working with stacks. So for that, let me switch back to Eclipse, and you can see I have a class created here which is called stack demo, and it has a public static void main method which is making this particular class executable. And here you can see I have initialized the stack. So stack of the class type. So you provide the class type as string, which means that this particular stack is going to store string objects. And then you just say new stack and you provide the same generics here. Actually, you can skip that. If you do this as well, this is going to work fine. So that is how you can basically initialize a stack. You can see the import here, which you need to import to make this work. It's basically part of the java.util package. What are packages? Again, we will cover that in detail when we'll cover classes and constructors and etc. So now at line 11, I'm using a method called push. Now the push method is used to insert elements inside the stack, but we call it push because, like I said, stack is a special type of collection. That's why it doesn't use the add method. Rather, it has a method which is called push, which is used for inserting elements or pushing elements on the top of the stack. So at line 11, you say stack.push. Basically, this stack is holding the list of all the countries or the entries of all the countries. So you say America at line 11. Then at line 12, I'm again doing stack.push and entering Germany. At line 13, I'm again doing another stack.push and entering India. So basically, I have added 3 countries' names inside this stack. Now, if you can think about the mental representation, or if you try to build a mental representation of this, then stack.push America is basically the first entry. Then when you added Germany, this entry went on top of America because that's how the stack of plates work, right? And then India entry will come on top of Germany. So the America is the bottommost entry. Then we have the Germany, which is sitting in the middle. And then at the top, we will have the entry for the India string. And after that, at line 15, I'm just printing the stack. So if you want to just observe the output till 15, let's comment this particular section for now. And we will just focus till line 15. And once we have figured that out, then we will move to the rest of the code here. So let's run this particular program and observe the output. So you can see this is the system.out.println, which is getting printed. So I'm printing a stack string and then I'm printing the stack as is. And you can see it's printed in the sequence in which the elements were inserted. So when you print the stack, you will not be able to figure out which is the bottom and which is the top, because you don't need to know that while you are just printing the whole stack. When you actually want to understand and observe that behavior is when you will start taking elements out of the stack. At that time, it would be critical to know which element is at the top and which element is at the bottom. But for now, we can see that we are able to successfully add elements or push elements to a stack, and we are able to successfully print the stack. Now let's uncomment this particular code and understand what is happening here. So at line 17, I'm using another method of the stack, which is called pop. So the push method was used to push elements or insert elements into the stack, and the pop method is used to take elements out of the stack. And remember the LIFO property of the stack, which means that if I call the pop method, which is basically I'm telling stack to remove an element, it is going to remove the topmost element from the stack. And it is also going to return the element. Remember that part? If you want to remove the element and if you want to see which was the topmost element which got removed, then you can actually store the output of this particular execution into a variable, and you can see which element was popped or removed. And that's the basic property of a LIFO, right? That when you have a LIFO collection, when you pop the element, when you call the pop method on the stack, you would expect the topmost element to be coming out. And that's why we store that into this particular string. And then we print that popped element to verify and see which element was actually popped. And after that, because I have removed one element here, then I print the modified stack to just see what all is remained in the stack. So let's run this particular program. Now let's comment the first part. Maybe this particular sysout is not needed because we have already observed the output of this. So let's observe these two output after pop, which was the element which was popped, and how the stack looks like after the removal or popping of one element from the stack. So I right click run as Java application, and now if you remember, when we inserted the elements, we inserted the elements in this fashion: America, Germany, and India. And when I called pop, the topmost element of the stack should get removed. So basically the Java looked at this particular stack and it could see that the element India was added at the very last, which means this element was sitting on the top of the stack. And when you called stack.pop, this method or this string basically got popped out. This element got removed from the stack, and we stored that element into this particular variable. We printed that element, and here you can see that output that the popped element is actually India, because India string was at the top of the stack. in this particular case. At line 20, now I'm printing the modified stack, basically printing what is remaining inside the stack after we called this pop. And we can see that the string India is gone from the stack, and now Germany is the new top. If I call this again, let's call this again to verify if Germany is at the top actually. So I'm calling the stack.pop again. Let's just call it popped element 1 for simplicity. Don't do that in production code. Always give nice variable names. But for the sake of demo, we can do this. So let's see what happens if after we have these two elements left in the stack, and if I call pop again, which element gets popped. So I right click, run as Java application, and we can see that this was the representation here at line 20. Then I called popped, and the popped element was Germany because now this Germany was the new top. And after Germany has been removed from this particular stack, then this stack has only one element, which is America. So this is how you can work with the stack, and these are the most two popular methods, which are push and pop, which you would basically require to use in your program if you're working with stack. And let's say you have a scenario where you just want to view which element is at the top. You don't want to remove it because pop is also going to remove the element, right? So if you don't want to remove it, but just want to view which element is sitting at the very top of the stack, then you can call the peek method. So this peek method is basically going to return the topmost element, but it is not going to remove the element from the stack. So let me just verify that as well for you. Control C, and after we do the peek, I'm going to print the element again. Let me just call it as peeked, or let's say just call it as top element, and then we print the stack again. So let me just comment out this one as well, and now we'll run the full program. Let me call this as original stack. So we'll first print the original stack, then we'll remove one element and we'll print that element, and we print the modified stack. Then I call the peek method, and then again I print the stack to see if peek also removed the top element or it just returned the top element. So let's run as Java application and observe the output. So the original stack was this, where India was the topmost element and Germany was in the middle and America was at the bottom of this particular stack. And then we popped the top element, which was India. And then the stack got modified and we had only two elements left into it. Then here we called peek at line 22, and we just at line 23 we printed the peeked element or the top element. So in this particular stack, if we call peek, we got Germany. But if we printed the stack again, we can see that Germany is still there because peek just returned the top element, but it did not remove the top element, whereas pop will remove the top element and also will return that element to you if you want to store it. So that's all I wanted to cover in this particular session, where we talked in depth about the stack features. And like I always say, please also go to the Java.doc API and read about all other methods and functionalities which are provided by the stack collection. In the next session, we are going to focus on queues, and we'll look at a hands-on demo of queues as well. Let's get started with queues in Java. So again, taking it back to the time when we discussed about the collections framework, we briefly discussed about the queue interface and what is the property of a particular queue. So queues were again inspired from real life queues, which you form whenever you try to go to a particular place where you want to get your things done. You generally stand in a queue. And this queue interface is directly inspired from that particular scenario itself, that it works on a FIFO arrangement. So now if you think about the FIFO arrangement, and let's connect it back to the previous lecture where we discussed about stacks, and we said that stacks are a LIFO arrangement. So in case of a LIFO arrangement, you had the last in, first out philosophy. But in case of queues, you have the first in, first out philosophy. It means the first element which enters the queue will be the first element removed from the queue. That is the basic premise around which the queue interface or the queue collection is formed. So remember that particular concept, whenever you have a situation in your project where you need to implement this kind of mechanism, that the element which got inside the collection should be the first one coming out of the collection, then you should be always thinking about queues. Whereas if you have an arrangement where the last element inserted should be the first element out of the collection, then in that case, you should think about stacks. So remember the value proposition of each of these collection types, which will help you take a decision as to which particular collection to be used in which scenario. So talking about queue is again an interface. Again, like I said, we are very soon going to cover the concept of classes and interfaces and abstract classes. So just hold tight on that particular concept. But connecting it again back to the theory lecture where we talked about the collections framework, you can think of an interface as just a blueprint, just a skeleton with nothing concrete implementation details inside that interface. So the queue is again an interface, and there are few implementations of it. One of the most popular implementation of queue interface is a priority queue class. So the priority queue class is again, technically it is a queue, which basically works on the concept of first in, first out. But at the same time, it also works on a priority. You can assign a priority to the elements, which will decide when which element is going to come first and which element is going to come second. And that concept is basically again governed by the same natural ordering logic, which we have been seeing in other ordered collections like tree set and TreeMap. So that's the basic idea about priority queue. And let me take you to a hands-on example so that you can relate it better. So here I have a class which is called queueDemo. It has a public static void main method. And then at line number 9, I'm initializing the queue. I'm saying that this particular queue should hold only string objects, and it is a type of priority queue. And like I mentioned, if you use priority queue, you can see the import of it here. If you see the priority queue, then you get that natural sorting or natural ordering logic phenomena out of the box. Because we are using strings here, so Java already knows how to sort strings, and it is going to sort strings in the alphabetical sorting order. If you are providing a custom class of yours, maybe let's say queue of students, then in that case, you need to tell Java how to sort those elements. And like I mentioned in the previous sessions, we are going to cover in detail about how do we write that sorting, we provide that sorting implementation or sorting logic to Java in case of custom classes, but we'll cover that when we'll cover about that sorting logic. For now, for the demo's sake, we are just taking a string or a queue of strings basically, which is of type priority queue. And then again, following the same example as we saw in the case of stacks, just so that you can build some sort of similarity. I'm again inserting few strings here, which are country names. So at first I'm inserting India, then I'm inserting Germany, and then I'm inserting America. So I have basically added 3 entries into this particular queue. Then at line 15, I'm just printing the queue, and I just want you to see if I inserted elements in this order, where India with an I go first, Germany with a G goes second, and America with an A goes third. And if it is a priority queue, does it automatically sort the elements or not? So let's first observe that part, and let me comment the rest of the code. We will cover the rest of the code slowly so that we build a sort of cognitive flow. So let me comment this code, and let's just print the queue for now. So I'm inserting the elements into the queue and just printing the element. Queue has a concept of head and tail. Remember that. So the very first element in the queue is basically the head, and the very last element is the tail. So whenever you see the term head and tail, you can remember that head is the first element and tail is the last element. So now let's try to run this code and see what happens if you just print the queue as is. You're not iterating over it, you're not accessing any particular element, but you're just printing it. So if we do this, we see the output here, which says original queue. This particular one says America, India, and Germany. Now this might be looking confusing, right? Because if I apply natural sorting, then America should come first, which is okay. Then Germany should come because after A, the G is the next natural alphabet starting point, and then India should come. But we see India in the middle here. The reason is because when you call this inside the system.out.println method, let me just go back. If you print it inside this particular system.out.println method, automatically when you try to print a variable, its toString method is called. So technically under the hood, this is what is getting called. Though we don't need to write the toString, but the moment you try to print any variable inside the system.out.println, automatically its toString method is getting called. And the interesting part is, if you call the toString method, it will call the abstract collection classes toString method, which does not understand sorting. So remember that very well. If you're working with priority queues, then in that case, if you just try to print the queue, you will not get the natural order. But once you try to add or elements or remove elements or peek the elements, in those cases, you will get the natural ordering sequence. But if you just print the queue as is, you will not be able to get the natural order, and it will be random order. That's why you see a random order. But let's try to build our understanding around the natural order. So once we have printed the queue, now let's understand the other method of the queue, which is the remove method. And if you remember, I told you that this is a FIFO queue. So if you try to remove an element, the head of the queue is going to get removed. The head in this case is this string America, which should be removed from this particular collection if I call remove method. So I'm just calling the remove method and then printing the remaining queue. Again, this queue will be printed in random fashion, but if it is respecting the priority queue's natural ordering sequence, then America should get removed once I call remove. So let's verify our understanding. So I can see the queue after removing the head element remains as Germany and India. These are the elements which are left now, and America is removed from this particular queue now. So that verifies our understanding that when you call remove, the head of the queue will be removed, and the head will be the alphabetically sorted first element of the queue. There's another interesting method in the queue. Similar to stacks, we have a peek method. If you just want to view which element is sitting at the head of the queue, if you just want to view it, you don't want to remove the element, but you just want to view the element. In that case, you can call the peek method. So I'm just calling queue.peek and storing the output of queue.peek into a variable called head, and then just printing the head. So let's see what happens in this case. Okay, so I'm getting this message which says head of the queue is Germany, because Germany is now the new head after America was removed from this particular collection. So that is our head. And like I said, whenever you call these methods, these will respect natural sorting order. Sysout will not respect natural sorting order. Remember that. Another interesting method is poll. So poll method is basically used to remove the element and also return the element. So you can see which is the head, and it will also remove the head both at the same time. But in case of remove, you were just removing the element. You were not able to see which element was removed. In this case, you will be able to see which element is sitting at the head, and also at the same time, the head will also be removed. So for that, you need to call the poll method. So I'm calling queue.poll and storing this again in the same variable head. So the head variable's value will get just overwritten if I reuse it again. And then I'm printing the removed head. Let's see. So I'm just running this application again, and I see this message, removed head Germany, which is coming from here. So when you call the queue.poll, the current head of the queue got removed, which was Germany, and it also was returned from the poll method. So you can store the removed element and use that removed element for further processing in your program. And after that, only one element in the queue should be remaining, which is India. So at the last line number 26, I'm just printing the remaining portions of the queue. So yes, now only India is remaining. So you can see all the outputs here. This was where we started from. Then we removed the head element of the queue. So this element got removed, and we were left with Germany and India. You can see here India, Germany was in this order, and here the order was changed because it is random order when you use it under sysout. Then we wanted to just get the head of the queue, but we did not want to remove it. So we used the peek method and we got Germany. Then we wanted to remove the head. So we removed the head with the help of poll method, and it also returned the removed element, which is Germany. And after the removal, the queue looks like this, which is having just one element left in the queue. And in this case, the head and the tail both is India in this case. So this string will be both the head and the tail. This is a special case if the queue has only one element left. So this is all I wanted to cover in the case of queues. And like I mentioned in all the previous sessions as well, do go and check out the Java Docs API of the queue interface and the priority queue classes. Learn and just get familiar with all the different methods which are available in this class, so that when you start using these queues types or these collection types, you know what all utilities and methods are available. And even if you don't know, like I always mention, if you just do dot here, it will any good IDE will automatically show you all the methods which are available here, which you can read about in the documentation here and understand what each method does, and you can use that method as well. So that is also possible. So that's it. That's all I wanted to cover in today's lecture. And in the next session, we are going to talk about classes and objects. Let's get started with classes and objects in Java. So like I have been promising in the previous sessions that I will cover this in a dedicated session. And this is the session where we will go deeper into the concept of classes and objects. You have been seeing this keyword all along in all the sessions wherever I ran the different examples. And let's understand what this means. Technically, if you go by the definition, a class is basically a blueprint of an object, which brings the question as what is object? An object is basically an instance of the class. I know this becomes more confusing, so let's break it down into simpler definitions. A class is technically a logical entity. You can think of it as any entity in the world. If you have to, let's say, if you have to build a student management system or a college management system, then all the real life objects which you see, we always say that Java is heavily inspired from real life examples, and classes and objects are the reason we say that, because whatever you see in the world is always basically some entity. Human beings are an entity, cars are an entity, students are an entity, lecturers are an entity. So all the actors which you see in the world are basically entities, and you can map them as classes in the Java program. Now, why do you want to map them? Because these entities have basically two kind of specifications. One is every entity will have some attributes and it will have some behavior. And actually that is how you identify an entity. For example, human beings have attributes like we have hands, we have eyes, we have ears, legs, etc. These are our attributes. Then we have our behaviors. Behaviors are actions. You can think of them as a human being can speak. So can speak is an action, it's a behavior. Can listen is an action, it's a behavior. Can walk is an action, is a behavior. Similarly, can eat is also an action or a behavior. So that's how you basically represent an entity. That's how basically you identify an entity, that an entity will have some attributes and some behavior. If you see those two specifications in any entity, you can map that entity, or you can write that entity inside a Java program as a class, because a class in Java will exactly have these two properties. It will have some attributes, which we call as properties, and it will have some behaviors, which technically are called as methods. So it will have attributes, and it will have properties and methods. Similar to real world entity where we have attributes and behavior. Behavior are methods and attributes are properties. That's how it is. So if you apply this simple philosophy, whenever you are taking requirements from a customer for a particular project, always try to identify these entities, these actors in your program. Once you have identified those, you will be able to write a corresponding Java class in your Java program, which can represent those entities. And without representation of those entities, you cannot write the program. So Java will kind of force you to think in this direction, to find entities which will have attributes and behaviors. So taking that philosophy further and taking that example further, here for you, I have prepared an example where I am creating a student class. So basically, let's say if you have to build a college management system or a student management system, then student is probably one of the main entities which will be talked about when you take the requirements. So if you think about the attributes and the behavior concept, a student will have a name, will have an age, will have an address, and at the same time, a student can also have some behaviors, like can enroll in a particular course, can attend a lecture, can take a leave, can take exam, etc. These are all behaviors. Let's understand this in a more detail with the help of this example where I've created a class which is named a student. And you see the public keyword here. Again, I will cover access modifier. Public is basically an access modifier, and I will cover this in very detail in the upcoming sessions. For now, let's focus on this part. So we have created a class to represent our entity. You put a curly braces around it. It ends here. And after that, you provide the attributes. So here I'm saying that a student will have a name, it will have an age, and it will have an address. It has three properties. So the technical name of attributes is properties. After that, let's skip this part and I will come back to this part. Once you have declared these properties, you would want to provide a way for the name to be filled or replaced or received. For example, if you have created the student class, how do you insert the name inside the student class? Or how do you insert the age, or how do you insert the address or modify the age, name, or address properties? For that, we have these setters and getters methods. We call them setters and getters because they start with this keyword, not keyword, but they start with a string called set. It is not a keyword. You can actually write it as anything. You can call it as modify name. That will also be absolutely fine. Java will not give you an error. But the standard naming convention given by Java is to start the methods as starting with set and get. This is the standard naming convention. And like I said, it's a naming convention. It's not a compulsion. But if you write this way, your core developers and the people who are going to maintain this project in the longer run will be very happy. Otherwise, they will be very angry if you use strange methods, because like I said, this is the standard naming convention. So now you are going to write a setter method for each of the properties in this particular class for name, age, and address. So we call set name. Again, you put public void because this is not supposed to return anything. This is just supposed to set the value of name with whatever value you specified. Then you call set name, and then you provide the value which you are supposed to set against the name. So whatever value, like any random name, John or Jane, whatever, you need to supply that name here while you call this method. And that name, whatever name you supply, will be set against the name property of this particular class. And remember, I use the word this here intentionally because the way you are going to represent this is with the help of this keyword. This keyword means current object. It means that when you use this dot name, it is referring to the current object's name property. And this name is basically corresponding to the name which is coming in when somebody is trying to set a name. Similarly, for set age, age is a numeric number. If you observed, it's basically an integer. Then I'm saying int age, and whatever value of age will be coming will be set in this particular object's age. Then similarly, for set address, we have a string address argument being passed into this method, and this gets set inside the current object's address property. So I've provided a way for the external world to set the values of name, age, and address, because for each student, you would need to set these values. Now, you also need to provide a way to receive the values or to return the values or to read the values. For reading operation, you need to provide the getter method. So you see this get, again, this is not a keyword, it's a standard naming convention. So similar, when you wrote set name, similarly, you will write a get name method. This get name method is supposed to be reading the current object's name's properties value and will return that value. Since name is a string, that's why you see the return type as string here. Similarly, get age is going to return the age, which is an integer, and address is going to return the address. You can also write it like this, which is absolutely fine. It is not going to complain because technically it is returning the current objects, name properties and age property and the address property. Now let's talk about this. What is this section? So this section is basically called a constructor, and I have a whole session dedicated on the constructors, but let's understand why we need this. Remember when I told you the definition of the class, I said that class is a blueprint of an object. So you have created a student class and you have 5,000 students in your college. Now you need to create a new student object for each of those students. You need to initialize this student class 5,000 times. How do you do that? To do that, we do that with the help of constructors. We call this constructor. This is a special type of method. Remember, this is a special type of method which is provided by Java to initialize any class's objects. If you want to create multiple objects of the student class, you can repeatedly call this student constructor. We call this constructor. So you put public here because we want this constructor to be accessible to the outside world. Then you put the exact class name. So whatever class name you have provided here, you need to put the exact class name here. If you don't do that, Java is going to raise an error. If I do this here, it is going to, you see a red line here because Java failed to compile this constructor. It does not understand what is student 111, but it does understand what is student. So this is how it is going to be. And then you provide all the properties which are going to create the student object. So you're going to create the name, the age, and the address. So the name, age, and address. And then you set those values again, similar to the setter methods we have seen. The reason we need to use this here because if you write it like this, then Java doesn't understand the difference between the current object's name and the name coming from the argument. So to differentiate that, you need to use this here. If you use n here, and if I just use n here, then this is fine because there's only single name variable in this whole class then. But if I write it like this, then Java doesn't know if this name is basically the student class's name or this name is student class's name. It will get confused, like you are getting confused if you try to just find this in the mind mapping. So that's why we need to write this here so that it's clearly differentiable that whenever I use this dot name, I'm referring to the class's name property. And when I'm just using the name, I'm referring to the method argument. That's what we do in this constructor. So you basically initialize all the properties of your class with some values with the help of constructor. So we have the constructor, we have the setter, we have the getter. We can cover about this toString. Basically, this toString is to print something, but we can cover that later. Now let's initialize this particular class. So I'm similar to the initialization we have seen so far. You just write student, you write the object name, this can be anything, and then you use the new keyword, which is used to initialize anything in Java. New is a keyword in Java, which you can use to initialize literally anything in Java. So you use new student, and when you say new student, you can provide all the values which should match its constructor. So here we have three values: string, integer, and string. And here also we are supplying three values: string, integer, and string again. So remember to match this exactly with one of the constructors which is available in the class. If it doesn't match, it is going to fail. It will not work. So if I, for example, if I do this, then I'm supplying 4 arguments to the student class, but there is no constructor matching 4 arguments, so it is going to complain. You see this red line and the code is not compiling. If I remove this, then it is matching it. And that's how you basically create a student object. So an object is basically an instance of the class. Remember that very well. An object is an instance of the class. Once you have created an instance of the class, then you can call any method, like say, let's say you want to read the name. So you can call get name. You can read the name. Similarly, if you want to, if you want to read the age of the student, then you can do that as well. So let me just copy this and do this. Let's call get age. I want to print the name, I want to print the age, and I also want to print the address. So get control space, I get suggestion address. Yep. So I'm printing the name, I'm printing the age, and I'm printing the address after I have initialized the object successfully by using this constructor representation using the new keyword. So now let's run this method, or run this class basically. Okay, so when I ran this class, the whole class got compiled, the constructor, the getters and the setters and the properties and their types, everything was set. Then the main got called and I created a new object from this class's blueprint. The object name was John. Then I called john.getName to print the name which is stored inside this particular instance of the student class. Similarly, the age which is stored in this particular instance. So we stored the name as John. So when we call john.getName, we get John. When we call john.getAge, we get the age 25. And when we call john.getAddress, we get this particular address. Whatever values you specified here, the constructor got called here, and the name John got set to the student's name value. The age value which you supplied got set against the student's age, and the address value which you supplied got set against the student's address. And that's how you are going to create a class. So remember, whenever you create a class, identify the properties and the behaviors like setters and getters. Write a constructor which can cover all the values which you want to initialize. And after that, just initialize that class, create an object of that particular class basically, And once you have the object, then you can call getters. You can also call this in this way. If I don't supply any of this, then currently it complains. And why it complains, I will cover that in the following session when I will cover the multiple constructors concept. But remember, you see this behavior here that if you have created a constructor which accepts some arguments, and if you supply this kind of initialization, then student class does not have a constructor which is parameterless. Student class has only one constructor which is taking 3 parameters. And that's why Java complains, because it is not able to find a representation of a constructor which accepts no parameter. But like I said, we will cover this. We will find a solution to this particular problem in the coming session. But for this session, this is all we are going to cover. We covered about classes, we covered about objects, and we also saw how we can write getters and setters. We can initialize those methods, initialize those objects, and we can access the properties of those objects using the getters. And we can also call the setters to modify the values as well, similar to this. So this is all I wanted to cover in today's session. And in the next session, we are going to dive deeper in the concept of constructors and how we can write different types of constructors. Let's get started with constructors in Java. Now, if you remember in the previous session, we covered about the concept of classes, and we walked us through with an example student class where we had a constructor. If I just open this back, this is the class which we covered in the last lecture. And we had this constructor where we supplied the necessary number of arguments which can match my student's properties. And then I set those properties calling this dot property equal to the argument, like this. But what if you have a use case where some of the values are mandatory and some of the values are optional in these properties section? For example, what if all the students have same address? Although this is a very hypothetical situation, but let's assume if you have a scenario where you have a particular entity, you have identified the entity, but there are certain properties in the entity which remain constant for all the objects. If you have such case, then it does not make sense to supply an argument for that particular property which is going to remain the same for all the objects. What if you can just initialize it with some default values? That would be simpler, right? Because let's say, for example, if this property is going to remain constant for all the student objects, then you can just supply these two properties, these two arguments in your constructor, and you don't need to supply the address. Let's go further. What if you have a class where you have more than one property? Let's say if your class has 10 properties and 8 of them are remaining constant or are optional, and only 2 are changing and mandatory. Then how would you write that? And what if you have a different use case for the same class? Let's make it even more complicated, that you have a single class. The same class or entity is being used by different consuming applications. One application would expect, let's say, these 2 to be mandatory and this one to be optional. Other consumer application wants these 2 to be mandatory and this one to be optional. The third consuming application wants all 3 to be mandatory. The fourth consuming application wants none of these to be mandatory. Then how are you going to do that? The answer is multiple constructors. You can write multiple constructors for each of those consuming applications, and whichever application wants whichever constructor, they can use that constructor to initialize the object of the class. So taking that concept further, I have created a class called cuboid. And I have 3 different properties written in this class. As we know that a cuboid has basically 3 properties, which are width, height, and depth. So I'm taking that example here, creating a class for a cuboid, providing the width, height, and depth. For simplicity, I'm taking this as integers, but generally you will see this as doubles probably, because the values can be in decimal points. But for simplicity's sake, I'm just keeping everything as integer here. Then with a standard use case, if you have to create an object of this cuboid class, you would need a constructor where you can supply all these 3 values. And here it is. This is the constructor which can be called to provide these 3 values. So I'm supplying the width, I'm supplying the height, I'm supplying the depth, and then I am setting all of these values with this keyword, say this dot width equal to the coming width. This object's height will be the height which is coming from here. And this object's depth will be the depth which is coming from here. Now for another use case where let's say there's another consumer application where it would expect the depth to be constant for all of its objects, let's say a value 10, and it only wants width and height to be supplied. Then you can create another constructor. Java does allow the use of multiple constructors in the same class. Remember that concept. So you can create another constructor for that representation where you supply only the width and height and you keep the depth constant. Now, if a consumer application calls this constructor 100 times, all of those 100 cuboid objects will have the depth as 10 only. That will be the fixed value, and only width and height will be the changing values. Similarly, if there's another consumer application which wants to have the same height and width and depth for the cuboid, then it would just require a single parameter. Whatever value the consumer application is providing, you're setting the same value to the width, to the height, and to the depth. So technically, this is basically becoming a cube because then the 3 dimensions, the height, width, and depth are same. And what if you have another consumer application which does not intend to supply any of the values because for it, all the objects are going to hold the exact same values for all the properties. Let's say there's a consumer application which would always expect the width, the height, and the depth to be 10. Then you can create a constructor with no arguments. You can see there is no argument here. You can create a constructor like this, and you can supply all the default values, which are static values. So in this case, I have created 4 constructors. I have created this constructor here, which accepts all the values. And whenever you call this particular object, you will have to specify 3 values, and each object will have the width, height, and depth different. Second use case where a consumer application wants the depth to be constant with the value 10 and only wants the width and height to be variable for each of the objects, then this particular constructor can be called. Similarly, for another consumer application which would want to just supply a single value, and it would want whatever value it supplies, it would want the height, the width, and the depth to be exactly the same as that value supplied, then it will supply only one value, and the same value is going to be set against height, depth, and width. And the fourth use case is where the consumer application does not intend to supply anything at all, but it would want the class to set some static values for all of its objects. So then it can call this constructor. And then I define a behavior. Remember the concept of behaviors. I define a behavior here. I have not defined the getters and setters here, but you can definitely do that. There's nothing stopping us from doing that. But for simplicity, I just skipped that here. Then I define a behavior to basically this class will provide a behavior which will be to create the calculate the volume based on the values which you supply. So whatever value you supply, based on that, the cuboid is going to calculate the volume. And as we know, the formula of volume is width into height into depth. That is how we are going to calculate the volume of a cuboid based on whatever values of width, height, and depth are supplied. So let's see this in action. I've created a public static void main method. I've initialized a variable called volume, which is an integer variable. We'll see how we can use that variable. And first, let's create a standard cuboid. So I call this particular constructor with 3 arguments. So when I do this, this particular constructor gets called, and the width, height, and depth values, which I supply here, 3 values, will get set, and I get a standard cuboid, and then I can call the standard cuboid dot volume. Then this particular method will be invoked, and the volume will be calculated with this formula with these values. That's how we're going to calculate the volume for a standard simple cuboid, and I'm printing that volume value exactly here. So this is basically the standard constructor being called with 3 arguments, calling the volume method, and then just printing the volume. Second use case where I'm calling the constructor with 2 arguments, and the third value should be set automatically. So I'm just supplying 2 values here. When I call the constructor with 2 values, a matching constructor should be found here with 2 values. Here it is. So width and height will be set with the values which I am supplying, and depth will automatically be set to 10. This is what is happening here, cuboid with some defaults. And then I again calculate the volume and print the volume. I'm just reusing the same volume variable here. In the third use case, I'm calling the constructor with a single parameter. So I'm just providing one value, and the same value should be set against all the width, height, and depth values. and technically it becomes a cube, so I've just called it as cube here. Then I'm calculating the volume of the cube and printing the volume of the cube. And then at last, I'm using the constructor with the new arguments. I'm calling this as default cuboid because I'm not supplying any values. And then I'm again calling the volume method on this and printing the volume. So these are the 4 constructor invocations. So this class is demonstrating 4 different kinds of constructor invocations. Let's run this class and observe the output. Okay, so let's start from here. I called this particular constructor with 3 arguments, 10, 20, and 15. And then the volume was calculated, which would be 10 into 20 into 15, which is 3000. So this sysout basically prints this output. Then move on to the next one, where I'm saying cuboid with defaults, which is having the value 10 and 20. And the third value of depth is automatically being set to 10. So technically, when I call the volume, it will become 10 into 10 into 20, which is 2000. And that's how the volume of the cuboid with default depth is printed from the line 47. Going on to the next one at line 51, the volume of the cube is basically the volume which is calculated after calling this particular constructor and calling the volume method. So here the height, the width, and the depth, all 3 are set to 10. So it will technically be, when we call the volume method, it will be 10 into 10 into 10, which is 1000. And that's how you get this output. It says volume of the cube is 1000. And then I call the default cuboid method, which is simply providing no values, and we expect everything to be set with some defaults. And the default constructor is setting the value as 10 for height, width, and depth. So in this case, if I'm calling the volume method and if I'm printing the volume, it should be printed as 1000 because 10 into 10 into 10 is 1000. So this is basically to showcase you how you can use different constructors. There's another thing which you should know is if you do not provide any constructor to this particular class. Let me just comment out all the constructors in this class. And let me comment out most of the code here as well. So now if you see, I have not provided any constructor in this particular class, right? There's no constructor. Let me just maximize this. So there's no constructor being called here. There's no constructor being left here. Everything is commented. So there's no constructor in this class, but this line still passes. There's no compilation error. There is no red line on this particular line. The reason is if you do not provide a constructor to a class, Java by default will provide a constructor, which will be the no parameter constructor. So remember that whenever you don't supply any constructor, you can still create objects of that class with this non-parameterized constructor representation, like student equal to new student without any parameters. That will work if you have not provided any constructor implementation inside your class. And if we do that, let's see what value do we get, because I have commented the default constructor, everything here, right? So let's print the value. If I go to run as, I get the value as 0. So what happened here? When I call this particular line, the default constructor provided by Java gets called, and Java will set the values of all the properties to the default values which are supported by the data type. And integer primitive data type's default value in Java is 0. If you do not provide any, if you do not assign a value to an integer variable, by default it is going to be initialized with 0. That's the Java's behavior. And that's what is happening here because we did not provide a default constructor. So when we call this new cuboid here without any parameters, without any arguments, the default constructor of Java gets called and it sets everything with the default values, which is 0, 0, 0. And then if we call the volume method, it's basically 0 multiplied by 0 multiplied by 0, which will eventually be the output as 0. And that's how you get this 0 output. Let's try one more thing. What if I enable one constructor? Let's enable any one constructor, which is having at least one parameter. Let's say this one. So I have enabled one constructor. I have commented in, I've just removed the comments from one constructor, which takes a single argument. And let's go down. Now you see an error. So this is something, again, a Java's behavior, that if you provide even a single constructor in your class, which is having at least one parameter. I'll just repeat that. If you create any constructor in your class, which is having at least one parameter, then the default constructor implementation of Java will not automatically work. in this case, you will have to explicitly provide a default constructor as well. The default constructor will only and only work if you have not provided any constructor at all in your class. The moment you provide even a single constructor which is having even a single parameter in your class, then the default constructor out of the box will not work, and you will have to explicitly provide a default constructor. So to make this work, I have to just enable the default constructor code, and then only it will pass. So if no constructor, it will work without any parameter. But the moment you provide even a single constructor with even a single argument, then you have to either use that parameterized constructor, or you have to provide your own default constructor implementation, because Java will not use its own default constructor implementation in that class. So I hope you find this particular concept useful, and remember this concept, because this is again, this can be confusing when you are reading somebody else's code. You need to always understand what all constructors are there. And in the next session, we are going to talk about another very interesting and exciting concept in Java, which is about streams. Let's get started with streams in Java. Before I go any further, I just wanted to clarify that when I say stream, I am not talking about the input-output stream, but I'm talking about stream as a concept in general. This is a slightly newer concept which was introduced in Java 8 and has been there, and it is extremely popular. And the reason Java introduced the concept of streams to the JDK was to promote the functional programming paradigm. What we have been seeing so far is basically an object-oriented paradigm where you execute one line at a time, but functional programming provides you more optimized way to run multiple lines of code as a sequence of functions in a single line. So the same lines of code which you would write in Java in a classic object-oriented way in, like, let's say 10 lines, the same line of code, that whole 10 lines of code can be written in a single line using the functional programming paradigm. So let's understand the concept of streams first. So the basic concept of streams is to help you iterating and manipulating collections. So remember all the classes which we covered in the collections framework, the list, the set, the map, etc. Streams provide you with a better and optimized way to basically allow you to manipulate those collections, iterate over those collections, change the representation of the collection types, etc. So to understand why we need streams, let's understand how the streaming works. So let's take a very simple example. If you watch a YouTube video, it is basically streamed to your device. And when we say stream, it means the whole object, the whole video size is not downloaded at once on your device, and it is being downloaded bit by bit to your device, piece by piece to your device. This is better in a lot of ways. Your device does not need the full memory to store the complete video, because it is only going to process 1 byte at a time and just throw it away once it has been watched. So the streaming will basically help you work on a very large size item using a very small memory footprint. That's the power of streams. Contrary to that, you can also, let's say if you're watching a 1 gigabytes video, then you can either download the whole 1 gigabyte video on your mobile, which is going to consume complete 1 gigabyte space on your memory, or you can stream that 1 gigabyte video onto your mobile device, where maybe only a few megabytes will be required to watch the whole video, because at a time it will only consume few megabytes and it does not need 1 gigabyte of complete space to stream that video. So that's the basic idea, and that's why streams are very popular and very optimal way to work with collections. And let's understand with the help of an example. Actually, I've prepared multiple examples of multiple capabilities of the Streams API. So Streams is basically an API which is provided after Java 8, and you can use that to iterate over collections or manipulate collections. Let's see that, and let's also compare that with how you have been doing this before Java 8. So here I have created a list. You can see it's basically an integer list, and I have created an array list here. I have added few numbers to this particular array list. So numbers are 10, 20, 30, and 40. So precisely 4 elements are inserted into the list. Now you have a requirement in your project that you need to basically calculate the square of each of the elements of the list and prepare a new list. That is the requirement. So if you were not using streams, you would write code something like this. You will initialize the list, a new list basically, which you can call it as anything. For example, you can call it as squares list. And then you are going to call an enhanced for loop here, iterating over the numbers list one by one, taking each element, calculating the square of it, and then adding that element to the new list. And that's how you're going to write this logic if you were not using streams. So you can see it's basically technically 1, 2, 3, 4 lines of code just to get the list. If you were using streams, then you can do this with a single line. Let me just comment out the old code, and let me just bring this to the same line to show you that it's a single line code. So the same logic which you wrote here can be written just like this. You can see it's so optimal, so simple. For the processor to compile this code is also very fast because they can process a single instruction very fast and very quickly. And streams do utilize the multi-core capabilities as well. So now is the time and the era of multi-core processors, and that's why streams are more beneficial to use rather than writing the verbose instructions. So let's understand how this works. To convert a particular collection into a stream, you need to call the collection type.stream. So here the numbers list was the collection variable. So once you call this .stream, you will get a stream representation. Now the elements of the list are being streamed one by one. They are not being sent at all at once. They are streamed one by one now. So you get a stream the moment you call stream. Then now the stream API has multiple methods, utility methods, which you can read about. For example, if I just write a dot here, you will see lots of utility methods which the stream API provides you, which you can use in different conditions. We are going to cover few of the very important and very popular methods, but again, please do read out the streams API documentation to get the hang of all the other methods. So once we have the stream, then the first method which I'm going to showcase to you out of the stream API is the map method. Map method can be used to change the representation of the elements one by one. And that's what we need to do, right? We need to change the representation of these elements to the square of these elements. So remember that line which I said, whenever you have to change the representation of the elements inside the collection, think of map. Think of the map method. This is not the map collection. This is not the map collection. This is the map method of the stream API. So if you're using stream API, you have a use case to convert the representation of the elements of the collection. Think about maps always. So I call the map method here, and then you see the strange syntax here. This is basically a lambda function syntax. So lambda function is another concept which Java introduced in Java 8. Lambda is as a concept has been there in some other programming languages like Scala for a very long time, but it's been introduced in Java of late in Java 8 only. And lambda is basically, you can say, is the paradigm which will enable you to write functional programming constructs in Java. And the syntax of lambda is very straightforward. You provide a representation of the element here. So each element here, one by one, is going to be represented to X. Then you write this arrow here, basically a hyphen and a greater than sign. And after that, you write what is the final value which you want to see for that particular element. So here my requirement was that I want to convert the representation of the element to the square of its element. So I just do X into X because X is the current element. I want to change this to this. So whatever destination representation you have in your mind, write that on the right-hand side of this arrow. On the left-hand side, it will be the element. On the right-hand side, it would be the representation which you want to work with. So you have written your conversion logic inside the map method with a lambda function representation. Under the hood, if you want to know more technical details about it, it's basically working on the concept of functional interfaces. Do read about the functional interfaces concept as well. That will help you build the usage of lambda functions and how this whole construct is written. So read about functional interfaces and lambda functions to understand map in detail. And but to work with it, like I said, the left-hand side will be the element and the right-hand side would be the final representation which you want to have for that particular element. Once you have done that, till this particular point, you have converted the collection into the stream. It is streaming the elements one by one, and you have successfully also calculated the square of each element, but this is still a stream. Now you need to convert the stream back to a list which can be used further in your program. So to do that, you can use the collect method, which we also call as the terminal methods. This is another concept which I'm just introducing to you right now. So there is an intermediate method concept and there is a terminal method concept. This is what streams understand, Java stream understands. when you say intermediate method, those methods are, or those operators are basically the ones which are used before the final collection is prepared. Like the map method is basically a intermediate operation. And then you have some terminal operations like collect. Once you call the terminal operations, after that, the stream has been concluded. The stream is dead. So once you call this collect method, and if you try to do something here, again, let's say if you want to do something, it will not work, because the moment you use the collect method, stream will expect this to be the last method which you want to use in this particular instruction. After that, the stream is dead and you will get strange exceptions if you try to write any further operation after collect. So also do read about what are all the different terminal operations available and what are all the intermediate operations available. I'm going to cover a bunch of these in the different examples I've prepared in this particular class, but because I will not be able to cover all of the methods, so do read about those methods, what are the intermediate operations and what are the terminal operations. And the concept I just explained to you, intermediate operations can be used in a chaining fashion. After this dot map, you can use another dot map, another dot map, another dot map. You can again like do this. This will work fine. You can keep concatenating multiple map methods and multiple filter methods and any of the other intermediate operations which are available. But once you have called the collect method, after this, you cannot call another map. If you try to do this, it is going to fail. It will not work because collect is a terminal operation. And what I want to do in the terminal operation is I want to convert this new stream, which is having the square of the elements, convert that back into a new list. And to do that, I can call the collectors.toList method. The moment you write this method inside the collect method, it is going to take the stream of the elements one by one, just collate that stream into a single stream, into a single collection, and then return that collection back into the list which you want to store it in. So remember the collect method, terminal operation, and the moment you do collectors.toList, the whole stream's elements is going to be converted into a list, and that list is going to be stored into whatever left-hand variable you have written. And that is how you can basically write this whole code which we wrote in 4 lines into just a 1 line, and then you can print the squares list. So let's do that. Let me comment this particular code as well so that we don't get any strange errors or strange outputs. Let me comment this part as well. We will cover these one by one, and let me cover all of this as well. I'm just going to comment everything here, and we'll focus on only the squared list which we have prepared using the Streams API. So right click, run as Java application. There you go. You have the output here. So the first number was 10. The square of it is 100. So yes, you get 100. Second number is 20. The square of it is 400. Third number is 30. The square of it is 900. The fourth number is 40. The square of it is 1600. So you get all the values squared by using the Stream API. And like I said, you can write the same code in the old way as well, but this is the efficient and the better way of writing the same code in a single line. This is all I wanted to cover in today's session. Let's get started with Streams API in Java. In the previous session also, we covered some basic functionality of the Streams API of how we can convert a list of numbers into the squares of the numbers of the same list. Today, we are going to look at an extension of the same kind of functionality. Let's say you have a requirement where you have a list and you are asked to convert that list into a set. And while you convert the list into set, you also have to calculate the square of each number. So instead of just converting the list of numbers into a set, you have to convert the square of those numbers into a set collection. That is our objective. So I'm going to use the same list which I had created in the previous example, which you can see here. I have a numbers list and I've added 4 elements to it, 10, 20, 30, and 40. And then if I did not have to use stream, or if I did not have the option to use stream, this is how the code would look like, where you would explicitly create a set of type Hashset, and then you will iterate over the numbers list, and then you'll pick each item of the numbers list and multiply it by itself, hence calculating the square. And then you will be adding that result into the destination set. This is what I'm doing here, just to show you the different comparison of how do you write it in the classical way. And then in a while, we will look at how we can write the same kind of functionality using the Streams API. So let's first run this particular approach where I'm adding all the square of all the elements into a set, which is a hash set type. So the order of the set is not guaranteed because I'm using a hash set. and then I'm just printing the hash set. So let's try to run this program. So I go to run as Java application and I get the output. And you can see if you look at the list here, the results are not in the same sequence in which the elements were added into the list. It is because of the nature of the hash set. But we do get the result as expected. Now, if I have to write the same kind of functionality using the Streams API, then this is how I will write it. I will just uncomment this one and will comment out this one. So now if I look at this new code, it's doing the exact same thing, but in a functional programming approach and using the Streams API approach. So I'm again calling .stream, hence converting the list into a stream, then calling map, which is to use to change the representation of the elements of the collection. So I'm changing the representation from the single number to the square of it, and then calling .collect, which is a terminal operator where I'm converting this stream into a set by calling collectors.toSet. So toSet is the method here, which is going to convert this into a set. And then I'm printing the square set. So let's run this program and observe the output. If I run the program, I get the same output. So I can achieve the same kind of functionality, but much more efficiently using the Streams API. So this was an example where I could use the collectors.toSet method to create a set out of a list. Now let us move forward to another interesting and very popular functionality, which is filtering. So let me comment this code again so that we don't get multiple outputs. And let me uncomment this code here. So what I'm doing here is I'm creating a list of languages, which is an array list. And then I'm adding 3 elements to this particular array list, which are Java, Python, and Scala. And this is a string of the list of strings here. So I'm adding 3 strings here. These strings can be anything. I've just taken the example of programming languages here, but this can be anything. So technically we have a list of string objects. And then my task is to get a new list out of this existing list, which will have the elements which start with the letter P. Let's say that is your requirement, that you have to get only the elements of this list where the name of the element starts with the letter P. If that is your requirement, probably this is how you will be writing the code if you are not using the Streams API, where you will create a new list, an empty list basically, and then you will iterate over the old list, which is the languages. So you will iterate over the languages list, and then you will pick each element of this particular list and check if that string starts with the letter P. If yes, then you will add that particular string element into the new filter list by calling the add method, and then you can print that particular list. That is how you will be doing it if you were not using Streams. So let's run this program and understand the output. So I'm again going to right click, run as Java application. And the output I get is Python, because that is the only string in the list which starts with the letter P. So we get the expected output. Now let's try to write the same code using the Streams API. So let me comment this code and I will save the file. And let's look at how we can do the same thing in a single line using the Streams API. So to write the same kind of logic using the Stream API, we start with the same kind of syntax where we take languages.stream to convert the list into a stream. And then we call a new method called filter. So filter is the method which you will be using whenever you have to write any conditional logic on all the elements of the list. Remember, whenever you have to write a filtering or a conditional logic on a particular list, then you will be using the filter method of the Streams API. So you will convert the collection into the stream, and then you will apply the filter method to apply the condition. This condition can be anything. In this case, the condition is that the elements should start with P. It can be anything. For example, it can be based on the string length if you want. If it's a numbers collection, it can be if a number is greater than 100 or not. So any kind of if logic which you might have to run on a particular collection can be run using the filter method. So we call the filter method, and we again follow the same lambda function syntax where this particular S denotes each element one by one, and this arrow represents the lambda notation. And then what we want to do, that we want to run this condition on each of the element of the stream one by one. And the condition is that the element should start with the letter P. If that is true, then whichever elements satisfy this particular condition will be getting out after this execution. So the block which I've selected, once the filter method has completed its execution, after that, only the elements which have satisfied this filtering condition will be left in the stream. Rest of the elements have been filtered out. So once you have the filtered result, then you can again call the collect method, which is the terminal operator, and you call collectors.toList, same as the example covered in the previous session. So I'm running the filtering logic and getting a new list, which will have only the elements which satisfy this condition. So I get the collectors.toList result back into a new list, which is called filter result, and then I'm printing the filter result. So let's see if we get the same kind of output if we use this logic. Yes, we do get the same kind of output. And this is something which validates how we can use the filter operation seamlessly by applying exactly the same kind of logic which we used to apply by writing this much verbose code. Another benefit is that the Streams API are more efficient in using the multi-core processors which are common nowadays on any machine. So this is all I want to cover in today's session. I don't want to elapse this session to be even more longer. So we will conclude today's session at this particular point. And in the next session, we are going to have a look at some more functionalities of the Stream API, seeing how we can sort the collections, how we can iterate over the collections, because even this code is a bit too much for the Streams API to iterate over a collection. So we will look at a smarter way of the Streams API by which we can iterate over the collection. We will also have a look at how we can sort collections. Let's get started with how we can use the Streams API to sort collections and also to iterate over collections. And I'm going to use the same collections which we have used in the previous sessions just to build some sort of continuity here. So I'm going to use the same array list which I created in the previous session, which is storing a string of elements, which is having 3 strings, which is Java, Python, and Scala. These are just 3 strings which I'm storing into a list, which is called languages. And now my task is to sort this particular collection. I have to sort the elements of this particular list so that when I access the list, I get the elements accessed in a natural sorting order. So I should get the result Java first, then Python as a second result, and Scala as the third result. Let's make it a bit more interesting. Let me put this at the beginning. So now I have an element starting with S being added first, then an element starting with J being added second, and the third element being added which starts with P. Let me add one more string to it just to make it a bit more interesting and practical. So let me add a new language here, which can be, let's call it basic. So now I have 4 elements here, and now I want to sort this particular collection. So for sorting, Streams API provide a very straightforward way to sort any kind of collection, which is to use the dot sorted method. And we will follow the same kind of semantics which we have followed in the previous session, which is you pick the current collection, call the dot stream method on it, which will convert the collection into a stream. And once the stream has been created, then you call the dot sorted method on the stream, which is going to sort all the elements of the stream in a natural sorting order. Remember, we are using strings here, so Java already knows how to sort strings. If you were using a custom class, let's say list of students or list of customers, then you have to specify your sorting implementation to Java because Java doesn't know how to sort customers or how to sort students. So in that case, you will have to provide your own sorting implementation. And we will cover that in the upcoming sessions. But for now, let's understand this example by using one of the pre-built data types, which is string. And we call the dot sorted method, which is going to sort this particular stream. And then we use the terminal operator, which is dot collect, to convert this stream back to a list. And we do that by calling collectors.toList. We do that and we get the list out. We store that list into a variable called sorted list, and then we print the sorted list. So let's run this program and understand the output. Remember that we have these strings added here. So right click, run as Java application, and this is the result I get. I get basic as the first element when I get the new list, which has all the sorted elements. Then I get Java with a J, then I get Python with a P, and then I get Scala with an S. So you can see that these strings are presented in a natural sorted sequential order here. And that is what is happening because we call the sorted method. And this is how you can use the Streams API to sort any kind of collection. Hope this is helpful to understand the concept of sorting. Now let's move on to another concept, which is about how do you iterate over collections using the Streams API. We already have a way of iterating over the collections using the enhanced for loop. Remember, we covered this at length in different sessions in the past. So we can definitely use this particular logic. It doesn't break. It will not stop us from using this. We can still continue using the enhanced for loop logic to iterate over any kind of collection. But Streams API provides even a smarter way to iterate over the collections. Let's see how we can do that. So let me uncomment this particular code here. And now if I look at this particular code and if I try to understand it, I will see a sort of similarity with the way we have been working with streams. So we'll follow the same drill. We'll pick up the existing collection, call the .stream method on it. This is going to convert the collection into a stream. And then we call .forEach method. This is the method which you need to use whenever you want to iterate over a collection using the Streams API. So we call the .forEach method. Again, follow the same lambda construct where this is each of the element. Y represents each of the element here. And then I write the code which is supposed to be executed for each element. So in this case, I want to just print every element. That is my requirement when I'm iterating over this particular collection. So I can just put this arrow here. Let me put just spaces here to make it more legible. So each element should be applied this particular logic on. And we are printing each of the element one by one. If I do that, let's observe the output and let me comment this particular code, which we just covered for the sorting logic. So we get only one output. Let's run this code now. So here we see we get some output here. First of all, this sysout gets printed, which says printing all elements one by one. Yes, that's there. And then here we are saying element is, which is a static string, and then every element one by one is supposed to be printed. And that is what we see here. We get all the elements one by one. And here it's not a sorted order because we are not doing any sorting here. It's just printing all the elements. So this is how you can use the ForEach method to iterate over any collection in a single line of code instead of writing all of that code. Now you might be wondering, what if I have to do more than just printing the element? What is it is a multiple lines of code which I have to run for each element? How do I do that? It's pretty straightforward. We just put curly braces here in the starting and in the end of the code block inside the ForEach method. And let me just put an enter here just to make it more readable. So here you can write the code whatever you want to in terms of the kind of logic you want to apply on each element. So once you have put this curly braces, you can write as many lines of logic as required inside this code, inside this curly braces block. And this code is going to be executed for each of the element one by one. If you have just one line of code, you do not need to and you should not put the curly braces. If it's just one line of code, just drop this curly braces completely, remove the semicolon as well along with the curly braces, and this is how you will run a single line of code. But if you have a multiple lines of code which is required to be run for each of the element, then you put the curly braces and then you follow the normal Java construct, which is to end every statement with a semicolon, the usual Java programming code basically, which can go inside the curly braces. So that's how you can use ForEach for any simple and complex iteration logic which you want to apply on a particular program. And this is all I want to cover in today's session. So we talked about how we can use the .sorted method to sort a particular collection. And we also had a look at how we can use the Streams API ForEach method to iterate over the collections. In the next session, we are going to talk about a very interesting method of the Streams API and a very popular one, which is called the reduce functionality. Let's get started with using the reduce functionality in the Streams API. Before we go to the implementation of the reduce functionality, let us understand why do we need it and how the constructs of the reduce functionality work. So let's understand first about the requirement. Why do we need it? So imagine a requirement where you have a list of numbers and you are asked to calculate the sum of all the elements inside the list. a very straightforward requirement that you have a collection and you are asked to calculate the sum of all the elements of the collection. Now, if you do not use the Streams API, you can go ahead and very well write a complex for each logic or an enhanced for loop logic to basically run that code and write the logic where you pick one element or all the elements one by one and keep adding them to the new element. But we can do the same kind of thing by using the reduce method. And to put it in a generic way, if we have to understand why we need reduce methods, so whenever you have to change the whole collection representation into a single result, remember that line, whenever you have to change the representation of the complete collection into a single result, in those cases, you will use the reduce method of the Streams API. And if you apply this definition to the example I gave you, I have a collection of numbers and I want to calculate the sum of all the elements of this collection, which is a single result, which is a single number. So yes, my example does apply correctly to the generic definition of the reduce method. So remember this generic definition. This will help you understand when to use the reduce method in your program. So how does the reduce method work? You can see I have shown you an example of the syntax of the reduce method, and it looks a bit complex here. So let's try to understand what is happening here. To understand the functionality of the reduce method, we have to understand three terms, which are identity, accumulator, and a combiner. Let's understand each of them one by one. Identity is basically an element which is the default or the initial value of the reduction operation. This value will be used if the stream itself is empty, or it will be used as the first value of the result which you want to get out eventually. So in this case, if I have to summate all the elements of a collection, the initial value can be set as 0. And that is the first thing which you have to pass inside the reduce method. So you can see 0 here. The next thing is the accumulator. So accumulator is a function which will take two parameters. The first parameter would be the ongoing partial result. Let's say if you have to calculate the sum of the all elements, and let's say if you have iterated two elements so far, so the sum of those two elements is your temporary or partial result, right? So you need to store that partial result somewhere. And that is the first argument of the accumulator method. In this case, it is this variable, which is shorthanded as ANS or answer. So the first argument is the partial result. And the second argument of the accumulator function is the next element of the stream. So whatever the next element is, which is supposed to be added to the existing result, is going to be the next argument of the accumulator function, which is I in this case. So we talked about the identity, we talked about the accumulator function. Then we have a third one, which is called combiner. And this is sort of an optional, not in all cases, but in some cases it is optional. Let's understand why do we need combiner. So combiner is an optional function which you will be required to use if you want to sum the two elements which do not have the same data type. What I mean is here, this ANS or answer and I both are integer. If both of the arguments of your accumulator function are of the same data type, you do not need a combiner. And that's why there's no combiner here. But if there is a requirement where you are, let's say, adding a current sum to a student object, then it doesn't work, right? Because a student object is a custom object and the current sum is a number object. So a student object cannot be just added to a number object. It can work if you can do student.getAge, which is a number object. So a current answer plus the student.getAge might work, but current answer comma student will not work. In those cases where you have mismatching data types, in those cases you will have to write a combiner function. But for this case, you don't need to write a combiner function because both of the elements or the arguments of the accumulator function are of the same data type. So you specify that argument function's arguments basically, and then you provide the implementation of the accumulator function, which is this one. This is the implementation, again using a lambda construct here. So you provide the implementation of this particular accumulator function, and then there is no comma here to provide further combiner functions specifications. So there's no combiner here. If there was a combiner, there would be a comma here, and then you will write the combiner specification where you will cast the current object into the type which is the same as the partial result. So you don't need that here, and you can just say the partial result plus the current element, and that should work fine. So this is how you will write the reduce logic. And if you have written this logic correctly, then it should automatically just summate all the elements one by one and produce a single result. And remember, I'm using the numbers list here, which is written here in the very beginning, where I have 4 elements to it, which are 10, 20, 30, and 40. So if the reduce operation works fine with my intended objective, then 40 plus 30, which is 70, plus 20 is 90, plus 10 is 100. So I should get the 100 as the final result of this reduce operation. You will also notice that after this particular method, you don't need to call any collector method or any collect method at all. The reason is because this particular function itself will return a single result, which we can store in the desired variable. So now let's try to run this particular example and see the output. So right click, run as Java application, and I get the result as 100, which is coming from this particular sysout where I'm printing the sum. So yes, this is working as per our expectation, where it basically created the sum of all the elements of this particular collection. So remember, when you will use the reduce operation, remember the generic definition. Whenever you have to convert the whole collection into a single result, that would be the use case where you will use the reduce operation. That's one thing. Remember the identity operators definition. Remember how the accumulator function works, and also remember when to use the combiner function. A reminder of when to use the combiner function is whenever you have these 2 arguments of different data types. That would be the use case where you would need to write a combiner function. It is also used if you have to write parallel streams, but parallel streams is an advanced concept which we are not covering in this particular tutorial. But if you want to learn about the whole parallel stream concept, do check out the API docs for that, and you can also have a look at some examples from the Java tutorial official website itself. And that's all I want to cover in today's session. In the next session, we are going to talk about the access modifiers in Java. Let's get started with access modifiers in Java. So when we talk about access modifiers, let's understand what is the underlying philosophy of the reasoning behind this. And the reasoning is very straightforward. It can be even wrapped into a single word, which is called security. The reason is that you will be creating multiple kinds of objects and variables while you write your Java program. And you should always write your Java program or any program in a manner that only the intended classes, packages, modules, or applications should be able to see what they are supposed to see. So as a consumer application, I should only be able to consume the variables which I am expected to consume. I should not get any variable, or I should not even have access to any variable which I am not supposed to access. So the idea is providing the least privilege principle. Give access to different functions, different variables, different programs only by providing them the kind of access which they need to run efficiently, and do not give them complete access. So with that notion in mind, Java created the concept of access modifiers, and it created these 3 modifiers, which are called public, protected, and private. If you do not provide any modifier, then it goes to no modifier, or some people also call it as default modifier, which is also a type of access modifier. So let's understand theoretically first how it works, and then we will try to have a look at an example. Let's understand the first one. First of all, these modifiers are keywords, and you can use these keywords in front of classes, in front of variables, and also in front of methods. And you might have already noticed this particular keyword called public in front of all the classes I've created, or even when we talked about the public static void main method, we saw this public as a keyword. It is basically an access modifier. And whenever you put public in front of a class or a variable or a method, that particular component becomes available to the whole of the program. It will be available to the whole world basically. Any subclass or any package or any other class which might have been written in your Java program will be able to access that particular class or variable or method if you put public in front of that. The second modifier level is protected. One of the other thing which you will understand as I explain this is that as you move down into this particular table, the access level will start getting more and more restricted. And by restriction, I mean that less and less components will be able to get access to those modifiers. So if you write protected in front of a class or in front of a method or in front of a variable, then everything within that particular class will still be able to access it. Everything within the package will still be able to access it. I still haven't covered the concept of package, but I briefly touched upon it, showing you how whenever we write a class, we have a package in front of it, and package is technically is just an aggregation of the classes. If you have to write multiple classes and wrap all of those classes into a single logical bundle, that would be called a package. Just to show you an example, these all are packages which you see here. You see this square box here, and you see these names. These all are packages, and these packages contain multiple classes. And technically, that's all the packages mean, that you can wrap multiple related classes into a single package. So coming back to the access modifier, whenever you write protected in front of a class or a variable or a method, then that particular component will be accessible to everybody within the same class, everybody within the same package. It will also be accessible to everybody which is a subclass of the class. This is again a new concept which I have not covered, but this basically means a child of this class. Now, what is a child of the class? We will cover that concept in detail when we will talk about inheritance. But for now, you can understand that it is basically an extension of the class. So when the moment you declare something as protected, it can easily be accessible within the same class in which this protected component was declared. It can be accessed in the package. It can also be accessed in the subclasses of the class, but anything outside the package will not be able to access it because you see an N here. Then we have the default access modifier or no modifier. If you do not write anything in front of a class or a method or a variable, it gets the default access modifier privileges. And that privilege means that anybody within the same class will be able to access that default variable or a default component. Anybody within the package will also be able to access it. The subclasses of the class where the default component was declared, those subclasses will not be able to access it. And anybody outside the package will obviously not be able to access it. Then comes the last one, which is the most restricted privilege, which is called private. So if you put private in front of a class or in front of a method or in front of a variable, that component will only be accessible within the class where it was declared. It will not be accessible in the package. It will not be accessible in the subclasses and definitely not be accessible to anybody outside the package. So private is the least privileged or least access permission level you have in Java. Once you write private in front of any component, that only the classes, other variables, the same class in which you declare this particular private variable, only that class itself will be able to access it and nobody else will be able to access it. And as you move above, the accesses become more and more lenient. You can see there's just one Y and 3 N here. The moment you move a bit above to the default modifier, you get 2 Ys. So everybody in the class and everybody in the package will be able to access that particular component. For the rest of the other world, it is still a no. When you write something as protected, then everything in the class, everything in the package, and everything in the subclasses will also be able to access it. Rest of the world cannot access it. And if you write something as public, then anybody can access it. It's like Y everywhere. So that is how the access levels work. Now let us understand this with the help of example. So I will go here and I've just written a very simple dummy class here, which is a class called test. And I have a method here, which is a display method. So very simple class, nothing fancy here. And if you notice, I have not put any kind of public, private, or protected modifier in front of the class. So this will get the default privilege. If something has default privilege, then the whole world will not be able to access it. So let's go to a different package. Let's go to this package, which is here. And let's try to access this particular test class. So we will try to access this test.java here in the main class. So let's try to do that. Let's say test t equal to new test. I'm just initializing the same class. So what do I get? I get a compile error. Let me try to fix it if I can. And I cannot fix it. If you see, I'm just trying to use this particular test class into a different package but that package is not able to see the class at all. I'm getting a compilation error, and if I try to click on the error, generally Eclipse provide me suggestions to to import this particular class. But Eclipse is not able to find any class with the name of test, which can be imported in this package, which is a different package than the one of the test class. So we cannot access it because it's in the default access. Now let's go back to the test class and let's make it public. So I've just made it public here. And now if I click on this again, I get the suggestion. If you see, this suggestion was not there earlier. Now it says import test. And if I click on this, double click, it gets imported and everything is happy. So you can see the whole access modifier in effect here, the default versus public. You can also try the other kind of access modifiers. Let's try private as well. I think private will also have the same effect because it will still not be accessible from the package or from the subclass or from the whole world. We already saw this particular in effect, but we'll see the private in a different way now. So going back to the test class, I've made the class as public, but the method here is default. I've not exposed this method to be used outside the class. Let's see what happens if I try to call this display method from the main class. So I have successfully initialized the class, and if I say t dot, and if I look at the suggestions here, I do not get the suggestion of the display method. Why? Because it is default. If I go back, make it private, can I now access it? Let's try again. Nope, still we can't access it. Eclipse is not even able to find it inside this package because it is private. Let's go back and make it public. So I've made it just public now. Going back to the main class and again saying t dot, now I get the display suggestion as the first suggested method here. And now I am able to use the display method once I have made it public. So you see, the moment you change the access modifiers, the changes are propagated immediately. And you can see the public versus default versus private in play here. We can even go into further detail by using the protected, but for protected, I have to explain the concept of subclasses. So I will cover this protected versus subclasses concept when I talk about inheritance, and there we will see the usage of protected variables and the protected access modifier. But we saw the usage of public, the default modifier, and the private modifier. Do check out the documentation for these access modifiers, and I would strongly suggest you to play around with this, get more comfortable with this concept of different kind of modifiers. Let's also run an example for understanding the default modifier in a better sense, because we can see that for the package, it says while, right? So let's go back to Eclipse, and within the same package where we created test class, let's create another class. Let's call it test demo. So I will just click finish. I get a new class. Let me also write the public static void main method here. So I get the public static void main method here, and let's try to access the test class here within the same package. So let me again go back to the default privilege here. So I put the test class access as the default class or default access, and same goes for display. So can other classes in the same package access the test class now? Let's see that. If I go to test demo, and here, if I try to get the test class initialize, does it work or does it give me a compilation error? Yes, it works. It works because the test class and the test demo are in the same package, and test class has the default access privilege. So let's try to run one more variation of it to understand the usage of the private method better. Going back to the test class, this display method has the default privilege right now. So going by that logic, if I say t dot, I should be able to get access to the display method. And yes, that is possible. If I run this particular program, I will be able to get whatever is given out by the display method, which is hello world. Now let's try to make this particular method as private. And let's try to access this method from one of the other class in the same package as of the test class. So the class is default, the method is private. And if you see, this class has already turned red. There is a compilation error because now the display method is not accessible to the test demo class. Even if it was in the same package, it's not accessible because the display method's privilege or access modifier has gone to private now. Exactly the same as explained here. Because it has become private, so the package level members cannot access it. There's an N here. So this was another variation to show you how you can use public, protected, and private together to only expose the members, methods, and classes which are supposed to be exposed to the consumer. This is a very critical and very important concept to be used in Java, and it is used from a very simple program to all the highly complex application. This is sort of the bare bone or the laying foundation for any kind of basic security level premise which you need to build in an application. So that's all I want to cover in today's session, where we discussed about the different access levels. In the next session, we are going to talk about the concept of inheritance. Let's get started with inheritance. So inheritance is basically one of the most important properties of any object-oriented programming language. It's basically a concept, and the concept says that what if you have a scenario where you want multiple classes to share similar behavior and similar properties. Let's understand this with the help of an example. Let's take the example of a bank. When you go to a bank to open an account, there are multiple types of accounts. There can be a savings account. It can be a type of current account. There can also be a different offering for personal account and commercial accounts, such as for businesses. Then you may also have loan accounts, which are having different kind of properties. So all of these types of accounts are still technically accounts, and they will share some similar properties. For example, all of them will have to maintain some sort of an interest rate. For example, all of them will be used to either deposit money or withdraw money. So there would be some kind of similarity across all of these types of account classes. But at the same time, there will also be some sort of differentiality amongst these classes. The way you will calculate the interest rate for a current account will be different from the way you will calculate the interest rate for a savings account. And the same applies for commercial account, personal account, loan account, etc. So you see that we have some common behavior, but at the same time, we also have some different behavior. So whenever you have such scenario, always think about applying the concept of inheritance in your application. There's another simple way to spot whether inheritance can be used at a particular place or not. Inheritance is also called is a relationship. So whenever you read the requirements from a customer, just try to find the words which use this particular phrase is a. For example, car is a vehicle. Savings account is a type of account. Similarly, you will find many other types of similar examples. So whenever you will see that is a relationship between two different kinds of objects or two different kind of entities, that means that there might be an inheritance relationship being applied between them. And that's how you will spot the usage of inheritance. So far we have understood this concept that there would be some sort of relationship between the two classes. What will be this relationship? The relationship will be of parent-child type. There will be a parent class. Some people also call that as base class. And then there will be a child class. So the child class will be inheriting the properties and the behaviors from the base class or from the parent class. I will be using base class and parent class terms interchangeably during this session. But the basic idea and basic premise is like that only, that there will be a child class and there will be a parent class. And the child class is extending from the parents class. Remember the word extend because we are going to use that. And I've just shown you the what you see here is basically the official definition which is given by Java docs here. You can read the definition as well. And the basic idea which I told you lies in the parent and child relationship. And this is how you can conceptualize it, that you will have a base class or a parent class, and then you can have multiple children of it. And then those children can again have their own children and so on and so forth. So this hierarchy, this whole inheritance hierarchy can go as deep as you want it to be. And that's the basic idea and basic conceptualization of how you understand and how you visualize inheritance. Now let's move to Eclipse IDE and try to understand this with the help of an example. So for this particular case, I have created a set of classes basically, which we will be using to demonstrate the relationship of inheritance. And I've taken the simple example of a bicycle. So a bicycle is again a very generic definition of any two-wheeler, and bicycles can have multiple types. There can be an all-terrain bike, there can be a mountain bike, there can be a city bike, there can be a bike which is specifically made for ladies, and similarly there can be multiple different types of bikes. But all of these bikes will have some similar properties. For example, all of them will have two wheels. All of them will have a seat. all of them will have brake, all of them will have some sort of a speeding mechanism, whether they can accelerate or deaccelerate. So there will be some commonality, but at the same time, a mountain bike's features might be very different from a city bike feature. A mountain bike mountain bike might have gears, for example, whereas a city bike might not have gears, because you don't need that much of a variation in inclination and declination when you drive down the road. So I'm trying to conceptualize the same example here, where I've created a class called bicycle, and this is my base class. I define two properties in the bicycle class, which is gear and speed. We will come back to protected in a while, but let's leave that there. So I have two properties, which is gear and speed. I have a constructor where I'm initializing the starting speed and the starting gear. And then I have three methods here, which says set gear, apply brake, and speed up. When I apply brake, the speed is going to get reduced. So that's why you see minus equal to unary operator. And when I'm trying to speed up, the speed is going to increase. That's why I'm using the plus equal to unary operator. So when you use the method speed up, the speed is going to be increased by the value you supply in the method. Similarly, when you apply the brake, the speed is going to get reduced by the amount you supply in the method argument. And that is my base class: bicycle, gear, speed, and three methods. Now let's have a look at the child class. So the way you will define the inheritance relationship in Java is by using this extends keyword. Remember, I told you to remember the extends keyword. So what you will do, that you will write your class name as usual, and then you will use extends keyword, and then you will use the parent class name or the base class name. So here I'm saying class mountain bike extends bicycle. And here I'm providing an additional property. Remember the whole commonality versus differentiality equation. So a mountain bike might have an extra property to adjust the seat height. So that's the extra property which mountain bike is having. And then, since this mountain bike is extending the bicycle class, this mountain bike class has the responsibility to initialize the bicycle class as well. And the way it will fulfill that responsibility is by taking all the arguments of bicycle class plus the mountain bike class in its constructor. And that's why you see three different properties here. You see the start height property, which is the property of this particular class, which is the seat height. And then you see the start speed and start gear property, which directly are not available in this class, but this class is inheriting those properties from the base class. Remember the keyword inheritance here. And then once you do that, how do you initialize the base class constructor? Is by calling the super method. This is again a keyword in Java, and you will use this super keyword to refer to the base class constructor in this way. So what you will do technically is that you will write super and you will supply the arguments which is required by the base class constructor. If I go back, the base class constructor requires two arguments, start speed and start gear. So I write super and then I write start speed and start gear. So whatever I got from here in the constructor of mountain bike, I'm supplying those values as is to super. And Java will automatically take care of invoking this particular constructor the moment it encounters this kind of statement. Another thing to notice is that the super keyword or super statement has to be the first statement inside your constructor. Remember that whenever you are dealing with inheritance and whenever you have to initialize the super class constructor or the base class constructor, use the super constructor invocation as the very first statement inside your child class constructor. Otherwise, Java will not compile the program. And then you will initialize the local variable. I should call this as this. Remember, we discussed about this in the classes session. Okay, and then it just has a method of set height. So there's no extra method which this mountain bike is providing, but this mountain bike will have access to all the methods which have been provided here and all the properties which have been provided here. This mountain bike can access everything from the bicycle class. And that's the whole idea of inheritance, that the child class can access the properties of the base class by extending the base class. Now let's look at how do we invoke this particular class. So for that, I have a simple class name as inheritance demo, which has a public static void main method. And then I am initializing the mountain bike class. I'm supplying three values as 20, 10, and 1. So the 20 goes to start height, the 10 here goes to start speed, and 1 here goes to gear or the start gear. And that's how I'm setting the values. So when I call this particular constructor here, the mountain bike constructor is going to, mountain bike constructor is going to get called, and which in turn is going to call the base class bicycle class constructor as well, and everything will be set accordingly. And then let's try to access the gear property. Remember, gear is not directly available in the mountain bike class, but I'm still able to do mountain bike.gear because child class can access the parents class properties. Similarly, the same thing goes for speed as well. And seat height is the local property of this particular class, mountain bike, so it will anyways be accessible. So I can access all the properties of the base class and the child class itself seamlessly without any differentiation. Now let's try to call a method. So here I'm calling the method apply break. Remember, apply break was defined in the base class, not in the child class. It's defined here. So I'm calling the apply break method, and I want to reduce the speed, the current speed by 1. And then I'm printing the current speed, saying that bike speed after applying break is mountain bike.speed. So let's run this particular program and observe the outputs. Okay, so the first statement which gets printed is at line number 7, which says gear is 1 because it's coming from here. Then the seat height is mountain bike.seat height, which is 20, which is the first argument here. And then the bike speed is 10, which is coming as here and getting printed here. And then when I apply the break, let's go back to the apply break method. The logic is that whatever is the current speed, reduce it by the value I supply in the method. So if I supply 1, 10 minus 1 becomes 9, and that becomes the current speed. If I supply 5 here, the current speed will be 10 minus 5 equal to 5. Let's assert that particular assumption as well. Yes, we can see that. And similarly, you can access other methods of the base class as well. If I just do control space here, and you can see apply break is accessible, set gear, set height, speed up, all the methods which are defined in the base class are accessible in the child class as well. This is the power of inheritance. One more thing which I said I will come back to is around the usage of protected access modifier. Remember when we discussed about the access modifiers in the previous session, I said that protected is used when you are dealing with inheritance, that whenever you define something as protected, it will be available to be accessible in the child classes of the base class. So if I define this particular variable as protected, then this particular property will be accessible in the child class mountain bike as well. Let's play around this. Let's make this as private and see what happens. So if I make this private, now when I say private, the scope of this particular variable is within the class only, and nobody outside the class will be able to see it. And you can see the effect of it. I can see an error being coming here in my inheritance demo class because now mountain bike object cannot access the gear property because the gear property is defined in the base class and now it is private. That's why the child class now, mountain bike class, cannot access the property gear. And the moment you make it back to protected, it will be accessible. The error is gone. There's no red line here. So that's how you can use the protected access modifiers. It is always recommended to use them when you write any kind of inheritance logic. And in inheritance logic as well, intentionally, if you want to hide a particular property from the child classes, just make it private. And that's all I want to cover in this particular session, where we dive deep into the concept of inheritance. We had a look at an example using the bicycle and mountain bike kind of construct, and you can apply the same kind of construct on any kind of other kind of business requirement. Remember, the is a relationship. So that's all I want to cover in this particular session. And in the next session, we are going to talk about another very interesting concept of Java, which is about encapsulation. Let's get started with encapsulation. So again, let's understand what is encapsulation in general, and then we will apply that concept to Java. Encapsulation, if you try to break that word, if I just write it here in the form of a comment, it's encapsulation. Just trying to break this word into to make it more visual. So you see a word called capsule here. So if you try to imagine a capsule, Why do you create that, and what's the concept of a capsule? Capsule tries to pack a lot of things inside a small tube-like shape. And the concept of encapsulation is sort of inspired from that. Not exactly, not literally, but that's the basic idea of this root word, which is called encapsulation. So encapsulation basically means to restrict accessing the properties of a class to the outside world. If you want to protect the properties of your class, how do you do that? You do that with the help of the concept called encapsulation. So here, this is a sort of a security feature. You can think of it as a security feature that you want to protect the properties of your class, and you will use encapsulation to protect the properties. How you implement encapsulation? Let's have a look at that now. So basic idea is to encapsulate the objects, create sort of a capsule around the object, which can provide that protection layer. And you will define how the outside world is going to access the properties of the class if needed. So I've created a simple class here, and it's if you remember one of the previous examples when we discussed about classes, I used the same class, which was the student class, and I'm just using the same class for continuity. So I've created a student class here, and I have created 3 different properties of this particular class, which is name of the student, age of the student, and address of the student. You see, intentionally, I have used the keyword private in front of these 3 properties. And that is the first thing which you need to do to implement encapsulation on your object, that you hide all the properties from the outside world. Remember, the moment you make anything as private, only the class, which is the student class itself, only the class itself can see these variables or these properties. Nothing outside the student class will be able to access the name or age or the address directly from the student class. It's not possible. That's the whole idea of making it private, because you don't want the outside world to access these properties. So you make those properties as private. Then you create a constructor. The constructor has to be public so that anybody can initialize the student object, because you want your object to be accessible. Remember, so you want the objects to be accessible, but you want the restriction on the access of the properties of the object. And these are the properties of the object. So you have restricted them by making it private, but that doesn't solve the problem, because there will be some illegitimate consumers of the student object which should not have access to the student properties, but there will also be some legitimate consumers of the student object which should be having access to the properties of the student. For example, the payroll application will need access to these particular properties. The examination application will require access to these particular properties. So how do you do that? You create getters. We call them getters because they start with the keyword get. So you create a getter method for each of the property. You create the method called as get name, and this is the naming convention which Java promotes, that you write get and then you write the name of the property in camel case. So you write get name, and this property is supposed to return the name property of this particular object. And here you say return name. So you're returning the name which is being stored by the current student object whenever somebody calls student object dot get name. And this is the way you have restricted the access of this particular object as well. So remember, you made it private so that nobody can access it. And then you defined your own way of providing access to the name property of this particular class. Now, if anybody wants to access the name value of your student object, there's only one way to do that, which is via calling get name. So you have provided restrictions, and you have also provided prescriptive guidance on how you are going to expose the properties of your class. That's the second thing which you need to do to implement correct form of encapsulation on your object. That is to provide the getter methods with the right visibility. You want to make them public so that anybody can call them, but since you are governing what is written inside the method, you have full control on what kind of exposure you want to give for this particular property. Similarly, you create a getter for age, calling getAge, which returns the age. and then you call you write get address and return the address. Here it is simply returning it, but if you want to do more stuff here, feel free to do that. Like I said, you govern the control of how do you want to return the name. Maybe you don't want to return the complete name and you want to just return the initials. Then you can split the string, trim the string, and return only the initials. So that's the basic idea of getters. Now, after you have created the object, there might be use cases where somebody needs to overwrite the values of the properties like name, age, or address. What if a student's name was incorrectly mentioned when they called the constructor and now they want to overwrite the name or fix the name? So basically they have to replace the existing value of the name with a new name. So in that case, you need to provide what we call as setters, and they start with set. That's why we call them setters. And we follow the same kind of logic that you provide the setters for all the properties of your class. So you had three properties, which were name, age, and address, and you provided the setters for all three of them. And how do you provide that? You again make them as public because you want the outside world to access this setter method to override the values of the name. This method is not going to return anything, so it is going to be void. Then you write the name of the method, which starts with set, and then the property name in camel case. And then you provide the new value, which is the value which should be the new value, and this is the value which should replace the existing value. So whatever new value you want to supply, you supply that as the argument of the setter methods for set name, for set age, or for set address. And then you write this particular line, which says set the current name property of this particular object with the name which is coming in from the argument. So this dot name, remember, this dot name represents the current object's property because this represents the current object. So whatever is the current object property value of the name is, just override that value with the argument coming in. Do the same thing for age in set age method, and do the same thing for set address in the set address method. So this is how you are going to provide the setters and the getters. So setters and getters can also be generated in smart IDEs like Eclipse. So you just right click, you go to source, and here you will see the option of generate getters and setters. If you click on this, it will give you the list of the fields which are available to be having getters and setters. Currently, it says no fields or all fields have getters and setters already. Yes, because they have it. Let me just comment this and show this how this works. So for example, let me comment all the getters and setters. So I'm commenting them. And if I right click, source, generate getters and setters, I get all the fields available for which setters and getters can be generated. So you can select them and leave everything as default, hit generate. And it is automatically going to generate the getter and the setter. You see, all the code of the getter and setter is automatically generated. You do not even need to write it. And this is the power of the smart IDEs. Let me just revert what I did. So you created everything as all the properties as private, and then you define how you want to replace the values by providing the setters, and you define how you want the outside world to access your properties. So you have full control of the class now. You control the visibility, you control how they are going to get initialized, you are controlling how the properties are going to be overwritten or set, and you control how the properties are going to be returned. So you have complete control of the class. So you have created a perfect capsule here, a perfect form of encapsulation in this class. And this is how you can implement encapsulation. And that's all I'm going to cover for this particular session. In the next session, we are going to discuss about abstraction. Let's get started with abstraction. Let's first understand the definition of abstraction before we relate this to Java. Abstraction generally means hiding something. When you want to hide some details of a particular object from the outside world, you apply the concept of abstraction. For example, when you drive a particular car, you just hit the accelerator and the car speeds up. Now, it's not only one action. When you hit the accelerator, the whole machinery of the car and all the components, different parts of the car work together to speed up. There would be engine, there would be propulsion, there would be fuel, there might be some, if it's an electric car, there would be batteries. there would be whole different kinds of pistons and plugs which will make the car speed up. It's not only a single component, it's a lot of different components under the hood. And that's the concept of abstraction, that we only show the relevant parts to the user and we hide all the internal details from the user. That's the basic idea of abstraction. So a car manufacturer abstracts away all the inner technical details from the driver and just gives the driver a single pedal to speed up the car. For a user, it's a very good experience because he doesn't need to know about all the internals of the car. But the car manufacturer can hide all the details and provide a very simple interface for the driver to interact with, which is just a gas pedal. And that's the basic idea of abstraction. And we try to apply the same kind of concept to Java in the form of abstraction. And Java provides this kind of concept implementation with the help of a keyword which is called abstract. Now, abstract is a keyword which can be used in front of a class or a method. When you use it in front of a class, the whole class becomes abstract. Abstract class is a type of class. So the class itself becomes an abstract class. One of the things to remember is that abstract class cannot be instantiated, but can be subclassed. Remember, we talked about the concept of subclass and the parent class when we talked about inheritance. So if you make a class as abstract class, you cannot call the constructor of the class because you cannot instantiate it, but you can extend the abstract class and create a child class out of it. That's the concept of abstract class. Another concept is abstract method. You can also use the abstract keyword in front of a method. And when you use abstract keyword in front of a method, then that method is only declared without an implementation. You are not going to provide any implementation of the method, and you're just going to declare the method. Something like this. We will see a similar example in the hands-on as well. But that's the basic idea, that you just declare the method. You are not providing an implementation as to what does move to method actually does, because that's the whole concept of abstraction. And it is the responsibility of the child classes which inherit the particular class in which the abstract method would be sitting. So the child class will be having the responsibility to provide a concrete implementation of the declared method. Let's understand this better with the help of an example. So here I have created a class called graphic object, and I have made the class as abstract class. This is the keyword which you need to use in front before the class keyword, and the class becomes an abstract class. Now, when you create an abstract class, it automatically gets some properties. The first property is that this particular class must have at least one abstract method. And this is how you define the abstract methods, where you just provide the declaration, but you do not provide the implementation of the draw method or the resize method. And the way you will create the abstract methods is by using the abstract keyword before the actual method declaration starts. So general method declaration would look like this. And if you use abstract in front of it, this becomes an abstract method declaration. Abstract class can also have concrete methods. So that is the liberty which abstract class gives you, that you can have abstract methods which are just declared, but you can also have normal methods which are where you can also provide the implementation. So you can have normal methods and abstract methods as well in an abstract class. So this is the abstract class. Now, if you want to provide an implementation of the draw and resize method, you have to extend this abstract class. So we extend this abstract class by creating two child classes out of this particular abstract class, which is circle.java, where you can see I create a normal class and I use the extends keyword for inheritance. And I'm saying that circle class is inheriting from the graphic object class, which was my abstract class. And once I use this extends keyword, then I have the responsibility of providing the implementation of the abstract methods. Actually, Java will force me to provide the implementation of these two methods. If I do not provide all the declared methods, so there are two declared methods here. So if the circle class does not provide the implementation for both draw and resize methods, then Java will throw an error and it will ask you to take an action, which can be either define all the methods, meaning provide implementation for all the methods, or make the circle class itself as abstract. Let's see, if I just comment this particular out, I get an error. You see a red line here. And if you click on this particular balloon here, it will say either you can add the unimplemented methods, or you can make the circle type as abstract. So these are the two options which you will get to fix this particular error. So an abstract class can be extended by another abstract class if the child abstract class is not implementing all the methods of the parent. If you want to implement all the methods, then just implement them and keep it as a normal class. And that's what I've done here. I've just created a normal class here and provided the implementation. And once you provide the implementation of both of the methods, the error is gone. Similarly, I've also provided another child class because there can be multiple children of a particular parent. So rectangle also extends from the graphic object, and it also provides its own implementation of drawing and resize. Because generally the way you will draw a rectangle and you resize a rectangle will be different than drawing or resizing a circle. Here I'm not doing anything in the methods because this is just to show you the demonstration. I'm just printing a sysout saying drawing a circle and resizing drawing a rectangle and resizing a rectangle, and in the circle class drawing a circle and resizing a circle. So one abstract class as the parent class, which is the graphic object, and two children, circle and rectangle, both providing the implementation of the abstract methods which were declared in the base class. Now let's go to the main class where I've defined the public static void main method. And here you see I have created two different kind of blocks of code here. One block is where I'm saying graphic object, creating a reference of the graphic object named as circle and initializing the circle object. Now you see a difference here. Here is the abstract class and here is the concrete class. So whatever you define on the right hand side, whatever is the type of object will be the type of methods being called. So if you created a circle object and then if you call the draw method and resize method, these methods will be called from the circle class. If you initialized it as new rectangle, then you are creating a rectangle class object, and then the draw and the resize method will be called from the rectangle class. That's the basic construct, and that's how you will initialize a particular class which is using an abstract class. So I call graphic object circle, new circle, and I call circle.draw and circle.resize. Similarly, graphic object rectangle equal to new rectangle and rectangle.draw, rectangle.resize. Let's run this program and observe the output. So when I call this particular block of code, circle object gets initialized, and then circle.draw method prints drawing a circle, and circle.resize method prints resizing a circle. Similarly, when I create the rectangle class object, referencing it with the graphic object class, rectangle.draw prints this particular line, drawing a rectangle, and rectangle.resize prints this particular line, which is resizing a rectangle. And this is how you will use the concept of abstraction. There's another very interesting thing which is going on here. Remember, I told you that the abstract classes cannot be instantiated. So if I go here and I try to create a constructor of the graphic object class, let's see what happens. If I do this and I just put a system out here, base abstract class. So if I do this here, if I still write a constructor, though Java says that it cannot be instantiated, if I still write a constructor of it and I do not do any changes here, and if I run this particular program, let's see what happens. You'll see the base abstract class being called here. Let me just reformat it by putting ln here so that we get a better output. So if I run this particular program, you see base abstract class is getting printed somehow, though we said that abstract classes cannot be instantiated, but still the constructor of this is still getting called somehow. When I create a circle class, the base class constructor gets called, and when I create a rectangle class, again the base class constructor gets called. This is the power of inheritance, because in inheritance, remember how it works. When you initialize a particular child object, referencing it with the parent object, see the reference is of the parent class and the object is of the child class. So whenever you do it like this, first the default constructor, because I'm calling the default constructor here, the default constructor of the circle class will get called, which will go here. Remember, I told you that Java provides the default constructor automatically if you don't provide it. So the default constructor of circle gets called, but Java sees that you are writing this code here, which says circle extends graphic object. So Java is automatically going to call the parent class and going to initialize the parent class as well, because that's how it will be able to see these methods. And so that's why it will automatically call the base class constructor even if you don't call it explicitly. In fact, you cannot call it explicitly. Java will not allow you to initialize the graphic object class explicitly. It can only and only be called by Java itself indirectly via the concept of inheritance. If you try to do this, let's try to do this for fun and also for better understanding. So if I write graphic object go equal to new graphic object, you see I don't even get an option, but let's write it and let's see what happens. So you see that this particular, it gives basically an error because it's not able to find the constructor of the graphic object class. Though even I have defined the default constructor here, but still Java is not able to find it because this class is abstract. So hence proved, abstract classes cannot be instantiated explicitly. They can only be instantiated by the child classes through the internal mechanisms of Java itself. And that's all I want to talk about in this particular session, where we looked in detail about the concept of abstraction. Couple of more things which I did not cover in the previous session. I just want to call them out for clarity. Java does not support multiple inheritance. When I say multiple inheritance, what it means that you will not have a scenario where a child will be extending from two base classes. Java does not support it. It does support it with the help of interfaces, but I will talk about interfaces in the coming sessions. But here, just understand this, that you cannot use multiple inheritance with classes in Java. A child cannot have two parent or two base classes in Java. Java will not allow that. It is also called the diamond problem because the child class does not know whether to follow the route of base 1 class or the base 2 class if it is extending from two different base 1 and base 2 classes. So a class can only extend from one class in Java. We can find a workaround of it by using the concept of interfaces, but that's something which will be coming later. Another thing to understand is that when you create an abstract class, here these variables, you can declare these variables as well, and these variables will be accessible by all the child classes as you access them. So that's all for this particular session. And in the next session, we are going to talk about interfaces. Let's get started with interfaces in Java. Now, again, let's understand what do we mean by an interface in general, and then we will see how do we apply the concept of interfaces in Java. So imagine, let's take the same example of vehicle industry because that's something which we see every day around ourselves and we can relate to it. So imagine if all the car manufacturers were creating a different way of driving a car. What if in one car you have a steering, but in other car you do not have a steering, but you have something else, which may be called something else. In one car you have the gas pedal to speed up. In other car you have a button to speed up. Similarly, in one car you may have different kind of doors, and in other car you may have different kind of doors, which are completely different looking. It's not even a single simple handle to open it. So you see the problem here. The problem here is that all the car manufacturers are not working on a single contract. They are not respecting a single interface, which will create a poor user experience because whenever the users have to buy a new car or they have to switch from one manufacturer to other manufacturer, they are completely clueless as to how to drive that particular class because the interface they were using in the previous car is completely different from the interface they are being shown in the other car. And that's the basic need for the concept of interface. Think of it as a contract agreement. You see, it is also mentioned here that if you apply the same kind of concept to programming world, imagine if every programmer was writing their own logic in their own way without following a single contract or a single guideline. Soon it is going to create a problem. And that's the kind of problem interfaces try to solve. So interface is again a keyword in Java, and the basic idea or the basic construct is that the interfaces are going to define the specifications of how a class would act. Let me repeat this in a more generic way. Interfaces are going to define the contract or the specification which is going to govern how an application or code or programming logic will behave. That's the basic idea of interfaces. So interfaces are their own type, and the basic property of interface is that it can only contain constants method declarations similar to abstract classes, and some default methods or static methods or nested types. What is nested type? We will cover that later. Default methods we'll touch upon a bit here, and the static methods as well. But the basic idea is that when you create an interface in Java, you cannot write anything concrete in terms of the behavior of the interface. When I say behavior, always think of that as method. So you cannot define a concrete method in an interface. You can only declare methods. You can also declare constants. You can create a particular type of concrete method by using the default keyword, but use it in very special circumstances. You can also create static methods as well, which are only going to belong to the interface and nobody else. Now let's look at an example. And also, before we go to the example, let me also phrase this here that if an interface cannot define a concrete implementation of the methods, then naturally the interface is going to be extended by a child class, a concrete class, which is going to provide the implementation of the methods declared in the interface. It does sound like abstract classes, but there is a difference. Let's understand the difference with the help of an example. This is how an interface will look like. I've used the same construct of bicycle and mountain bike just to maintain some continuity and less context switching. But this is how an interface will look like. You will not use the class keyword, but instead of that, you will use the interface keyword. You can only declare methods. You cannot define methods. Remember when we looked at the abstract classes example, we were able to define concrete methods as well. But in interface, that's a strict no-no. You cannot define concrete methods. Let me show you the abstract class in the case of abstraction which we used. This was the abstract class and it did have a concrete method, right? But bicycle.java here, which is because it's an interface, it is not going to allow you to create a concrete method. Another thing is that if you try to declare a variable inside the class, they will have to be constant. You cannot just declare them without any value. For example, I cannot do this. If I do this, it is going to give an error. You see an error here. And it says initialize field X at declaration, something like this, public static final. So interface is going to force you to declare all the variables as public static final with some value if you try to use them inside interface. So that is also something which interface will mandate. So you see interfaces are more strict. They are more strict in terms of what you can do. You can only declare public static final variables and you can only declare methods. You cannot define methods. So abstract class is less restrictive. Interface is more restrictive. And that is the differentiation which we have to keep in mind, whether to use abstract classes or whether to use interfaces. That is also a very common confusing question in the interviews as well. And remember that interfaces are only for contracts or specifications, where in case of abstract class, you can write a concrete behavior as well in terms of a concrete method in the base class. Interfaces, there's no concrete implementation in the base class. Abstract classes, yes, there can be a concrete implementation in the base class. That's the basic difference. Moving on, I have created a child class here, which is again mountain bike, and it has three properties: seat height, gear, and speed, similar to the previous example. It has a constructor, and remember, again, interfaces cannot be initialized directly, so you do not even need to call a super method here because there is nothing to initialize. You initialize a class to create a state. State is denoted by the properties, but interfaces will force you to write a public static final property and initialize its value automatically. So you do not need a constructor for the interface because there is nothing to initialize. Everything has been initialized in terms of the variables, and the methods are anywhere just declared. That's why you don't need to call super here. After that, the moment you write this particular keyword here, implements, and that is how you will basically extend from the interface. You will use the implements bicycle keyword here. Implements is the keyword and bicycle is the name of the interface. If you write this here, then Java is going to force you to provide the implementation of these two methods. If I do this implements bicycle and if I comment out these two methods, which is coming from the base class, it is going to give an error. And if I read out this error, it says either you add the unimplemented methods or you make the mountain bike class as abstract. There are two ways to fix this particular class. Similar to abstract classes, it will force you to write the implementation of the base class declared methods. Another thing which Java will suggest you and will also force you via some IDEs as well is that you use this particular annotation. We use this particular annotation to tell Java that we are overriding this method from the base class. Since apply break and speed up methods were defined here in the base class, and this child class is supposed to provide the implementation of the methods by overriding them. Overriding is again a concept which we will talk about in detail in the coming sessions. But for now, remember that you need to write this annotation here on the methods which have been taken from the base class to provide an implementation. And the implementation is similar to what we have seen before. So whatever value you supply in the apply break, the speed is going to get decremented by that particular value. And in case of speed up, whatever value you supply in the argument, that value is going to be added to the current speed, and the speed is going to go up. Let's look at the main class here, which is called interface demo. It has a public static void main method. And here I'm again initializing the child class. Nothing strange here. And then I'm using the getter method here because I have made everything as private here. And rest of the things are just here as is. I have the getters and setters here for all the properties, and I'm using those here. So I'm using the getters to just get the value of gear, seat height, and speed. And then I'm applying the brake, and then I'm printing the current speed after applying the brakes. Let me just expand this a bit more. And then I'm using the speed up method, trying to increase the current speed of the bike by 10, and then printing the new speed again. So using the apply brake and speed up methods, which are concretely defined in the child class by using this override annotation. And these were the methods which were declared in the interface, in the base interface. And that's all which is happening in this particular class. Let's run this particular program. And these are the values I get. I get the gear as 1, which is coming from here. I get the seat height as 20, which is coming from here. I get the current bike speed as 10. This was the value which it was initialized with. Then I'm applying the brake. And after applying the brake, the speed of the bike gets reduced and it becomes 10 minus 1, which becomes 9. And that's what gets printed here. And then I'm speeding up the bike by 10. So the current value of the speed of the bike is 9. And if I incremented it by 10, it becomes 19. And that's what gets printed here. And that's all I want to cover in this particular session, where we had a look at an example of how we can use interfaces in Java and how we can use interfaces with the concept of inheritance. And in the next session, we are going to have a look at the concept of multiple inheritance using interfaces. Let's get started with multiple inheritance in Java using interfaces. If you remember, in the previous sessions, I said that multiple inheritance is not possible in Java. And it is not possible because of the diamond problem. Or simply put, a one child cannot have two parent classes. That's what Java says. And let's understand why this is a problem. So I have created a very simplistic diagram to demonstrate the problem of multiple inheritance. And then we will see how we can solve that. So let's say you have a class C, a normal class. Then you created two parents of class C. So basically class C is extending class A, and you also want the class C to extend class B. First of all, it is not possible in Java, and why it is not possible is because of there can be a superclass which is extending class A and class B as well. So you started with class C, you wanted class C to have two parents, which is A and B, but A and B also had a common parent, which is superclass. So now, as you know that the child classes can see the properties of the base classes as well, then if class C wants to access something from superclass, which route should it take? Should it take this route or should it take this route? That is the problem which we called as the diamond problem. And that is the reason why Java prohibits using multiple inheritance using classes. So that's the problem statement, that we don't have a clear route to reach to the superclass from class C, and we try to solve it using interfaces. So let's jump right into the Eclipse IDE to understand how we can solve it. So here I have prepared an example for this particular problem and the solution of it. So again, I'm using the same bicycle and mountain bike example for the sake of continuity. I have created an interface of bicycle, which has two declarations, which is for applying brake and speed up. This is my simple interface. And then I have a mountain bike class, which is implementing the bicycle interface and providing the implementation of apply, brake, and speed up. This is something which you have already seen in the previous example. So nothing new here. And then you have other getters and setters, and you have a main class where you can initialize the mountain bike and get the gear, get the seat height, get the speed. We have covered all of this. There's nothing new here. But now let's say you have a requirement that you have another interface which is called vehicle, and your mountain bike should extend or implement this interface as well. Is that possible? Let's try that. Remember, mountain bike was already implementing bicycle interface. What if you want to have two parents of this mountain bike using interfaces? Like I said previously, that interfaces does solve the problem of multiple inheritance. So let's see if it does solve that problem. So I can just say vehicle here and see if the code compiles. The code doesn't compile here. And the reason is pretty expected. It's because vehicle has a declared method which is called can drive, and mountain bike now needs to provide the implementation of that particular method. So if you click on this balloon and hit on add unimplemented methods, just double click on that and you will get an empty method definition of that can drive method. And let's put a sys out for simplicity and say mountain bike can be driven. So this is how you can see this code is working fine. And now this particular child class has two parents. It has a bicycle parent and it also has a vehicle parent. So if bicycle and vehicle would have been concrete classes, then this would have caused an error. Let me quickly show you that if I can. So let me go to bicycle and I just change this to class and I put an empty definition for both of the methods. And then let's go to the vehicle class and convert interface and convert that into class as well. And again, provide an empty implementation. So I've just converted the vehicle interface and the bicycle interface into classes. And now if I go back to the mountain bike and if I change this to extends, I get a whole lot of errors. If I go here, it says multiple markers and it doesn't give you the right error, but the right error is happening because you cannot extend from two concrete classes. Now, bicycle and vehicle are both classes and mountain bike cannot do that because Java does not support multiple inheritance from classes. But if you go back to the previous state, if I just quickly do Control Z here and Control Z here in case of vehicle as well, converting both of them back to interfaces and putting the implements back here, everything goes fine. So using interfaces, you can implement multiple inheritance, but using classes, you cannot do that. Let's cover one more interesting scenario. What if you have a need to extend from, let's say, one interface and one more class? Is that possible? Because we saw the combination of two classes that was not possible. We are seeing the combination of two interfaces, which is possible. Now, is it possible to extend from a base class and implement an interface? Let's see what happens if we try to do that. And I have another class. This is not an interface, but this is a class called two-wheeler. So technically speaking, mountain bike is a two-wheeler. And at the same time, mountain bike is also a vehicle and mountain bike is also a bicycle. So what if you have a requirement that your mountain bike should also extend from two-wheeler class? Can you do that? Let's see if I can do that. I will just write extends two-wheeler and let's see if that works. It doesn't work here, but let's put it here. If I put it here, does it work now? Yes, it works. There's no compilation error here, which means Java does accept this particular construct. So what happened here? First thing, when I put this extends two-wheeler after implements, Java did not allow, which means that the extends keyword has to come right after the child class. It cannot come after the implements clause. It has to come right after the child class. That's first thing. Second thing is a normal class, a normal child class can extend from one concrete class and can also implement any number of interfaces. You see, I have two interfaces. So now technically this mountain bike has three parents. It has a concrete class two-wheeler as the parent. It has bicycle interface as the parent. And it also has vehicle interface as the parent. So three parents. So this basically justifies the philosophy or justifies the concept that a class can extend from only and only one base class, but can implement any number of interfaces. You can have more interfaces here, as many as you want. So number of interfaces is not a restriction, but number of concrete classes is a restriction. A child class will have only one concrete base class, but can have any number of interfaces being implemented from this particular class. That's the basic property. And then the main in the main method, you can access any of the vehicle or two-wheeler or bicycle interfaces methods and the classes methods as well if you want to. So for example, if I want to just type this, and if I just do dot here, I can access can drive as well. Now can drive was implemented in the vehicle interface or declared in the vehicle interface. Similarly, if I look for the two-wheeler method, can I see the two-wheeler method as well? Let's see if I can. Yes, and this you can see this is the two-wheeler class method which says can rotate two wheels. So I can call this particular method which is coming from the two-wheeler class. I can call the vehicle class declared method which was can drive. So this is also possible, and this is possible because mountain bike is implementing the interface of vehicle. So let's run this particular program and understand the output. So at first I initialize the mountain bike class and I print the gear, the seat height, and the bike speed values. You have already seen this. Then I apply the brake and I speed up. So after applying the brake, the speed becomes 10 minus 1, 9. And after speeding up, the new speed becomes 9 plus 10 as 19. Then I call mountain bike dot can rotate two wheels, which is going to invoke the method which is defined in the two-wheeler class, which is printing a simple sysout. So I get the same sysout here. This method is being invoked from the mountain bike object due to the concept of inheritance. Similarly, when I say mountain bike dot can drive, this can drive was declared in the interface vehicle, and then when mountain bike implemented this interface, Java forced it to provide a definition of this particular method, and this is a definition which is again a sysout, and you can see that sysout being printed here. So this is how you can implement multiple inheritance in Java using the power of interfaces, and you can also combine the classes and the interfaces. The condition is that only one class should be the parent class, and then you can have any number of interfaces as the parent entity if you want to. And that's all I want to cover in this particular session. In the next session, we are going to discuss about method overloading concepts in Java. Let's get started with polymorphism. So polymorphism is a very generic concept which means that a particular object can take multiple form. Let's not even call it as object. Let's make it more generic. A particular entity can take multiple forms. If any entity in Java exhibits that kind of behavior, then we say that polymorphism is in action. That entity can be a class or an object or even a method. And in today's session, we are going to talk about that type of polymorphism which is exhibited by methods. So we will see how a particular method in Java can take many different forms containing different logics, but still having the same name. And that concept is called method overloading. So whenever you hear the word that you need to overload a particular method or this is method overloading happening, technically or conceptually, it's basically polymorphism in action, and polymorphism is being applied on a method here. And that phenomena we call as method overloading. So in today's session, we are going to have a look at how we can implement method overloading in Java. So the basic idea of method overloading is that the name of the method should remain the same. So you see in this particular class, which I have created to demonstrate the method overloading. So this is the class name, and the method name, which I am going to overload, is called multiply. And that is probably the first thing which you need to remember to implement method overloading correctly, that the method name is going to remain the same. The type of the return of the method may change. Here you see it's returning int here in the first instance. In the second instance also it is returning int, but in the third instance it is returning double. So the return type of an overloaded method can change. Another thing which can be varied between same method being defined again and again is that the number of arguments and the type of arguments. The first multiply method takes two arguments of integer type, the second multiply method takes 3 arguments of integer type, and the third multiply method takes 2 arguments of double type. So by using method overloading, you can vary the number of arguments and also the type of arguments. So the basic idea is that you define the method using the same name, but you do a variation in the arguments or the return types. And that's how you technically implement method overloading. In this particular case, the multiply is the method being overloaded. And in the first case, it is accepting 2 integer arguments and returning the result of multiplication of those arguments. In the second case, the same method name multiply here, the same visibility public, and the same return type, but this time 3 different types of integer values can be accepted, and this method, multiply method, is going to return the multiplication of 3 integer numbers. In the third case, at line 15, I again use the same multiply name, the method name, but this time the return type becomes double, and this method accepts 2 double arguments and returns the result of the multiplication of these double values. So the method name is same, but the arguments vary, and also the return type may also vary. That's the basic premise of how you implement method overloading. So whenever you want to implement it, keep the method name same, vary the arguments and the return types. And after that, I'm just created a public static void main method here. I have initialized the class here, this particular class itself, method overloading demo. And then I am calling the multiply method on the object. And based on the number of arguments I supply, the corresponding method will get invoked. That is something which Java will take care automatically, that whatever type and the number of arguments you supply in the call, in the invocation, based on the number and the type of the arguments, Java will try to find a matching method in the overloaded methods. If it is able to find a method, it's going to get invoked. If it is not able to find the method, you will get an error. In fact, you will get a compile error itself while you invoke a method for which the definition is not available. For example, if I try to just copy this and make an invalid method invocation, let's provide 4 arguments. And if I do that here itself, I will get the error because Java is not able to find a multiply method in this particular class, which is accepting 4 integer arguments. So you will get the compilation error itself before you can even run the program. But the basic idea is that you use overloading with multiple different types and the number of variables. So I'm calling multiply 3 times. Let's run this particular program and observe the output. So let me just bring this output down. Yep. So first I call demo.multiply and pass 2 integer values, 10 and 20. When this happens, this particular method gets invoked and it returns a result of 10 into 20, which is 200. In the second invocation, I'm calling again the multiply method, but this time with 3 arguments. 3 integer arguments specifically. And this call is going to match this particular method signature, and it is going to execute whatever is written inside this particular method, which is the multiplication of the 3 arguments being supplied. So 10 into 20 into 30, which is 6,000. The third case, let's go back here at line 25. The third case of invocation of the multiply method is accepting 2 decimal based arguments, 10.5 and 20.5. So Java is going to look at the class and trying to find a method which can accept decimal values. And there it is. This is the method signature which is going to match the invocation. Java is going to do this matching automatically for you. And here, whatever logic you have written inside this particular method will get executed. So 10.5 into 20.5 returns 215.25, and that's the output you get. So this is how you can use method overloading in Java. This is a rather fairly simple example, but you can make it as complex as you want. But a word of caution, do not use it too extensively. In fact, a lot of expert programmers do not recommend using method overloading because it becomes very confusing. Use it only when you do not have any other way out. Use it only where this is the only way to write correct form of methods with the right readability. Otherwise, generally there would be other ways to avoid method overloading by writing concrete purpose-friendly method names themselves. Maybe you don't need to use the multiply name again and again. You can call it as multiply 2 numbers, multiply 3 numbers, multiply doubles, so that the method name itself is more explicit and understandable rather than juggling around different signatures of the same method. Especially it becomes more confusing if you are creating an interface which is to be consumed by a third-party developers or third-party application. So try to use it with caution. That's what I'm trying to stress here. And that's all I want to cover in this particular session. And in the next session, we are going to talk about method overriding. Let's get started with method overriding in Java. So in the previous session, we discussed about method overloading concept. Now, in this session, we'll focus on another interesting concept by which you can have the same signature of the method again and again be used in your code, but in a different way. And this concept is called method overriding. Method overriding basically is used together with the concept of inheritance. You will not be able to use the concept of method overriding without using the concept of inheritance. Remember when we talked about inheritance, I spoke about the subclass and the parent class concept. Sometimes we also call the parent class as superclass. So the basic idea is that if a superclass defines a method, remember I'm using the word define here. If the superclass uses defines a particular method, and then the subclass again tries to define the method with the exact same signature, this phenomena is called method overriding. Now, when you do method overriding, there are some rules to follow. And I'm showing you a tabular structure here, a table basically, which will show you what is possible and what is not possible when it comes to method overriding. So let's try to understand this table. So if you try to define a method with the same signature as a superclass method, the rules follow as per this table. Let's go with the first one. If you have an instance method defined in the superclass, instance method is the normal method which you define in your classes. So if you have defined an instance method in your superclass, and if you define a method in the subclass with the exact same signature, then that concept is called method overriding, and it will be a successful override. Override also, let me also explain what override means here. Override means that once you try to initialize the subclass object, you will be able to invoke its own overridden method definition. If you call that particular method, the subclass's own instance method is going to get invoked rather than the superclass's instance method. We'll look at that when we look at the example as well. But that's the normal scenario where your superclass defines an instance method and subclass also defines an instance method with the exact same method signature. That concept is called method overriding. What if your superclass defines a static method? Static method is basically a method which belongs to the class but not to the object. Instance method is called instance method. A normal method is called instance method because it belongs to the object. You can call the method on the object, but static methods are called by class. So you say class name dot static method name. But when you call instance methods, you just call object name dot instance method name. So that is the basic difference. The static methods belong to the class. Once you have defined a static method, the same static method will be available to all the objects of the class. But instance methods are unique to each object. So that was a short tour of what static methods mean. So if you define a static method in the superclass, and then if you try to define an instance method with the same signature in the subclass, you will get a compilation error. It will not be allowed. It's not allowed in Java to override a static method from superclass. That's what it says. Next one, if your superclass has a normal instance method and then the subclass tries to use the same signature but creates a static method out of it, then again you will get a compilation error. So the overriding of an instance method to a static method is not allowed. And the last concept is again a very interesting concept and a very popular interview question about method hiding. So if the superclass defines a static method and the subclass also defines the static method with the exact same signature, then the superclass's static method gets hidden. It basically hides the superclass method. So that's the basic idea behind method overriding. So if you see, technically, it's a form of polymorphism. because the same method is having multiple definitions. But when we looked at the previous example, the multiple definitions were in the same class. Here, the multiple definitions are in different classes, and those classes are having a parent-child relationship. That was about the theory of it. Let's go to an example of it to understand it better. And I've used again the same construct of bicycle and mountain bike, which we have been using in this series just to maintain continuity. So I have a parent class called bicycle here, which has two properties, gear and speed. It has a constructor, nothing unusual there. And then it has defined three methods: set gear, apply brake, and speed up. Set gear is just setting the new value as the gear value. Apply brake is going to decrement the speed by the value you supply, and speed up is going to increment the speed by the value you supply. Simple, this is exactly what we have seen before. Now, mountain bike tries to extend bicycle. So mountain bike becomes a child class. It defines a variable called seat height, defines a constructor called super here, nothing unusual so far. Also defines a setter for height, setter for the seat height, not exactly following the setter construct, but this is just to set the height. But here things get interesting. Let me just bring this down a bit. Yeah. So here it is overriding all the three methods of the base class. And by overriding, it is providing its own implementation of the same methods. Let's compare them. Here, when it overrides the gear and whatever value you supply, it adds 2 to the plus 2 to that value and then sets that value as the gear value. But in case of base class, it was just setting the new value as the gear value. So for instance, if you supplied 1 here, the gear value becomes 1. But here, if you supplied 1, the gear value becomes 3. Similarly, when you apply brake on the mountain bike class, whatever value you supply will be subtracted from the current speed, and 10 would be subtracted even more. So if the speed is, let's say, 50, and you supply the decrement value as 10, so it will be 50 minus 10 equal to 30. But in case of bicycle, if the speed was 50 and you supply 10, then it would be just 50 minus 10, 40. So there is extra 10 being subtracted from the speed when you apply brake in case of a mountain bike. Similarly, for speed up, it's increment of 10 in addition to what value you supply. So again, if the speed was 10 and you supplied 10 here in the argument, so 10 plus 10 plus 10, 30 will become the new speed in case of mountain bike. But in case of bicycle, if you supply 10 and if the current speed was also 10, then it becomes 10 plus 10 only 20. So that's the difference. So the basic idea, I hope you get the basic idea here, is that you override the methods and your own class provides its own implementation of those methods. That's the basic premise of method overriding. All good so far, and you do not have an obligation to override all of the methods, because here we have the concrete implementation of the methods. So here, in case of mountain bike, you can skip overriding one of the methods if you like to. This is also fine. There will be no compilation error because speed up has a concrete implementation in the bicycle class as well. So it's up to you how much you want to override. So let's move to the main class now. So in the main class, we have created the public static void main method here, and let's look at what is happening inside the class. First, we initialize the bicycle class. So bicycle class reference and bicycle class object. Nothing unusual here. We supply the gear value and the speed value. Then we print the gear and the speed value. We apply brake on the bicycle, and then we observe the new speed of the bicycle after applying the brakes. Let me comment out the rest of the code, and let's observe the output for only this part of the code, which we just walked through for this section. So if I run this as a Java application, and if I show you what I'm getting here. So bicycle gear is 1, which is what you supplied in the constructor. Bicycle speed is 10, which is again what you supplied in the constructor. Then you applied brake, and when you apply brake, this logic gets executed, and you supplied 1 here. So current speed was 10, so 10 minus 1 becomes 9, and the new speed becomes 9, which is what you are printing here. So far, so good. Let's move on to the next section. Let me comment out the previous section now, and let me uncomment this section. So here I have a bicycle reference, but the object is of mountain bike. Remember this concept. This is called dynamic object binding concept or dynamic binding concept. Again, this might be asked in your interviews. So here I'm initializing the mountain bike with a reference of bicycle. Remember, whatever is written on the right hand side will govern the variables and the methods usage. We'll see how that works out, what I just said. So I'm supplying three values here, 50, 50, and 3 in the mountain bike. If I go here in the mountain bike constructor, so the start height, start speed, and gear are the three values which is supplied as 50, 50, and 3. Then I'm accessing the gear and the speed. Now remember, gear and speed are declared in the bicycle class, but they are accessible in the child class due to the inheritance phenomena, which we have already covered. So if I print only this part, I should get the expected values. Mountain bike gear is 3, which is what I have supplied here, and mountain bike speed is 50, which is what I have supplied here. Then I apply the brakes. Now let's move on to this section. I apply the brake, supply the value as 1, and then I want to see what would be the new speed after applying the brakes. So let's see what happens when we run this particular code. So if I run this code, after applying the brakes, the speed becomes 39. Before applying the brakes, the speed was 50. So what happened here is 50 minus 1. Basically, this logic is getting executed here. 50 minus 1 minus 10, which becomes 39. That's why you get the value as 39 as the new speed. Similarly, if you want to call another method as speed up method was also defined here, where I'm saying speed plus the argument supplied plus 10. So the current speed is 39 right now. Then I'm speeding it up by 10. So by this logic, 39 plus 10 plus 10, which will become 59. And then I'm printing the new speed after speeding up. So let's see what happens. So if I go to run as Java application, and if I observe all the outputs, the speed was 50 initially. After applying the brakes, the speed became 39. And after speeding up, the speed became 59. So this was a quick demo to show you the power of method overriding and how you can override the behavior which is defined in the base class. So this is all I want to cover in this particular session. Let's get started with the static keyword in Java. Now let's first understand the need of the static keyword, and then we'll talk about how Java implements the static keyword. Imagine a scenario. Let's take the example of a class which we have been using in our different tutorials in this particular series, which is about the student class. So if you are building a college management system, you have a student class there, and if you have an entry, a property in the student class which is storing the name of the college, then the name of the college is going to be the same for all of the students of that particular college. It's not going to change. Another example, let's say you are building a employee management system for an organization, and you want to maintain the employee numbers. For the first object, the employee number should be 1. For the second object, the employee number should be 2. For the third object, the employee number should be 3, so on and so forth. So when you initialize all the employee objects, the last employee object has the final total employee count. And you can also treat this employee count as, let's say, the employee number as the employee ID. So starting from the first employee to the last employee, the employee number is the employee ID, which is a way to uniquely identify an employee. So we talked about two different cases. In the first case, we had a particular value which was same for all of the objects, which was the student and the college relationship. And then in the second example, which I quoted, where all the employees objects have to share a particular property amongst them, because if the second object did not know the previous value of the employee number, it will not be able to get to the new number. It needs to know what was the previous value so that it can do +1. So each of the object needs to know the state of the previous object. Two different cases, two different scenarios, one single solution, which is static keyword. So the static keywords are used for those members which belong to the class. Now apply this definition to the examples which I gave you. If I make a member of the student class, let's say the college is the property of the student class, and if I make that property as static, now that static member becomes the property of the class and not the property of the object. It means it belongs to the class. It also means that all of the objects will get the same copy of this static member variable. And that's one of the first usage. And you can make any property or any member of the class as static, by just putting the static keyword in front of it. We also call the static member variables as class variables like I just described. So use it for the cases where the value across the different objects doesn't change. You can make those class variables and those variables as class variables or static variables. Similarly, also try to identify the cases where a particular value has to be shared in terms of knowing the previous state. In those cases as well, you can use a particular member in that particular class and make that static. For example, in this case, we have a bicycle class and we have a static variable which says number of bicycles. So every time you initialize the bicycle object, this number will be shared. And you can see, this is here, it is incrementing the number of bicycles. So every time you create the object, the ID becomes +1 to the previous count of the number of bicycles. Exactly same example as I gave you for the employee number. So every time you create an object, you do a +1 to the previous value. Next object will take the previous value +1 and so on and so forth. So you can use the static keyword in front of a property of the class and make it a class level variable, which will be tied to the class and not tied to the objects. You can also make the methods as static as well. And the same kind of rule will apply on the methods as well, that the methods will belong to the class instead of belonging to the objects. Let's say you have again a common functionality which you want to share amongst objects. Just make that common functionality as a static method, and that would be shared amongst the objects. For example, you want to get the total number of bicycles for the previous example, which I just shared in this particular doc here. So you can just create that method as static, and any object which will call this method will get the latest count of the number of bicycles. You can also make these static variables as constants by putting the final modifier in front of it. So if a variable in a particular class is static and final both, then technically it becomes a constant. So these are some of the interesting use cases and constraints of the static methods and static variables. There's also a thing called static block, which is just a code block which you can write inside your class. And we will have a look at that example as well. So let's shift to the IDE and let's have a look at how we can use this static keyword. So I have used again the same class which I have been using in other examples, which is student.java. And you can see I have this same class. You would have seen these properties earlier as well. And the code below is exactly the same, just setters and getters and constructors. And it has an additional property, which is college. And the college name XYZ is the same for all the students. So I have just hard coded it. But you see, what is happening here is that every time you create a student object, this variable gets initialized. Even though the variable for all the objects has the same value, still it gets initialized again and again and again. So technically, it's a waste of memory. You're just wasting memory of a new allocation every time, even though the value is same. What if we create this object once and this member variable once and just use it across objects? You can do that by just writing static in front of it. If you do that, then you see this becomes sort of italic here, and that's Java's convention to show that this particular variable is a static variable. You can also see the static keyword in front of it. And then whatever value you have specified, this will be initialized only when the class is loaded. Remember, I'm not talking about the object initialization. I'm talking about the loading of the class in the JVM. So the first time the class is loaded, this particular variable will be initialized, and that's it. After that, no matter how many student objects you create, the same college reference will be used again and again, and the college variable will not be initialized again. It will be initialized once, and the same college reference will be used again and again. That's the power of static variables. For example, if I want to access this particular college variable, how do I do that? So let's look at a main class where I have initialized this particular student class with an object named as John. And I've specified the name, the age, and the address, and I'm printing those values. How do I access this static variable? If I say John dot, do I get access to the college variable? Yes, I do have access to it, but does it work? Let's see. You see a yellow line here, and we will come to that yellow line in a while. But let's first see if this works. Yes, it works. I can see that the college name is printed here as XYZ, which I have set. Now let's look at the error or the warning. It says the static field student.college should be accessed in a static way, because the way you are accessing it right now is the instance way of accessing a particular member. This is not a static way of accessing a member. So if you want to access a static member of a class, you should access it with the class name and not the object name. Why? Going back to my original definition that the static variables belong to class. They do not belong to object. And that's why Java will warn you if you are not accessing the static variables via the class, because they are supposed to be accessible via class. It will not give you a compilation error, but if you're working in an enterprise project, this is going to raise a lot of violations and a lot of questions for you as to why you are not accessing it via the class name. So this is the correct way of accessing it, and you will get the same output. Now, no matter how many objects you create of the student class, you can always access the student.college and you can always get the same value of the college name. That's the first use case. Second thing is about static methods. So you will use the static methods in a case where I described about the counting the employee numbers. And let's say if we have the same kind of scenario where you have to count the number of students, because you can use that particular count as, let's say, the roll number of the student. So if you have that kind of requirement, then you need to create a static method because you need to share the state of the object across objects. Remember that. So what you can do simply is create a static method. So let's say I create a normal method and then I just put static in front of it, saying static void student count. And now I want to count the student. So let's create a simple count variable and let's start it with 0. And then I can increment the count variable again and again in the static method, right? But you see, I get an error here. The error is if you go to the balloon, it says cannot make a static reference to a non-static field count. This is one of the properties of the static methods. The moment you make a method as static, then that particular method can only access the static member variables of the class. The static methods will not be able to access the non-static variables. Count is a non-static variable. Count is a normal instance variable. So a normal instance variable, for that matter, name or age or address, nothing would be accessible here. If I try to access, let's say I try to access name here. So if I just say sysout and I say name, it will also give me the same kind of error. If I go here, it gives me the exact same error because static method cannot access the non-static member variables of the class. So you have to make this count variable as static as well. And then only this compilation error will be fixed. I can remove this one. And now this method is fine. Now I can increment the count every time that object is created. And that is one of the use case of using the static method, that you can share the state across the different objects. And if you want to fetch this particular variable, then you can simply write a getter for this, saying int count, return count. And then you can return the count. You can see that now an instance method can access the static member. So the reverse is fine. A non-static method can access a static variable, but a static method cannot access a non-static variable. Remember that a static method can not access a non-static variable, but a non-static method can very well access anything, including the static variable. That's second thing. The third concept is of static block. And static block also has a similar usage, that if you have a block of code, it's not just a variable, it's not just a method, but you have a block of logic which you want to execute only once when the class is loaded into the runtime. If that is your requirement, then you can write a static block. And the way you will write it, generally we write it at the beginning of the class. And the way you will write it is as you write static and you put curly braces and you start writing code here as to whatever. You can say initializer and you can write whatever code you want to write. The only caveat is that in the static block, you will only be able to access only the static member variables of the class. So you will not be able to access these variables. You can only access these two variables. You can very well move these two variables here if you want to. So if I go here, I can paste this and I can drop the static keyword because everything in the static block is automatically static. So I don't need to explicitly call out static variable. And now this code is fine. You get some warning because it's not used anywhere in the class, but that's fine because this is just a simple demo. But the whole point is that you can write the static block and you can write all the initializer code which you want to write here. which you only want to execute once during the whole execution of your program. Just to show you the reason and the way it works, let's try to see if the static block works. And let me comment all the static code which I wrote here. And let's go back to the static demo and let me remove this one as well. So now I just will run this student.java. I will create an object of student.java and I will see if the static block gets executed or not. So let's run this particular class, which is the main class, and I have a main method. I have a student object initialized and I'm printing the name, age, and address. If I run this, you see the first line of code which gets printed in the output console is the static block code, which is what I wrote here. And let me do one more thing just for fun's sake. Let me create more objects of it. Let me just call them 1, 2, 3, and 4. And let's see how many times the initializer code gets printed. You see that the code still gets printed only once, even when I created 5 different objects of the student class. And that's the property of the static block, that it will be executed only once when the program is loaded into the runtime. And that's all. And that's pretty much all what I want to cover in this particular session. Let's get started with nested classes in Java. So far we have seen that we can create classes in Java and we can create objects of those classes to interact between those classes and objects and other properties as well. But what if you have a use case, or what if there is a need that you need to define a class within a class? So that's the concept of nested classes, that Java does allow you to create classes within the classes. Now, you might be wondering as to why do you want to do that? And the simple answer is encapsulation. You would be facing some scenarios while writing enterprise grade applications where you have a class which has its own scope, but that whole scope or the existence of that class is justified by another class. For example, if you try to design an object-oriented design for a house, then a kitchen cannot exist without a house because the kitchen exists inside the house, right? So if you have that kind of relationship, then probably kitchen class has to be inside the house class somehow. And that's where this nested class concept will come into picture. And that's why we have this nested class concept here. As you can see, what I'm showing on the diagram, that Java programming language allows you to define a class within a class, and that is called nested class. Now, when we talk about nested classes, you will hear two different terms. Basically, nested classes are divided into two categories, which are static classes or static nested classes and non-static nested classes. Now, static nested classes are called simply static nested classes, and the non-static nested classes are called inner classes because they are non-static, they are just normal inner class. Exactly similar to the way we say a normal method and a static method. Similarly, if you put a static keyword in front of a nested class, that becomes a static nested class. And if you do not put static keyword in front of a nested class, then it is simply treated as a general inner class. That's the overall concept. Now there are some more drivers of why you would like to use it. One example is I gave you about the existence of an object within an object, or technically speaking, the existence of a class within a class, the whole house and kitchen analogy, which I just shared with you. But broadly, you will see these different reasons due to which you will be using nested classes. First of all, it's a way to logically group all the related classes that are only used in one place. What it means is that if you have a class which is only serving the purpose for a larger class, then it's better to group those two classes together inside a single class, or simply nest the smaller class inside the bigger class. I might be using the term inner class and outer class to point out the static nested inner class and the outer class. That's the first reason. The second reason is, like I said, it increases encapsulation because now you have full control over what you can expose and what you cannot expose, or what you should expose and what you should not expose. Because inner classes will also come with its own set of visibility constructs like private, protected, etc. So you get more fine-grained control in terms of what you want to expose to the outside world collectively from the outer and the inner class. and it can lead to more readable and maintainable code. Though I would honestly say that this is debatable because in a lot of programming languages, static nested classes are not promoted because they drop readability. Imagine if you have 10 classes, if you have a single class and if you have a nested hierarchy of 10 classes, it becomes super confusing and super complex to track the visibility of the variables and also to understand the code better. So this is debatable whether it improves to readability and maintainability or not. Maintainability, yes, to a sense, because you have a single class which is containing the logic of a inner helper class and the outer class. Readability, yes or no, it depends. If the classes are small size, then yes, it does improve readability. If they grow larger, then it's better to move the class outside and just make that class maybe a package private or something. So this is the basic premise of why we use nested classes. Now let's talk about an example by which we can demonstrate how to work with the static nested classes. So here I have created a class. It's a simple class, but I've just named it as outer class so that we understand that this is the outer class. So I have a class here which is named as outer class, and at line 5 I am defining a static variable inside the class. You can see the static keyword here, and I've just called it as outer static member. Then I have a simple instance variable. This is something which you have seen normally in all the different examples I have given you. And then I have another static variable, but this is private. So this one is a normal static variable. This one is a normal instance variable. And this one is a private static outer variable. All these three variables are sitting in the outer class, but this is private, this is static, this is private static, and this is a normal instance method. And we will see how we can access these variables inside the static nested class. To define the static nested class, the way you will write it as you will be inside the class opening and closing braces, and you will start writing like this: static class and the name of your class. That is how you're going to define a static nested class. And then you put the curly braces, and whatever goes inside it is just like any other normal class you would write. So let's say inside this static nested class, I have defined a method called display. And now I am trying to access this particular variable, which was a static variable defined in the outside class or the outer class. We will see if we can access these static variables from the outside class or not. So that is what this system.out.println is doing. I'm just accessing this directly. You can see you can directly access the outer class static member variable inside the static nested inner class. Then in the next statement, I am accessing the outer private member, this one. So the outer private member, which is also static. So these two static variables are being accessed here in these two lines basically. And then I have commented out one more thing to try out if I can access the normal instance member. Also remember the concept which I taught you in the previous session, that a static method or a static block can only access static variables. A static block will not be able to access non-static variables. So these two are static variables, and this is a non-static variable. So we will see if the same construct still applies on this particular class or not. So inside the display method, I have these two sysouts, and this one is commented out. I will come back to that later. So you have your outer class and your static nested class ready with a sample method. Now let's see how we can invoke these outer and inner classes. How do we create the objects of an inner class? So for that, I have this static nested demo class. It's basically containing a public static void main method, as you can see here. And let's try accessing a static nested class. So if you want to initialize or access the inner static nested class, then you have to follow this kind of construct where you say outer class dot inner class name, then you give a reference to it. And again, you follow the same construct. You say new outer class dot static nested class name and a simple parenthesis. And this is how you are going to create an object of the static nested class, which you have defined inside your outer class. Remember this syntax. This is how you're going to do this, that you type outer class dot static nested class. Once you have done that, it will call the default constructor of static nested class, and you will get an object. Now you will also see the dependency which I talked about. There is no way that you can initialize this static nested class without referring it from the outer class. You always have to write this outer class dot to access the static nested class. You will not be able to access or use this static nested class directly anywhere in your program. So the whole concept of the inner class only existing with the outer class holds true here, because the inner class only can exist if you refer it from the outer class. Once you have the object, you call the .display method, and let's see what happens. So if I run this particular program, and let's see what kind of output do I get. I get 2 lines of output when I call the display method. So let's go to the display method, where I am doing a sysout for the static member of the outer class, which was this variable. So that value gets printed as 10. And then I'm printing the private static member of the outer class, and that also is accessible. So it means that you can access the normal static variable of the outer class and also the private static variable of the outer class inside a static nested class. That's one part of it. Now let's uncomment this and see if this works. You see that you directly get a compilation error, and you don't even have to wait for the program to be run. You see that this particular variable instance member variable is not accessible. So this also verifies our understanding which was built previously in the previous session, that static blocks can only access static members, and those static blocks will not be able to access any non-static variable or member. And this was a non-static member. So that's all I want to cover in this particular session, where we talked about the nested classes concept, the static nested classes concepts basically. And we also had a look at what the static nested class can access or cannot access. And we also saw how do we initialize an object of a static nested class. In the next session, we are going to talk about the second category of the nested classes, which is the normal inner classes or the non-static nested classes. Let's get started with inner classes in Java. So in the previous session, we talked about the static nested classes. And in today's session, we are going to focus on the non-static nested classes. We also call them simply as inner classes. So whenever you hear the word inner classes, always clarify whether they mean the static nested inner classes or the non-static nested inner classes, because people may use different terminologies. But the official or the standard terminology is, whenever somebody says inner classes, it means the normal nested class. And when somebody wants to convey static nested classes, they will use explicitly the word as static nested classes. So when we talk about inner classes, they look a bit similar to the static nested classes, with the difference that you will not see a static keyword when you define the inner class. That's one type of the simplest inner class you can create. It follows pretty much the same kind of construct, where you define the outer class and you define the inner class and you write the logic inside the inner class. So let's understand this with the help of an example, and we will also talk about the other type of inner classes which we have. So with that, I want to switch back to the Eclipse IDE, and let me comment this one out because I will cover this in a while. And let me fix an error here as well. So I will comment this as well. Okay, so let's talk about the demo which I have prepared. It's a very simplistic demo just to understand the concept. And please do practice all of these concepts in detail to get more confident about these. So I start defining a normal class, just naming it as outer class. And then you can create a class within a class. I'm calling it as inner class. You can obviously name it as anything you want. And you can write any logic which you want to write inside your inner class. Here I just have a display method where I have a simple sysout, which is verifying if I can invoke this particular method or not. So if you have this simple kind of construct of outer class or inner class, how do you initialize the inner class? Remember when we talked about the static nested classes, and if you wanted to initialize the static nested class, I had to follow this particular syntax where I said outer class dot inner class on both sides when I try to initialize the object. But if I want to initialize a normal inner class or a non-static nested class, the way to do that is like this. So on the left hand side, you again follow the same kind of construct where you say outer class dot inner class. You write a reference for it, and then you say new outer class. Here you are creating an object of it, dot new inner class. So you basically first initialize the outer class, create an object of the outer class, and then that object of the outer class can be used to create an object of the inner class. So this is the difference. If I take you back to the static nested classes initialization, here on the right hand side, it was simply outer class dot inner class and then the parenthesis, because this was a static member. So you access the static members by the class name. That's why class name dot static member. But you access the normal instance members via the instance and not the class name. So you need to create the instance first. And then once you have created that instance, then you can access any member variable of this class. And inner class technically is just a member variable, which has been initialized here. So this is how you're going to initialize an inner class. Then you get an object of it. And once you have got the object of the inner class, then you can call the display method. And whatever is written in the display method shall be executed. Let's run this program. Yes, I can see that the display method is getting called and it is printing whatever was written inside the display method. In the display method, I just simply had a sysout which said this is an inner class method, and that's what is getting printed here. That's one type of the inner class, which is looking very simple. Another a bit more complex and special type of inner class is called method local inner class. When I say method local inner class, the name itself explains what it means, that you are trying to create a class inside a method of the outer class. So let me just uncomment this part. So this is a normal method, normal instance method of the outer class. And inside the method, I create a class. You see, inside the method also you can create an inner class. That is also something which is supported by Java. And that's what I'm trying to showcase here. That when I define the outer class method, I write my whatever logic I want to write in my method, and then I can create an inner class, a method local class basically. I've just named it as method local class to just look it more readable. And then you can define anything you want to write inside your method local class. Here I have just defined a simple method called local inner method, and I have just printed a statement inside the local inner method which says in the method local class method. Once I've defined the class, then within the method, I can also initialize the class if I want. You can see I'm creating an object of the method local class within the enclosing method. That is also possible. So I create an object called MLC, and then once I have the object, I can invoke this method by the object, and that is what I'm doing here. So this whole logic can be just embedded inside a particular method, and we call this type of class as method local inner classes. This is also a type of inner class, but this is just to show you that you can also create method local inner classes. So this is what I've done here, and if I invoke this outer class method, what happens? Let's see that. So here I have written the code to simply initialize the outer class. Nothing new here. This is a normal initialization. And once I've done that, once I've got an instance, then I say outer class dot outer class method. I simply call the instance method. And once I call the instance method, everything is written inside the instance method gets executed. So first I should get this statement, then the class will get loaded and compiled, then an instance of the class will be created, and then whatever is written inside the local inner method will be executed. So technically I should see this sysout and ultimately this sysout if I run those two lines. Let me comment the first part so that we can observe the output correctly. And I run this as a Java application and I get these two lines. So I get the in the outer class method statement, which is coming from here. And then this whole code gets executed, and eventually when this method gets called, I get this statement as well, which is in the method local class method. So this is to show you how you can invoke the method local classes. Basically, there's nothing new here. It's just a normal class. You instantiate the normal class and then you call the object. You get an object and you call the method on the object of the method local class. Now there is another type of inner class which is called anonymous inner class, which we haven't covered so far. Anonymous inner classes are not very common, but sometimes you might need to do that. You might need to create anonymous inner classes, but always first understand and discuss with your teammates as to if there is a way to avoid anonymous inner classes, because they are not very readable. But let me cover that as well as part of this curriculum. So if you have to implement anonymous inner classes, let's first understand why do we need to implement anonymous inner classes. And I would like to do that with the help of a demonstration. So I have again created a simple interface of bicycle, and I will create an implementation class called mountain bike. So you see a bicycle interface, and I have two methods which says can speed up and can apply brake. Just simple two interface methods being declared here. Then I create an implementation class called mountain bike, which implements bicycle. And if it implements bicycle, it has to provide the implementation of those two declared methods in the interface. And that's what it does here. And for the sake of simplicity, I'm just printing a sys out here. All good so far. And then if you have to access or create an object of this mountain bike class, the way you do that is simply by just saying bicycle mountain equal to new mountain bike. Remember, I'm using the bicycle reference here, but the object is of mountain bike. So when I call anything on the mountain bike, then that implementation of the mountain bike will be invoked. So I'm just invoking the can apply brake method and can speed up methods. Nothing new here. You have already seen this when we were talking about interfaces session. But what if you want to create an object of the bicycle class itself? You don't want to create a mountain bike class at all. Is there a way to avoid creating mountain bike class and still being able to write this logic? Yes, there is a way, and that is the anonymous inner way. So I can just say bicycle equal to new bicycle. If I say new bicycle, remember I'm not saying new mountain bike because mountain bike does not exist, or I don't want to create mountain bike class. Then you can write this instantiation right for the interface class. But the moment you hit control space, and you will get this option where it will say, okay, I will get you an object of bicycle interface, but it has to be of anonymous inner type, which is lying in this particular package. So if you just click on this whole code will be generated for you. So you see, the moment you double click on this whole code was generated automatically for you, which is providing everything, technically everything which you wrote in the mountain bike class. So the whole logic which you could write in a child class gets embedded right into the instantiation code itself. And this is your anonymous inner class. You see, it automatically looks a bit ugly. And imagine if you're writing this for a real production code where each of the methods may have a lot of logic and you may have a lot of methods, then it can grow very long and it can look very ugly. That's why I was saying always try to create a child class instead. It can be a simple use case, but try to create a child class or try to avoid writing anonymous inner classes if you can. If there is no way out, then this is the way you do it. There's also a bit nicer way to do this using Lambda function for functional interfaces, but that is also something which will not improve the readability a lot, though it will make the code look smaller. So here you can write the exact logic which you want to write in can speed up and can apply brake. Basically, whatever you wrote in those two methods in the mountain bike class can very well be written here, and the code will still be executed. So let's just do that quickly. So I will just go here and copy the sysout from speedup method. I'll just put it here, and I will copy the can apply brake method, and I will put it here, and I will comment the mountain bike code. So I've created the object of bicycle class here, and now if I say bicycle dot can apply brake, and I can say bicycle dot can speed up. So now I can access these two methods, and the implementation will be invoked from this anonymous inner class implementation. So if I run this, I will get pretty much the same output. Yes, you can see I get exactly the same output. It's currently printing both of these sysouts as the same because I did not change the sysout here. And yeah, I have written the exactly same text in both of the cases. So if I just change this text to say can apply brake, and I do the same thing here, I say can apply brake, and if I run this, so you get the same output. And if you comment this back, and if you use the above code, you also get the same output. Yep. So that's the basic construct of anonymous inner classes, that you can use the interface instantiation. If you do not want to create a child class of it, just instantiate the interface, and Java will automatically generate the concrete override implementation for all the methods which are declared in your interface. And then you can provide the implementation of those methods inline. And that's all I want to cover for this particular session. So we covered a whole lot. We covered about the normal inner classes, we covered the method local inner classes, and we covered the anonymous inner classes. Let's get started with packages in Java. Now, I have been using the concept of packages all the while in all the sessions, but we never focused particularly on packages and why we need them, how do we create them, what are the thumb rules. So we will focus on all of those questions in this particular session. So first of all, just to get the definition out, a package is basically a grouping of related types. Now these types can be classes, they can be interfaces, they can be abstract classes, they can be nested classes or whatnot. But the basic idea is that you try to keep everything which is related to each other at one place. It's quite similar to how you arrange your house or how you arrange your office or how you arrange your work desk. You try to keep the similar kind of stuff together. For example, you might have a particular rack in your almirah where you keep all the books. You might have a different rack where you keep clothes. Generally, you won't mix books and clothes together in a single rack, right? Because they don't belong together. And that's the concept basically which Java packages try to put you or give you to implement in your programming language and your project as well. So it's a logical way of grouping related classes and types together. That's what packages do. And if I take you back to the Eclipse IDE before I go any further, you will see all these square looking objects, right? These all are packages. You see the square icons, these boxes, these are packages. And the way you create packages is basically, if you just go to the SRC, let me go back to the SRC, and you right click on this, you go to new, you will get an option of package. So you can go click here and write any name of your package. Let's say test.package. Couple of things to note is that packages follow this convention of dot, and that is how you nest a package into other, or that is how you create a hierarchy of packages and sub packages. So you can create this as a package, which is fine. And you can also create dot something else, dot something else, dot something else, and you can go further as well. Other thing to notice is that this will not accept keywords. You can see it says else is not a valid Java identifier because else is a keyword, a reserved keyword in Java. So make sure that you are not using those reserved keyword names in this particular package name. So it can be test.test1, test2, test3, whatever. So just make sure that you're not using keywords here, and you can create the hierarchy. Now, how do you name them? Different organizations and different project teams follow different naming conventions. This is your area. This is fully customizable, so you can write it the way you want it. Generally, what companies do is they put their domain name from the backwards. So for example, google.com might have a package called com.google. Similarly, amazon.com might have a package called com.amazon internally. This is something which might have been there, but they might have chosen something else. But this is sort of the standard convention that you just reverse the domain name of your application and you write the package name backwards. That is the general convention. And after that, once you have written that, let's say if you have written com.google, this is the top domain name. Now, after that, you specify what you want to do. Let's say you are implementing a web package. Then you can be even more specific. Okay, web package is a huge package. What is specifically this package will be doing inside the web package? So let's say HTML. HTML might not be a right example, but let's say some front-end code, front-end auth logic, let's say. So now this can be a valid package because if somebody reads the package, they can understand what would be lying inside the package. This hugely improves readability, and please do spend a good amount of time in naming your packages right. Because once you write the code is going to be living for many, many years to come, and many other developers, once you leave the organization, many other developers will be looking at that code, and you would like to make their lives easy by understanding the code by just looking at the package name. So please name the package names correctly. And once you have written this package name as, for example, in this case, front-end auth logic, or let me say front-end dot auth logic. Once you have written this package name as auth logic, then make sure that only the classes which belong to this particular business requirement are present inside this package. No other unrelated class should go inside the package. That is something also which developer have to take care of. So this is again the responsibilities of the developers, that they make sure that whatever goes inside this particular package is only relevant to the package. There's no irrelevant stuff which should go inside the package. Again, this is to improve readability, searchability, maintainability, and tons of other out-of-the-box benefits you get. So that is how you create the packages. Now, let me go back to the documentation and talk about why would you use that. Let's look at some of the more benefits of it. So if you scroll down in this official documentation, you will find bunch of reasons and benefits of it. First of all, you and other programmers can easily determine that these types are related, because if some classes and some types are sitting inside a package, then there is an expectation that those classes and types serve the purpose of that package only. It also provides a benefit that you and other programmers can easily find the types that can provide a particular type of functionality. Again, the same concept of aggregating single functional classes into these packages. That if you are writing, let's say, a banking application, and if you have a package called interest rates, then everything inside the calculation of the interest rate and the specification of the interest rates should sit inside that particular package only. Similarly, the names of your type would not conflict with the type names in the other packages. That is also a huge benefit of packages, that once you start writing a particular class inside a package, and if you make that particular class as private package, then that particular class will be visible only within the package. And you can again recreate the exact same class with the exact same name in another package. Let me give you an example. So if I go to, let's say, the inheritance example, here I have a class called bicycle. This is a bicycle class. And if you see, strategically, I have not put public here. I have removed the public identifier here. So this class is only visible within this package called .inheritance. This particular class will only be visible in this package to these other classes. Now, if I go, let's say, if I go to method overriding, I have another bicycle.java here. If I open this, this is also a class. These two classes are exactly the same, but they don't conflict with each other because both of them are package private and they live in different packages, and only those packages can see them. This particular class is present in this particular package, which ends with .method overriding, and this particular class ends in a package which ends with .inheritance. So if I go here, let's see, if I go to the main class, and if I try to type bicycle and I put control space, you see I only get the suggestion of this package private bicycle class, which is sitting inside the method overriding package itself. What if I change the visibility of this inheritance package bicycle class to public? Let's make it public. And now if I go back to the method overriding demo, which is sitting in the method overriding package, where I already have a bicycle class. And now if I type bicycle and I do control space, I get two options. One is from the local package. And because I have made the other bicycle class as public, I get that as well as a suggestion. And if I import this one, you see now the inheritance package bicycle class has been imported in the method overriding package. It can create a lot of confusion. That's why it is always a good practice to work with the access modifiers really well and try to restrict the visibility of the classes to what they should be accessible at. And that's why it's a good practice to keep the classes within the package private visibility so that they're only visible within the package. This will help you in a lot of ways, providing any kind of problems around ambiguity. So ambiguity is a big problem when you have huge projects with a lot of similar class names. So that's all I want to cover in the session of packages. And you can obviously nest packages within one another. You can go as long as the package name you want to be. Just make sure that there are no keywords in those package names. So that's all for this particular session. Let's get started with recursion in Java. So let's first understand what do we mean by recursion, and then we will look at the details of the class which you are seeing on your screen. So recursion is the phenomena of a method calling itself. So we have the scenarios where we call a particular method on an object, right? But what if you have a scenario where a method wants to call itself? Now you might be wondering why a method would call itself, because this will go into an infinite loop, right? If you write a method called sum and then the sum inside the sum method, you again invoke the sum method, then this will keep running into loops till your program goes out of memory. I will show you the example of that as well. But the basic idea is the use case where if you have a need where the method wants to call itself, that is where you will use the recursion concept. Another thing, whatever you can achieve with recursion, generally you can achieve the same output using for loops as well. But when you use it for loops, it will require you to write a lot of code. Recursion will reduce the number of lines you need to write and manage in your code. But on the other side, recursion can get a bit complex because it requires an advanced understanding of how methods actually work in Java. So before I go any further, understand that methods, whatever you define inside the method, that goes onto a stack. Remember, I covered about stacks and it's a LIFO arrangement. So whatever you define inside your method, all those variables and all those statements, they go onto a stack. And then the stack gets emptied one by one, executing the statement which is sitting on the top of the stack. That is the concept of the method execution, that under the hood it is using a stack. Now, when we talk about the recursion, it also follows the same stack insertion and stack item removal concept, that how do you insert elements into the stack and how do you remove them. So we are going to walk through an example of recursion with the help of a use case called factorial. Now, if you have studied about factorial in your school classes, you might remember that factorial is a way where, let's say, if I have to calculate the factorial of 10, then it would be 10 into the factorial of 9, into the factorial of 8, into the factorial of 7. So you see, I'm repeating the concept of calculating the factorial again and again. First, I'm calculating the factorial of 10 into factorial of 9. Then I say 9 into factorial of 8. Then I say 8 into factorial of 7. Then I say 7 into factorial of 6, and so on and so forth. So this is the concept of how do you calculate factorials. Another example where you can use recursion is a Fibonacci series. So when we talk about the Fibonacci series, the basic idea is that you sum the previous two elements, and that's how you create the next element. Then you sum the immediate previous two, and you create the next element. So again, you perform the operation of summing the past two elements again and again to calculate the next element. So you see, again, you're repeating the same operation again and again. So try to identify that particular thing where you have to repeat the particular operation again and again on the whole sequence. That would be the use case where you might be needing to use a recursion concept. So here I have prepared an example for calculating the factorial of a number. So what you see on your screen is a class called complex function, and then it has a method called calculate factorial. And inside the method, you supply an argument, which is basically a number for which you want to calculate the factorial. So if you supply 5, a factorial of 5 will be calculated. If you supply 10, a factorial of 10 will be calculated. Now, the first thing which you need to do when you write a recursion function is to know the exit condition. That is probably the most important concept when you write recursion. You should know when to end the program. If you get it wrong, then your program will be stuck into an infinite loop, and it will only exit when there would be a stack overflow. Basically, there will not be enough memory inside the JVM to run your program. It will crash technically. So remember always to define a exit condition. Some people also call it as a base condition, but remember the base case or base condition or the exit condition. Either of the terms can be used interchangeably, but always remember to first define the base condition. So here, when do you end calculating the factorial? You know the factorial of 1 is 1 and it cannot go any further. So that would be your base condition, that once, if you encounter a scenario where somebody inputs 1 as an argument, then you simply return 1 because the factorial of 1 will be 1. So this is your base case. This is what is going to make sure that your program exits smoothly. If you get it wrong, your program will never end. It will go into an endless mode. Then in the else condition, you write the factorial logic based on the recursion. So like I said, what does a factorial function does is, if you calculate the factorial of 5, then it would be 5 into factorial of 4, 4 into factorial of 3, 3 into factorial of 2, 2 into factorial of 1, and that's when it will end. So here I'm saying, let's say if n was 5. So you say 5 into, you again call back the same function. 5 into calculate factorial of 5 minus 1. So now again the function will be invoked with an n equal to 4. It will go here. This condition will not be met because n is 4. It will go to the else block. Again the same thing will happen. 4 into calculate factorial of 3. So you are again invoking the same function, but this time supplying n as 3. So it will go here, n will be supplied as 3. It will again check the base condition, n is still not 3, n is still not 1. So it will go to the else block. So 3 into calculate factorial of 2. It will again go up, and again it will invoke the calculate factorial method, but this time with n equal to 2. This condition is still false because n is still 2. It will go to the else block and it will say 2 into calculate factorial of 1. It will again go up. This time it will invoke with n equal to 1, and it will go here and it will satisfy the condition. And that's where your program will have its first output. You remember previous execution of 5 into factorial 4 into factorial 3 into factorial 2 did not result into an output. These were the executions of the method call which were just going on the stack. So you were just, at first you had the calculate factorial of 5 on the stack. On top of it, you had the calculate factorial 4 on the stack. Then you had calculate factorial 3 on the stack. Then you had 2, and then you had 1. But when you had 1, your program did received or reached an particular end. So that was your first output. Once you have your first output ready, then you go back to the previous one. So the first statement has been popped now. You go back to the calculate factorial of 2 and you calculate that. Once you have the output of that, then you go back to calculate factorial of 3. And so you basically unpack the stack now. You basically try to remove the elements from the stack. To visualize this, this is how it will look like. That you first call the factorial 5. Let me just change the name of it just to make it look exactly how it will go on the stack. So this is how it is going to go on the stack. So you call the calculate factorial of 5, which in turn called the calculate factorial 4, which in turn called calculate factorial 3, calculate factorial 2, calculate factorial 1. And once you had the calculate factorial 1, you got the first output. And once you had the first output, then you start unpacking it because you had the value of the calculate factorial 1. So you can say 2 into calculate factorial 1's output. Calculate factorial 1's output was 1. So 2 into 1 becomes 2. And this is the output of calculate factorial 2, right? Then it goes to the next step, basically this one. And calculate factorial 3 was demonstrated as 3 into calculate factorial of 2. So 3 into calculate factorial of 2, which is this one, 2. So this gets replaced here 2, and you get the output as 6. Now you have this one also resolved. The next one on the stack was calculate factorial of 4, which was written as 4 into calculate factorial of 3. So 4 into calculate factorial of 3's output. So this function calls output. This function's call output was 6. It goes back and it says 4 into 6, 24. And you have this one also calculated. Now you go to the last statement, which was calculate factorial of 5, which was written as 5 into calculate factorial of 4. And calculate factorial of 4 has been already computed as 24. So now you can simply say 5 into 24, which is the output of calculate factorial 4. And you get the output as 120. And this is the final return statement which will be returned to you. So if you try to understand this, till this particular point, you were just calling function after function after function with a different value of n. And everything started getting into a result due to the base condition. This was the base condition. And that's why the base condition is very important. Now imagine there was no base condition. Then this would never return, and it will keep calling calculate factorial, and it will keep going down the stairs. It will never be able to come up because there is no base condition. And that's why base condition is very important. At the same time, also understanding how recursion works is also very important. Always remember that the output of the first execution gets supplied in the second execution. The output of the second execution gets supplied in the third execution. And that's how the stack unpacks or empties itself. So here I'm just doing the normal drill here where I'm saying complex function equal to new complex function, and then calling the calculate factorial method, passing 5 to it, and then printing the eventual result. And if I run this, I get the output as 120, which I just walked you through. So remember how to use the recursion, why to use the recursion, how to define the base condition. All of these things will be of very much importance when you try to implement recursions. Practice this a lot. Recursion is a concept which takes time to get used to. So practice many different examples and many questions of recursion and you will be more confident about it. Read more about this concept in the Java docs, look at different examples on the internet. That will help you build more knowledge around this. And that's all I want to cover in this particular session. And in the next session, we are going to talk about how do we call methods, basically how the method calling works. We will look at different examples and the pass by value concept, etc. when we look at the method calling. Let's get started with method calling in Java. Now, when it comes to defining the methods, I have been talking about methods throughout this particular series. And the syntax is pretty familiar, where you first specify the access modifier, then you specify the return type, then you specify the actual name of the method, and after that you specify all the arguments which this method is going to accept. And inside the curly braces, you do your calculation, and based on the return type, you return an appropriate value. We have seen many examples of it, and let me show you a quick example to just understand the method anatomy better, and then we will talk about how do we pass arguments to methods. So in this simple class student, I have some properties, I have constructor, and then I have methods. These all are also simply methods. You can see we have an access modifier, which will decide whether this particular method should be visible to the outside world or not. You can also either remove this particular access modifier or make the method private if you want, or you can also make the method protected if you want. So all of the possibilities are there, and what kind of access modifier will you keep depends upon your use case. So that is the access modifier. And then if your method is not supposed to return anything, then you would just say void. Void is the default keyword in Java, which is used for use cases when you do not want to return something. Void just means empty or nothing. So when you have nothing to return, you are going to put void. You cannot skip this. If you remove this, the method signature is not complete. So you have to provide this. There is no way around it. So you need to provide the method return type. After that, you provide the name of the method. This is a free text string, and you can name it whatever you want. Just follow the camel casing convention, where you start with a small alphabet, and for every new word in the method name, you start with the first letter as capital. After that, you put normal braces and you supply the arguments which this particular method is going to accept. For example, if this method was about calculating interest, then probably you might supply the interest rate as the argument and the principal as the argument. If this method was about calculating the price of the car, then you might supply all the different mileage details and the manufacturing details which would decide the price of the car. So it depends upon what you are doing, and that's how you will understand what kind of arguments your method is going to need. When you define the arguments, you need to define the data type of the argument, and again a name which you can give it as anything. This is again a free text string. And after that, it depends upon you what kind of logic you want to write inside the method. The basic need for writing a method is to not do the same thing again and again at every place. If you have a functionality, let's say if I take the same example, if you have to calculate interest and the interest calculation logic is required at, let's say, 15 different places in your application, then just create a single method for calculating the interest rate or the interest, and then just reuse that method again and again at different points in your application. Just call that method. That's how we use it. So that is the basic idea of creating a method, to keep reusing the functionality over and over again across all the different methods in your application. Let's take another example of this particular method because it has a return statement. Again, I specify a public access modifier. I specify the return type, which is string in this case. Then I specify a name of the method, and I can also choose not to supply any argument if the method does not need any argument to do its computation or to run its logic. If you put a return type, any other return type, then void here, then you have to provide a return statement. The return statement will be the last execution step of your method. Remember that. The return statement will be the last execution step of your method execution. This has to be provided if you provide a return type other than void inside your method. In this particular case, this method expects a string return type, which means when I call getName, I should get a result back, which should be of type string. Then I need to write a return statement and return a variable which should be of string type. For example, if I just change this method to say, let's say if I say int I equal to 1, and if I say return I, this is going to give you an error. You see there's a compilation error, and if you hover over the balloon icon, it says cannot convert from int to string. It is trying to convert this particular return type and trying to match this into this particular return type, and it's not able to match int to string, so you get an error. So it has to exactly match the return type, the data type of the return value which you have put here. It has to match exactly with the return statement variable type. If it doesn't match, you're going to get a compilation error. That's the first thing. Now, there might be scenarios where you have multiple branches of execution in your method. For example, if you have, let's say, if I just use this condition of I equal to 1 and I write if I equal to 1, then return, let's say, a test string, else return the name. I'll just cut this and put it here, and we'll change this to name. This is also possible. And this is possible because of the same statement which I told you earlier, that return statement has to be the last execution step of your method execution. In this particular method, there are two branches of execution. This is one branch and this is the other branch. At a particular time, either the if block or the else block is going to get executed. There would never be a case that both of the blocks get executed in the same execution cycle. It will always be either this block or this block. And that's why if you use these kind of statements, then you have to provide return type in each of the branches. You can also do something like this. Let's say if I say string return var equal to null, and then I say control C, control V, I assign test string to the return var, and then here also I assign name string to the return var, and at the end I say a single return and I say return var. This is also fine because here I am just assigning different values in the if block and the else block, and then just returning the placeholder variable, which is also absolutely fine. So you can use either of the way. The better way is to return from within the branch itself. So this was a quick tour for you to see how methods work and what kind of anatomy method represent. Now let me just quickly revert everything which I did here and bring it back to return name. That's good. And now let's talk about the method calling patterns and how do we call the methods. So for that, I have prepared a class called method calling demo. It has a public static void main method. And here I have just declared a simple variable I and initialized the value of I as 1. Then I'm calling a method which is named as change value. And if you go to this particular method, it has a very simple implementation. It is accepting the argument which I created here. I'm passing this particular variable as an argument to this method, and then whatever argument I supply, I'm incrementing that argument by 1 and just return and not returning anything from here, just incrementing the value of I, and that's it. And after that, I'm printing I. So what would be your guess here? What would be the value here? I'm going to pause here for a moment and to let you think about what is going to happen. Okay, I hope you would have done some calculations in your head to see what is going to happen and what is the value of I eventually at line 8. Let's run this program to understand that. Okay, so I had initialized I as 1. Then I passed the value of I in this particular argument, and I said I equal to I plus 1. So it should be 1 plus 1 equal to 2, and the new value of I should be 2. But at line 8, I still get I as 1. Why is that happening? It's happening because of the concept of pass by value. Remember that concept that in Java, every argument which you pass to a method is passed by value and not by reference. In simple language, what does it mean is that when you pass this particular argument, a copy of this particular argument is a copy of this particular variable is passed to the method argument. It's not the exact same variable. We are not passing the same reference of I here. We are passing a copy of it, a unique local copy of it. That's why whatever you do with I inside this particular method is not going to change the state of I which is defined here, because it is passed by value, or in simple language, the object is copied over locally to the method. It's not the same reference which is being passed upon. That's why you see this value. If you want to get the return value, then the one way is to just change the return type and say return I, and then just store this return I value here, saying int result equal to whatever is returned from here, and we are returning the new I here. And then you can print the result and you will get 2. If I run this now, I get I as 2. So this is just to validate that everything in Java is pass by value. There is no concept of pass by reference when we talk about method calling in Java. Let's take a more complicated example. This was a simple variable. Let's go back to the student.java. So I have the student class here. Let's create some objects of it and try to follow the same pattern. So here I have created an object of the student class named John, age 25, address 23 East California. I'm doing some sysouts which are not really important here, but let me just uncomment this particular method. So here what I'm doing is I'm calling a method. I'm basically defining a method which says change name in the same object, and I'm supplying the student object. So the student object gets here, and then I'm overwriting the name in the student object. That's what I'm doing here. So now let's just call this particular method and see what happens. So I'm going to call this particular method here and pass the object John inside it. And then let's try to print the name of the object referenced by John. If I say get name. So I'm calling this particular method, passing the John object here, where I'm overwriting the name John with Jane, and then I'm printing the new name of the John object. Let's see what happens now. So if I run this particular program, yes, I can see that the name has been overwritten from John to Jane now. This happened because you passed the reference pointed to the object inside the method, and then you overwrote the name on the object which was pointed by this particular reference. So here you might think that this is passed by reference, but this is still passed by value, because this reference is not the same reference as this one. This is a different reference, but both references are pointing to the same object. That is the only commonality here. So you can mutate a particular object inside a method, and be very careful of that. Do not ever try to do that, because it is going to create a lot of unpredictable results for you, because it might be possible that you're calling a particular method from some other application which is doing a lot of changes in the same argument object which you supplied, and then you don't know what is the state of it. So it's a very dangerous pattern and very dangerous way to mutate the objects. Do not do this. Let's find another way to deal with this problem. If I don't want to mutate the same object, how do I solve that problem? So we can solve that problem simply by creating a new object and changing whatever we want to change. So I have one more method here which says change name in a different object. It is also accepting the student object, and then here it is creating a new student object, and here it is overwriting the name but getting the age and the address as the same values from the argument. So we keep the age and the address same, but we create a new name, but we don't overwrite the same object. We create a new object, and then we can return this particular new object if we want to. I can do quickly this, and I can say return new student, and then I can store the value of this particular method calling. I can call this method here, supply the same argument as John. Let me comment this one, and then I can store the value of the result, student result obj, and I get the value here, and then I can say result obj.getName. And if I run this program now, remember I'm calling a different method now, which is going to create a new object and then change the value. I do get the same effect, but now my previous object John is not touched at all. It is safe and sound. I can reuse this John object anywhere in my method, in my application, and I can be assured that nothing is changing in terms of the state of the object. So always follow this particular pattern whenever you are calling methods and passing arguments to the method. And if those arguments happen to be your custom classes and even Java classes, in fact, then always try to create a new copy of the object inside the method if you intend to mutate or change the state of the object. Let's get started with today's topic, which is about exceptions in Java. Let's first understand what are exceptions and why do we actually need this concept. The simple reason for having exceptions existence is that developers make mistake. We do create bugs and errors while we write code. It's natural. It always happens that whenever you write code, you might miss out some condition or the other, which creates a bug in the application, which creates a defect in the application. And then the testing team finds that defect and then we fix that defect. And that's how a normal software development lifecycle works. So to handle those kind of exceptions and errors, every programming language provides their own exception and error framework to support the developer in spotting those errors and fixing those errors and handling those errors instead. And Java also provides its own exception framework. So what you see on the screen right now is basically a snapshot of the exception framework of Java. And you see it has a long hierarchy of different classes here. This is also an inheritance hierarchy, just to give you context. And the whole exception framework hierarchy starts with a class called throwable. So throwable is the class which is the root or the parent class of handling all types of exceptions and errors. And that's where the next differentiation comes, exceptions and errors. Java treats these two things differently. And I will go in detail as to what is an exception and what is an error. But let's first understand the hierarchy further. Under the exception hierarchy, you see some exceptions like IO exceptions, which is an exception which comes when something goes wrong in the file writing or file reading or the file handling operations. Then you have SQL exception, which comes whenever you are talking to the database, writing SQL queries and something goes wrong. You also have class not found exception, which comes when a class is not found in the runtime or at the time when the class is being loaded in the JVM. And then you have also runtime exceptions, which are like arithmetic, number format, and there are lots more of this type of exceptions as well. On the right hand side, you have the error type, and then you have some errors like JVM error, memory error, and framework error. So now coming to the differentiation between exception and error. Exception is a type of problem which can be recovered in a program, from which the program can be recovered, which the developers should handle. So exception is a type where the developer focus is. The developer is responsible to make sure that none of these exceptions occur in the program. And if these exceptions occur in the program, then the developer has the responsibility to handle these exceptions properly. We will look at the examples of how the developer can handle these exceptions. On the right-hand side is the error type, where the developer does not have any control. You cannot do anything if the JVM has an error, or if the underlying memory of the computer or the JVM memory gets an error, or the whole framework or the Java itself, library itself has an error. You can't do anything about that. And those are the kind of problems which go into the category of error. That's why Java has created these two different categories. One is exceptions, which is the responsibility of the developer, and other is error, which are not the responsibility of the developer. And in fact, developer cannot do anything if this happens. So this was a quick tour to you to what kind of the exception framework is present in Java. Do read about this framework in detail in the Java docs as well. But just to extend this understanding further, we'll have a look at some examples of the exceptions and how these exceptions occur. So with that, I'm going to switch to the Eclipse IDE, and I have created a bunch of classes to show different types of exceptions. So let's go through the first class, which is named as Simple Exception Demo. It has a main method. It has a variable of int type. The variable name is data. And what I'm doing here is I'm dividing 100 by 0. So if you see this carefully, you know that this is going to result in an infinite value. You cannot divide any number by 0. And Java also prohibits doing the same because it doesn't make sense to divide anything by 0. So if you run this particular line, if you execute this particular line, this is going to throw a runtime exception. These are the runtime exceptions, remember. So let's try to comment rest of the code and let's quickly try to run this. So I run this program and there you go. I get an exception which says exception in the thread main. Main is the main thread. Which the exception type is java.lang.arithmetic exception. And this is the exception type, divide by 0. And it will also give you the line number at which the exception happens. If you click on this, it will directly take you to the exact line at which the exception happened. And this is, if you see now, this helps the developer a lot. This information which is printed here is called exception stack trace. And you can look at the stack trace, go to the last line, and this would be the line from where the exception actually originated. If you click on that particular line, it will take you exactly at the place where the exception might have occurred. And then you can look at the line, fix the code, and rerun the program to see if the exception is gone. That's why I said that developer has to handle this exception. Now, as far as handling these exceptions is concerned, I'm going to cover that in the next session. But in this particular session, we are just going to focus on the types of exceptions and how they occur. This was an example of arithmetic exception where we are trying to divide something by 0. Let's take another example. Let me uncomment this particular line of code and comment back this one. So here I am creating a string A, but the string is null, and null means nothing. It's a void reference. It has nothing in it. And now if I try to do some operation on this particular string, so remember A is null, and whenever you are trying to operate something on a null object, Java is going to throw you an exception because you can't operate on null, because null means nothing, empty. It is a dummy thing. So you cannot do anything on this particular null reference. And if I run this program, I get an exception which says null pointer exception, java.lang.null pointer exception, and it will give you the exact reason. Cannot invoke string.char at int string dot, this is a string type, string.char at int because A is null. So it will give you the exact reason as to why this program failed. And then again, if you click on this particular line, it will take you the exact line where the problem is. And then you can fix the problem. Maybe you need to initialize the string properly to make sure that this error doesn't occur. So these are all the runtime exceptions which the developer has to take care of, which the developer has to fix to make sure that the program runs smoothly. If they don't handle it, the program is going to fail, and the program will actually force them to fix because the program will not run unless they fix those exceptions. Now, these are the examples of runtime exceptions. You can also create these kind of exceptions, which are called checked exceptions. Runtime exceptions are also called unchecked exceptions. You might hear this term as well. Some people use the term runtime exception instead of unchecked exception and use both of them interchangeably. So runtime exceptions are also called unchecked exceptions, and these exceptions are called checked exceptions. Why do we call them checked and unchecked? Is because these exceptions are something which you do not have to explicitly specify in your program. In this program, I did not have to explicitly specify this particular because I don't know if this line of code is going to result into a null pointer exception or not. But these exceptions are something which Java will force you to handle. Let's look at an example of this. So I have created one more class which is named as checked exception demo, and I'm doing some file operations, basically reading a file, writing to a file, etc. I'm using some classes of Java named as file reader and some methods like readLine and close. And if you see, the moment I'm trying to read a file, this line has a red marker. There's a compilation error. If you scroll over it, it says unhandled exception type file not found exception. So Java is forcing you to handle this particular exception because file not found is a checked exception. So if your expression, your line of code is throwing a checked exception, then Java will force you to do something about it. It will not compile the code until you either handle this exception or you rethrow this exception. Again, how do we handle this is something which we will cover in the next session. But you can always rethrow this exception, but you have to do something about it. You cannot just skip it. So what I can do if I don't want to handle this is I will pass on the responsibility of handling this exception to the callee program. So whoever is going to call this main method has the responsibility now to handle the file not found exception because I've just thrown it. I've just passed it on. I've just passed my responsibility to the callee. And you can do similar thing here as well. If I go here, you see it says unhandled type exception IO exception. And if you remember, IO exception is here. It is a checked exception. So I can do one more throws here, comma V. And now if I just resolve the import, whoever is calling the main method has the responsibility of handling the file not found or IO exception. You can also handle it like I said, or you can just add throws clause to the method signature, and then the caller has the responsibility to fix or handle the exception. So this is how the checked exceptions work. Remember, in the unchecked exception, in the runtime exception, we can see that these two lines do throw exceptions, but there is no forced way by Java to tell us that I have to fix it because Java doesn't care about unchecked exceptions at the compile time. It will only encounter those runtime exceptions at the runtime. That's why they're called runtime exceptions. but checked exceptions are compile time exceptions, and you have to fix them, handle them, or throw them right at the time of compiling the code. So that was about checked exception. Now there's also a possibility that you can create your own exception if you want to. So for that, I've just created a very simple class here called myException. And the way you create your own custom exception is by just extending your class with exception class. You just write this extends exception, and you can write a default constructor or a parameterized constructor, whichever makes sense for you. And this is your exception class ready to use. And you can just invoke this exception explicitly. Remember, whenever you are creating your custom exception, it is by default a checked exception. So your program has to handle it. For example, if I go back to this particular class, and if I do this, let me just comment all of this code now and remove the throws clause as well. So if I go here and I'm saying throw new myException. MyException was my class. So I'm explicitly throwing an exception, which was my custom exception. And I again get the error. If I hover over it, it says unhandled exception type myException. So I have to handle this exception, or I can just throw this exception and let the caller handle it. So this also works. So this basically builds our understanding that broadly there are three different types of exceptions which we work with. There is a runtime exception, which is also called unchecked exception, which happens because of developers' mistakes in the program, like this one. Then there is a checked exception, which developer might not be responsible for creating the exception, but developer has to handle it. And there are some classes in Java which throw those checked exceptions, like file not found exception and IO exception. Whenever you are working with file handling operations, Java will force you to handle those checked exceptions or rethrow those checked exception using the throws clause. Similarly, the third type is when you create your custom exception type, and custom exception types are also checked exceptions by default. And whenever you are explicitly throwing your own custom exceptions, you again have to either handle the exception within your enclosing code, or you can just rethrow the exception and let the caller handle it. So this is a quick tour of different types of exception and including this exception hierarchy. And let's get started with exception handling in Java using try and catch blocks. So in the previous session, we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception, or there's a checked exception, or there's an unchecked exception, or there is a custom exception. Now, we did not talk about how to handle those exceptions, and now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try catch block. So try catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try catch block so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to enclose your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? Just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that. If you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called writeList. I have a try block here, and this try block is basically initializing an array list, adding an item to the array list, and then I'm accessing list.get1. Remember when I added this particular value, let me make it 10 to make it more understandable. When I added 10 to this particular list, this goes to the index 0 position. And here I'm trying to access index 1 position, which does not have anything. So in such case, it might throw an error because there's nothing at list.get1. So this is my method where I put the try block code. And then because I don't want to end up in a position where I get an index out of bound exception. Index out of bounds exception comes if you are trying to access an index which is illegal, which does not having any value. So I'm putting a catch block and catching the index out of bound exception and just printing the message of the exception. And then for simplicity, I'm showing a finally block as well, though I do not have any resource to close here, but this is just to show you how this looks like in the code. This is just to show you that I'm printing a sys out here. This is what my method is. And if I go to the main class, the try-catch demo class, I'm creating an object of the writer helper class and calling the writeList method, which we just walked through. Let's run this program and see what happens. Okay, so first I get this statement saying entering try statement. So if I go here, I call this method, the execution goes inside the try block, and I get this sysout which says entering try statement. Then I try to access the second element in the list because the position is 1. This is going to index 0 and I'm trying to access index 1. There is nothing at index 1. So I get an error saying index out of bounds exception, index 1 out of bounds for length 1. Because the total length of the list currently is 1 because there's just one element and that one element is sitting at 0 and not 1. So I get the exception, which is the index out of bound exception. But the index out of bound exception is caught by my catch block, and the system.error.println is something which gets executed, and I get this particular line from this line number 17. And then irrespective of the fact whether an exception occurred or not, my finally block always gets executed. Let's fix this and see if the finally block gets executed even if there is no exception. So now accessing get 0 and let's see what happens. Yep, I access the element 10, no exception, but the finally block still gets executed. So this is to assert our understanding that the finally block will always be executed irrespective of the fact whether there was an exception or there wasn't. Now you can also nest different try blocks if you want to. Let's look at an example where I have multiple try blocks. So you can write a try within a try within a try if you want, and you can go as deep as you want. But remember, the more indentations, the more hierarchy you create, the program is going to get more and more complex. So always remember to have that kind of trade-off. So I write multiple try blocks, I initialize an array, I print array 10. Obviously array 10 does not exist because this array has just 4 elements. So this is bound to throw an index out of bound exception, and I'm catching that exception immediately in the catch block. This is the exception, printing a sysout and just rethrowing the exception. You can also rethrow the exception by just using the throw keyword. Remember, this throw is different from the throws keyword, which comes in the method signature. This is just to throw any exception from your code. So this is array index out of bound exception for this try block. Then I have another array index out of bound exception for this try block, which starts from here, block 2. And then I have another catch block for the block 1 try block. So you can see it is already getting a bit complicated where I have multiple hierarchies, but you can do that. So this is what is happening in this particular program. Now let's try to run this and see what happens and try to decipher the output. Okay, so at first I get this particular line which says array index out of bounds exception in block 3. What happens here is that this line gets executed. It throws an array index out of bounds exception. At line 13, that array index out of bounds exception is caught, which was generated from this line. And then we go inside the catch block. We execute this sysout. This is what you see here, the same sysout. And then we rethrow the exception. If we rethrow the exception goes to the enclosing try block. The enclosing try block is this one. There was an exception rethrown from this try block, and now it has gone to this try block. And now this try block, block 2, will try to see if it can catch this array index out of bound exception. Yes, we can catch it. So it can. So the block 2 again has a catch block which catches the array index out of bound, and it prints a sysout here which says exception in block 2, which we see here, and it again rethrows the exception. And if it rethrows the exception, so now the block 2 is rethrowing the exception. So this whole code is now rethrowing the exception. If this block 2 is rethrowing the exception, it goes to block 1, just going one hierarchy up. And then it sees if it can handle the exception in the catch block of this block 1. So yes, the block 1 try block also had a catch exception which said array index out of bound E4, and here it just had a sysout. So if I just bring back the output, yes, we do get this particular exception printed here, which says array index out of bounds exception in block 1. This is what you see here. And this is where the exception just stops going propagated, because I'm not rethrowing the exception from this particular catch block. So that's where the exception ends. The reason you see a hyperlink here is because the text which I have printed here exactly matches with the name of the exception. So Java is pretty smart in that case. If you use the exact same name exception, it will link it to the matching class name in Java, which is pretty cool. I also have a redundant catch block here, which does not have a try block. This is just to show you that you can write a catch block without a try block, but it doesn't make sense. It is of no use, so I can just remove this particular catch block and the program still will compile fine. So this was a quick demo to show you how you can use try, catch, and finally blocks, and when would you use the finally block. And if you want, you can use a nested hierarchy of try blocks, and you can rethrow the exception from within the catch block only to be caught in the outside or the outer or the enclosing block. So this is all I want to cover in this particular session. Let's get started with equals and hashcode in Java. This is probably one of the most important and interesting concept in Java, and extremely popular when it comes to Java interview questions. So let's cover this in detail. To understand why we need equals and hashcode and what equals and hashcode is all about, let's first understand the object class of Java. Remember, I'm calling it an object class and not just an object. Object is a class as well in Java, and it is the super class of any class you create in Java. So anything you do in Java, any class you create, it will automatically be inherited by the object class. Object class is the super class of any class created in Java. And if you look at this documentation, and if you come here, you will see that object class defines this equals method, which indicates whether some other object is equal to this one or not. And it also defines a hashcode method, which returns a hashcode value for the object. So let's understand both of them one by one. First of all, let's establish that these methods have their concrete implementations available inside the object class. But how do you do that, and how does it come into effect? Remember when we talked about hashset, and I said that hashset will maintain uniqueness automatically. How does it maintain uniqueness automatically? It is because of the equals method implementation, which it inherits from the object class. That's how it maintains uniqueness. And if you remember, I also told that you can maintain uniqueness in a hash set if it's a built-in data type, like integer or string or float or double, etc. But what if you are trying to create a hash set of student objects? Then Java does not know how to perform equality on two student objects, because student is a custom object. Java doesn't know how to run equality. And that's where equals and hashcode comes into picture. So the contract is that whenever you are creating your own custom objects and you have a need to perform equality on those objects, you must override the equals method in your own class. You have to override that. If you do not override that, then two student objects will be compared based on the reference and not based on the actual object values. We will see all of that with the help of an example. Another thing which says that whenever you are overriding equals, you should also override hashcode method. Reason is because hashcode is also used in certain collections, and we will cover that in a while. But let's just focus on equals first. And let me switch back to the Eclipse IDE, where I have a student class. Again, it's a very familiar class which we have covered in other lectures as well. And I have three different properties here: roll number, name, and address. I have a constructor, and I have setters and getters. Now, if I go here and I create three different objects of the student class, you see I have created three different objects. This student object has a roll number 1, name John, and the address is the same one. Second object has a roll number 2 and the name John, and the address is the same as this one. And third one again has a different roll number, but the name and address is the same. It's a hypothetical situation. So let's do one thing. Let's make this roll number as 1 as well. So now these two student objects are exactly identical. So what happens if I compare John with John 2? By looking at naked eyes, these two objects look exactly the same. So John equals John 2 should return true. Let's run this program. But we get false. The reason we get false is because the default implementation of equals is being run on comparing the student objects, because Java still does not know how to equate these two objects. Why you are getting false? Because these two are different references. Java created a new memory location somewhere and put this object, created a reference John to it. Then Java created one more new object in this line and created a new reference John 2. So these two different references are pointing to two different memory locations of the objects. Though their internal values are same, but their memory locations are different. That's why you get this particular value as false, because these are pointing to two different memory locations. And that brings me to the hashcode contract. You need to override the hashcode contract as well, along with the equals, to make sure that your equality runs perfectly. Let's go back to the student class and let's fix this problem, because we can see that these are identical objects. You don't want to store the same student twice in your database, right? So you need to fix this. So I go back to the student.java and I have commented this equals method, and let me uncomment this now. So what I do, that I override the equals method, and the equals method contract looks like this, where you supply an object which is a foreign object. And now you need to compare this foreign object with your current object of the student class, which is this. So at first you need to run this particular condition, which says, are these two objects, these two references, this reference and the obj reference, pointing to the same object? If they're pointing to the same object, then this will return true. And then we will say that the object is that equality holds true, because both are pointing to the same object. So obj equals this. If that doesn't hold true, if this doesn't hold true, then it moves on to line 50 and it runs a condition saying that is obj null, or obj.get class is not equal to this.get class. Get class is a method which will tell you the class type. Here we are checking is the obj class object is of the type student or not. If it's of different type, let's say vehicle or something, then definitely they will not be equal and we can directly return false. So that's why I'm checking that it should not be null, or the class types should be matching. If these two conditions are, if either of these conditions are holding true, then I return false and I say that objects are not equal. So I've covered this condition where both of the references are pointing to the same object. I covered this condition where the class types were not matching or the obj itself was null. Then we return false. If we passed all of these sanity checks, then we do the actual comparison. Before doing the actual comparison, I need to do this explicit casting. So I cast the obj object into the student type. If you remember, this is how we did the casting for other data types as well. Once you have converted this obj into the student object, then you need to define your own business logic based on which you are going to define uniqueness. So how are you going to uniquely identify a student in your application will govern this logic. In this particular example, I'm saying that I am going to identify a unique student based on its roll number. So even if two students have exact same matching details, but if their roll numbers are different, then these are two different objects for me. But if two objects are having the same roll number, and even if they have a different name and address, I'm going to say that those two objects are duplicate. So roll number is the condition on which I'm defining uniqueness, equality, and duplicity. So I define this and say if the roll numbers are equal, then the object is equal. Objects are same basically, or duplicate. And if the roll numbers are different, then these two are different objects. Good so far? coming back to the main class. So now I have the same roll number here. Let me change the name just for fun and address as well. So I have a different name and a different address, but the roll number is exactly the same. Remember, we have defined the equality condition based on the roll number. And here we are comparing if John is equal to John 2 or not. So let's run this program. Now I get true. The reason I get true is because this equals method is used to run this equals comparison. So this establishes how we can use the equals contract to maintain uniqueness. Now I also said that whenever you are defining the equals method, you also have to override the hashcode method. And to understand why do we need hashcode as well, let's go back to how hashmap works. Remember, in the hashmap, or let's say even hash set, in the hash set you have to maintain uniqueness. Now Java maintains uniqueness using both equals and hashcode. Hashcode is nothing but a memory bucket in Java's memory where your object is stored. It's basically a memory location. So every object has a hashcode, and that hashcode is the actual memory footprint where the object is stored. And whenever you're dealing with hash set or hash maps, you will be required to override both of these methods. Let's understand how this works. So if you have a hash set and you are trying to insert an element, then first Java will use your equals method definition to check if an object similar to the object being inserted is already present in the hash set or not. If it finds an object, it will basically flag that this is a duplicate object and it will not insert it. Let's understand how an object is fetched from hash set. Let me open a hash set example just to give you some sort of a visual representation of what I'm talking about. So if I go to my hash set example in the collections package somewhere, and let's open a hash set demo class. Yeah. So when we were doing these insertions, though this was a string object, so the Java already knew how to use the equals and hash code of it. But if it was a student object and you were doing multiple add, and then when you were actually fetching the element or you were doing the contains, then how does it work is basically first it is going to calculate the hash code of the object. Let's say you are saying hashset.get b or hashset.get John1. Then it is going to calculate the hash code of your John1 object. Hash code is your memory footprint, and hash code, and the way it is going to calculate the hash code is going to be based on the definition which you have provided. So the definition which you have provided, this hash code will be run to calculate the memory footprint, and then that particular Java will go to that particular memory footprint and see if there is an object present there or not. Now Java has a memory location, right? And there can be multiple objects stored at that particular memory location. This is possible in Java. So if there are multiple objects present in that particular memory location, which was calculated based on your hashcode implementation, then Java is going to run the equals method to find the exact matching object. So just to try to visualize this, if I try to visualize this, let's say you have this memory locations, and let's say your hash code came up to memory location 2, and then at 2 memory location you had multiple objects, obj1, obj2, obj3, etc. This is possible. Multiple objects can point to the same memory location. So if this happens, then Java is going to use the equals contract to compare your John1 object with obj1, with obj2, and with obj3. This is where the equals will come into use. So you see that both hash code and equals are being used here to point to the right memory location. And that's why I said that hash set and hash maps are where equals and hash code will come in full force, where you will be required to implement this. And it's a good practice to always override the equals and hash code in your application whenever you are creating classes. The reason is that you don't know when and where these classes will be stored into a hash set collection or a hash map collection. So it's always a good idea to have equals and hash code being implemented. And when you implement hash code, The thumb rule is that you should use the same parameters which have been used in the equals contract in the hashcode contract as well. The reason for that is, what if you used here, let's say you used name here and you used roll number here, then two different properties are being used to find memory location and the uniqueness. And remember this logic which I just gave you. Here both hashcode and equals are working together to find the right object. So if you make any mistakes in defining the equals and hashcode, or if you made any mistake in defining the symmetry between equals and hashcode, then you may get unpredictable results. How you define your hashcode? Up to you. But make sure to use the same properties which you have used to define the equality. Always keep this consistent to avoid any unexpected results. You can also do this, just say return 1. And what will happen that when you use this particular student class in a hash set, all the objects are going to be stored at a single memory location. And then this particular situation will occur where you will have a single memory location and all of your objects will be present at that memory location. And when you are trying to fetch anything, the hash code will always point to the same memory location, and then equals will make sure to find out the right object you are trying to fetch from the hash set. So this is all about equals and hash code, which I wanted to cover in this particular lecture. Do read about this in detail. There are tons of articles available on this particular concept because this is a very important and popular concept, both from implementation perspective and from interview perspective. And that's all we are going to cover in this particular session. Let's get started with comparable in Java. And before we go there, let's understand why do we need comparable. The need for comparable comes from the requirement whenever you have to sort your collections. So to understand that, let's move over to the Java docs to understand how this works. So the basic idea is that you want to sort your collection, and to do that, Java provides you with a method called collections.sort. You just supply your list or your collection inside the sort method, and all the elements or objects inside your collection will be sorted based on the natural sorted ordering. This holds true for built-in data types, but what if your list is of type student objects? Then again, the same constraint applies that Java does not know how to sort student objects. It knows how to sort strings and ints and floats and doubles because those are built-in data types, but student is a custom type and Java doesn't know how to sort it. And to solve that problem, Java provides an interface called comparable. So comparable is the interface which you need to implement from your class whenever you have a need to sort your objects or of your class type. So this is the interface which your class needs to implement. This interface provides a single method which says compare to, and it provides the foreign object, and then you need to compare this foreign object with your current object. So let's go back to the Java class and understand how do we work with this comparable interface. So again, I have used the student class for the sake of continuity, and I have the same properties as roll number, name, and age. But this time I say implements comparable of type student. This is a generics type. We will be covering generics in a bit more detail in this whole series. But the basic idea is that you define that this comparable interface will only work for student types. You define the type in this particular construct, which we also call as generic type. So you do this, and the moment you do this, Java will force you to provide the implementation of the compare to method, which I have provided here. So the way this implementation works is you have a foreign object here, but this time this foreign object, since I have defined this as of type student, so the moment you do this, Java will ask you to override this method, and using Eclipse IDE, if you override this, then you will get this signature automatically. Let me show you this how this works. So if you do this, you will get an error here, and if you click on this balloon, it will say add unimplemented methods. If you double click on this, you will see a compare to implementation here. And this is exactly the skeleton which you see here. By default, it says return 0, but I'll just come back to that in a while. So this is how this method came up here. And once you have this signature available, then you need to provide your implementation on how do you want to sort the objects. Remember, you need to define your logic here. So again, I would like to sort my students based on the roll number, which is the natural sorting order for me for the student objects. So this is your custom sorting logic, which you can call as natural custom logic sorting order for your student objects. So I want to sort them based on roll number, but you see, I've done a strange thing here. I've done a minus here. So what I'm doing is that the current object's roll number minus the foreign object's roll number. So if this value comes as a positive number, then this object is going to take priority. This is going to be sitting before the student. If this result returns in a negative value, then this object will come first and this will come second. So the student object will come first and this object, the current object, will come second. And if this returns 0, then it means both of the objects deserve the same priority or the same order priority, and any one of them can come after the other. So the basic idea is that if this results in greater than 0, then the current object is going to take precedence. If this is going to return in a negative value, then the foreign object which you're supplying here is going to take precedence. And if this returns in 0, then any one of them can take precedence. So you need to define your compare to logic in the compare to override implementation. Once you have done that, let's understand this with the help of an example. I've created a comparable demo class which has a public static void main method, and I create an array list and I create 3 different student objects. First student object is named as John, second is Jane, and third is Tom. The first has a roll number of 3. So John has a roll number of 3, Jane has a roll number of 1, and Tom has a roll number of 2. So if my compare to logic runs perfectly, then Jane should be coming first after I sort this collection, after I add these 3 elements into my list. And once I sort this collection, then Jane should come first, Tom should come second, and John should come third, based on my natural ordering custom logic, which I have implemented in the compare to method. And that's what I'm doing here. After I've sorted the list, I'm just printing the list by using the ForEach construct of the Streams API. I'm just printing the name to see which one comes first and which one comes second. So let's run this program. And this is how it looks like. So Jane comes first because she had a roll number 1. Tom came second because he had a roll number 2. And John came third because his roll number was 3. So no matter how many times you run this program, you're going to get the collection in the same sorted sequence. And this is happening because of the compare to implementation which you provided here. Now, if you comment this implementation, let's see what happens. And I remove this implements comparable as well from here. I just create a simple student class and now I try to run this sort. Now you see that you get an error here. And if you hover over this balloon, it says that the method sort in the type collection is not applicable to the argument array list of student. Java does not know how to sort this. So it will force you to provide a sorted implementation. And the moment you provide comparable implementation here, and if you go back to the main class, the error is gone. So this also will force you to provide your comparable implementation. Now you can use this sorting for any kind of collection sorting as well. And whenever you are doing this, always make sure to provide the compare to implementation. And remember that contract which I gave you about greater than 0, less than 0, and equal. And that's all I'm going to cover in this particular session. Let's get started with comparators in Java. In the previous session, we talked about comparable, where we said that whenever we want to implement a naturally occurring sorting order, where you just say collection.sort and you sit back and relax, if you have provided the compare to implementation, you would expect things to work. But what if you have a custom sorting requirement? Let's take a hypothetical scenario where you created an application and your application has a student object and you created a collection of student objects, and now you have different consumer applications. Let's say you have a payroll application, you have a attendance system, you have an examination system, you have another extracurricular activity system, and all of them want to get the student collection, but all of them have different sorting requirements. Payroll wants to have the sorting based on the roll number. Attendance want to have the sorting on some other mechanism. Extracurricular application want to have the sorting on some other mechanism. So how do you implement custom sorting or multiple sorting logics for your collection? And that's where comparators comes into picture. Comparator is again an interface, as you can see here in the signature. And this interface provides you the flexibility to define your own custom sorting logic multiple times. So you can create multiple comparator implementations, and each comparator implementation will focus on a particular sorting order. So that's the basic need of sorting. So remember, whenever you want to sort the object in an order other than natural ordering, or you want to sort some object that don't implement comparable. So whenever you have these kind of conditions, always think of comparator. Apart from that, always think of comparator when you have to provide multiple sorting implementations on the same collection. So let's see how can we do that with the help of an example. So here again, I have the same student class and I have the same properties. Currently, by default, I have provided a comparable student implementation, which is exactly the same as we covered in the last session. And if we use this particular implementation, we create an array list, we created multiple student objects, we added them to the list, and we called sort. So what happens if I just comment the new code, and if I just run this particular code, remember the sorting is happening on the roll number. So here, roll number 1, Jane will come first, roll number 2, Tom will come second, and roll number 3, John will come third. But then you had one more application which wanted to have the sorting based on the age of the student. So these are the age values of the students, and some application wants you to provide the sorting implementation for the age. Now, age is a custom sorting logic which you need to provide. And whenever you have that kind of situation, create a comparator. How do you create a comparator? Like this. Simply create a class, name your comparator anything, try to end it with the suffix comparator so that you know that this is a comparator implementation. And then you say implements comparator of the class type. This is what you need to do. And the moment you do this, it will force you to override this compare method. Remember, the comparable interface provided compare to method where you supplied just the foreign object. Its name was compare to with single object. In comparator, the name is just compare, and you have two objects here, student 1 and student 2. Let me just call them student 1 and student 2 for simplicity. O1 and O2 look a bit weird. So I've just refactored this one, and I will refactor this one as well. So I have student 1 and student 2, and this is an age comparator. So I want to apply the sorting logic based on age. Simply put, whoever is younger should come first, and whoever is older should come later in the collection once I sort it. So let's see how this sorting logic is implemented. This is a single line code, so let me just put braces around it so that it's more easily readable. You can write it without braces as well if you have a single statement inside the if block or else block, but you can always write it like this. And let me just format this as well. Okay, so this is the compare implementation. The first logic which I've run which says that if the first student's age is less than the second student's age, then return -1. Similarly, if the first student's age is greater than the second student age, then return +1. And if both of the students' age are same, then return 0. So this is your custom logic, and this is where you need to define your logic. And remember, this will also govern whether the sorting is going to be ascending or descending. So for example, if you have provided that student 1's age is less than student 2's age, then return -1, then this is going to maintain the natural sorting or the ascending order sorting. Now, if you want to have a descending order sorting, just change these values, saying that if this is less, then return 1, and if it is greater, then return -1. And this is going to run the sorting in a descending order fashion now. So it depends upon what kind of sorting order you want, and based on that, you can define the values. But the default is always like this, that whenever the first object's value is less than the second object value, return -1. And if the first object's value is greater than the second object's value, then return +1, otherwise return 0. -1 means this one will get precedence over this one. So this is how you have provided your age comparator. Going back to the main class and uncommenting the other part of the code, here I have called the sort method where I want to sort the list. But since I want to supply a custom sorting operator or a custom sorting comparator here, I need to provide that comparator object here. So remember the age comparator which you created here? You just need to provide the comparator. You need to tell Java how to sort this particular list. If you do not tell Java how to sort this, Java is going to look for the comparable implementation in the student class, and it will sort the student objects based on the compare2 implementation provided inside the student class. But if you want to have more custom control over sorting, then you need to tell Java how to do that sorting. And if you see, this is an overloaded representation. This is a method overloading example as well, where the method signature is same, but just the number of arguments are different. So this is how you provide your custom sorting. You supply your comparator. Now you can create multiple comparators. You can create another comparator based on, let's say, name. You can have one more property here, create one more comparator. So you can have as many comparators as you want. Just keep creating them and keep supplying them individually one by one in the sort method. You can just duplicate this and add one more comparator. So this is how you are going to have more control. And if you have multiple consumer application, call multiple sort methods, supply their corresponding comparator, and you will get the sorted collection. So here I'm just printing the list based on the age comparator sorting. And these are the objects. So let's see how this works. And understand the output from the beginning. So the natural sorting order is something which we have already covered, which was done based on the roll numbers. So Jane comes first, Tom comes second, and John comes third. And this is how you get this particular output. Now coming to the age comparator, you print this particular statement, which is coming here, and then you print these values. So let's see how the age comparator is working. The youngest here is John. So John comes first. Then we have Tom, who is 20 years old. So Tom comes here. And then we have Jane, who is 21 years old, and Jane comes in the last. So we can see that our age comparator has fired here, and it has sorted this in an ascending order. Now let's flip the values. I'm going to change the values here, and now it should work in a descending sorting order for the age comparator. So let's run this application again, and now you see Jane comes first, who is 21, then Tom comes, who is 20, and then John comes, who is 18. So now the age comparator is working in a descending order. So this is all I want to cover in this particular session, and in the next session we are going to have a look at a project which will cover all the concepts which we have talked about so far. Let's get started with walking through a particular project using all the concepts which we have learned so far. So in this session, we are going to focus on a particular project, and the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hashmap class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to pin mapping. So we create a map, and inside the get login method, we add couple of entries to the map. Here, the first entry, the first integer, is pointing to the customer number, and the second integer is pointing to the PIN of the account of this particular customer number. So if we call the get login method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called set customer number. Again, I will come back to that. And once we have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks. But things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here, which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here. Based on the customer types 1, 2, 3, or 4, the corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called. and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund. And for that also, I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes, where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input, which will be used at multiple places. And then I have the setters and getters for these 4 member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have set that, we were fetching the values using the get customer number and the get PIN number. And that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these 2 methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have 2 methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have 2 more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined 4 calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit, basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input, and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class, And if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these 4 calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line, the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the get login method. Remember, get login was the first method which asked you to provide the customer number, and then get login called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the getChecking method. And the getChecking method again provides you with another menu, view, withdraw, or deposit or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option because inside the getChecking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class. And this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw. So I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100 and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calcchecking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here getChecking withdraw input got called. Here, this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise, your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application. And this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept. Let's get started with walking through a core Java project using all the different OOPS concept we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. we are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into two different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into two different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do this exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll, and this time the numbers.poll is going to pick up 3. So 3 will be picked up here, and then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2 and whatever value it gets, it is going to store a value back into the rest variable, and then it is again going to go back here and again going to check the condition if the numbers queue is not empty. But now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action, and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through, because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27, and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression. And whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So that's all I want to cover in this particular session. If you like this video, a thumbs up will be massively appreciated. Thank you, and we'll meet again in the next session.
Thanks a lot, Vikesh, for being with us and helping us to learn the fundamentals of core Java. Hope this session was interesting and informative. If you have any queries regarding the topics covered in this session, or if you wish to get the codes executed in this particular tutorial, or if you feel we missed out something important, then please let us know in the comment section below. Our team of experts will be happy to respond. Until next time, thank you, stay safe and keep learning.